Well, hello to everybody. So we're going to talk a little bit about this Android ecosystem for this video. So we'll start without wasting any more time because we got to get to it. We got a lot of good stuff to do. All right, be quiet and tell me. You betcha. Android is an operating system designed for use on mobile devices. The Android operating system was originally created for use in digital cameras. Bet you didn't know that, did you? So the Android operating system is developed primarily for use now on smartphones and touch tablets by Android and Google. Google bought the Android company in 2005, and the Android operating system was released in 2008. Although Android is developed for smartphones and tablets, today it's still being used in Android televisions, smartwatches, Android Auto, and Android Wear devices. Android Auto is the car smart multimedia system, in case you weren't aware. So, Android operating system is used in more than 100 languages today. That's 5.22 billion people who are using a mobile phone today. And that equates to 66.6% of the world's total population. Also, more than 2 billion people use the Android operating system as of May 2017. Google Play has more than 2.8 million applications published, and more than 6,000 applications are published on Google Play every day. More than 20 million application developers will be needed in the next few years. Yeah, I'm looking at you, right? So this means that you need to learn this Android application development really, well, I'd say kind of quickly, but thoroughly, but quickly. So I believe this course is going to be really good for your process, okay? So after this course, you will be a very good Android application developer. All right, well, at least a good one. Anyway, let's get going. So another motivation factor, let's talk a little bit about salary. I know you wonder how much your salary is going to be. Well, I'll let you in on a little thing here. Junior Android developer salaries are more than $55,000 per year in the U.S., but I believe you're going to make more. Middle-level Android developer salaries, more than $100,000. Senior-level Android developer salaries is about $130,000 US dollars per annum, as they say. So this chapter was just to give you some, general information about the Android ecosystem. Hope it was useful. After this video, we're going to start to install Android Studio. If you're ready, let's go. Well, hello, friends. So in this lesson, we're going to download the interface that we're going to use to develop an Android mobile application. It's called Android Studio. Then we're going to do the necessary setup, okay? So Android Studio is completely free. It can be downloaded and used by anyone and everyone. And you know what? Without any further ado, let's just get started to download Android Studio right this very moment. So first, we'll go to our favorite browser, and in the search field, just type in Android Studio Download. Press Enter. Okay, so here you'll see the second result. In my case, Download Android Studio and SDK Tools site. So if you notice, my friends, this site here is developer.android.com. So this site is a particular site that Android developers must follow, okay? So you can follow latest Android developments, updates, documentation required for application development, and everything else they want to talk about. So yeah, we can continue with the download right now. Now, in its current version, as you see, of Android Studio, it's available. And now I do have to mention here that Android Studio is continually updating itself. So the most recent version shooting this video is 4.1.1. So this version may be a little different for you depending upon when you're doing it, but Android Studio's download and installation processes are always the same. So even if you do see a different version here, have no fear, my dear. you can download and install by following the steps that I'm going to explain. Okay? So if your computer's operating system is 64-bit, you can start the download just by clicking the Download Android Studio button right here. Now, I do want to point something out to you. If you don't happen to know your computer's operating system, just find out, like I'll show you here. So just click on the Windows icon in the lower left corner, open up the computer application, and see the window that opens. Select this PC. It's this tab on the left, and right-click with the mouse. Now, when you select the Properties option at the bottom of the window that opens, the window containing the basic properties of the computer will open. All right. So from this window, you can find out your operating system, how many bits it runs at, etc., etc. All right, so let's go back and continue from where we left off. So if your computer's operating system is not Windows, you can click the Download Options tab right here on the left. And when we click on this tab, we can see the download links for Windows 64-bit, Mac 64-bit, and Linux 64-bit. So these are the operating systems. Now, please note that such an option does not appear for 32-bit operating systems because Android Studio does not support 32-bit operating systems since Android Studio 4.0. All right? Now, if your operating system happens to be 32-bit, go ahead and download Android Studio 3.6.3. All right, that's the last version of Android Studio before version 4.0. So for this, you can click the Download Archives link just right in here. And from the window that opens, need to accept the relevant contract terms. So I'll just click on I'll agree. And as you can see, we've already accessed all the versions of Android Studio. So here you can find 3.6.3 and use the download link required for 32-bit operating systems. All right, my friends, we can all work together. All right, so let's go ahead and start the download process. So I'll open up my previous page since the operating system of my computer is Windows 64-bit. I'll download the appropriate Android Studio, and here I'll click on the file with the .exe extension, right? So we need to accept the terms of the contract required to download Android Studio. Then after confirming with this checkbox here, the button that we'll use to download Android Studio becomes active. So that means that when we click on this button, the download process is going to start. So I'm going to go ahead and click. And as you see, the download process has started for me. Of course, this download might take a little longer for you depending upon where you are and your internet speed and bandwidth. So I'm going to just speed up this part. Okay, so now that the download's complete, I'll click the arrow icon to the right of the file that I downloaded and choose the Show in Folder option. So this way we can view the file that we downloaded. So I'll double-click this file. And here, Windows is giving me a warning. Do you really want to run this file? Well, I'm clicking the Run option because, yeah. So the warning might not have appeared for you. It's not necessarily important. So the setup screen opens, and from here, I can just press the next button. Press the next button again. All right, so now here is the location where the files will be saved. You can, of course, change this location, or you can remain in default. And I'll just, you know what? In fact, I usually prefer the default file path. That way I don't have to remember anything. Okay, so just press Next and one more time without making any changes. All right, so here it's going to ask if we can create shortcuts for Android Studio. Now, I do want it to create a shortcut. You might not want to create a shortcut, but you do have to confirm with this checkbox here. And again, I will not make any changes. And now we can start the setup process. So by clicking the Install button here, This is going to start the installation process, and I'll press the install button. And what you're seeing here is the starting of the installation process, okay? So the process is going to take a little time, so I'll speed up this. All right, my friends, installation is now complete, so I'll press the next button, and it states that the installation process of Android Studio is now complete. If we want Android Studio to be started after the installation process, we will need to check this box. So I uncheck it and start Android Studio together. All right, I press the finish button, and that completes the necessary setup. So we'll take a short break here, and in the next tutorial, we're going to examine Android Studio's interface. So I'll see you in the next lesson. Well, hello, friends. In our previous lesson, we downloaded Android Studio onto our computers, set it up, but the installation process is not yet completely finished. So in this lesson, we're going to complete the SDK setups. And we'll also examine in detail how to create a project in Android Studio. So let's get started. All right, first we'll find the application called Android Studio, and that's the one that we downloaded from the search bar. Now, by typing Android Studio right here, we can find the application that we downloaded. Easy as that. And there's the app. So now I'll just click on the Open option. And now that opens the application. As you can see, a window like Android Studio Setup Wizard opens. Now we can start the setup. So I'll press the next button. And right here, we'll come across two different options: standard installation, custom installation. Now you can select the standard setup here and complete the necessary setup procedures. But I want to show you all the steps in the setup phase. So I'm going to choose the custom option just so that you are aware of it. So I'll press next again. And on this page, it asks us to select the JDK. And that means Java Development Kit and where it's going to be located. So at this stage, it's pretty useful to explain what the JDK is. It is indeed the developer kit developed by Oracle, the founder of Java, in order to develop Java programming language applications using Android Studio. Now, of course, this kit comes embedded with Android Studio, so we don't need to install JDK separately. And that's why we choose the embedded JDK option here. So we can press the next button again. And here, too, we can choose the background color of the interface that we will encode. There are two different options: Darkula and Light. I usually prefer the light mode. You can also change these settings later. Now I'll press the next button again. Now on this page, we will do the necessary steps for SDK. And that basically means Software Development Kit. And here's where we install it. Now you can see there are three different options here: Android SDK Platform, Performance, and Android Virtual Device. So it's worth noting at this point that we can test the applications that we make in Android Studio on virtual devices offered to us by Android Studio. So the settings here are generally related to the performance of this virtual device. And I just suggest you choose all the options here. Otherwise, you may run into some problems later on, but that's why I generally choose all three options. Now, just below, we'll need to specify the SDK location. And of course, I generally use default locations. But of course, you can save it to any folder that you want. And I'll press the next button again. And on this page for the emulator, we can adjust the RAM size that we're going to give to it. In general, we can always use the size suggested here. And then while your emulator is running, the size that you set will be used from your RAM. Of course, when you turn off the emulator, your RAM continues to run at the size before it started. All right. So without changing anything, I'll just click the next button. So this page also lists the settings that we've made so far. And if there's any setting that you want to change, you can always return to the pages where we made the relevant settings just by pressing previous. And if you don't make any changes, if you can just confirm all the settings. And that completes the installation when you click the Finish button. All right, so yeah, the download starts. And again, the process may take a little while. So I'm going to just jump ahead, and then we'll continue where we left off. Okay, so now the installation's complete. I just press the Finish button. And now, what you see here is creating a new project in Android Studio or opening an existing project. So more precisely, this will be the first screen that we see whenever we open the Android Studio. Now we can create a new project. So I'll choose a Create New Project option here. And then from this page, we'll choose a template for the Android project that we're going to create. So first, let's have a look at the different tabs here. And as you know, Android operating system is used not only in phones and tablets, but also in watches, televisions, cars, and many other things out there. So if you want your application to work on whatever type of device you want your application to work on, you need to choose a template suitable for the device in question. Now, of course, since we will develop applications for tablets and phones, we're going to use the Phone and Tablet tab. And certainly there are many different templates under this tab. Android Studio offers us some ready-made templates so that we can, get some faster results when you're creating projects. For example, we're going to make an application related to Google Maps, so we can make use of this template here. Now, oftentimes we'll choose a blank template. And if you notice, there's an expression here called empty activity. So we're going to hear the concept of activity very often from now on, because in Android, the software part and the interface of design that's shown to the users is the activity. All right. You might be a little unfamiliar with the concepts right now, but as we move along throughout our lessons, we're going to examine each of the concepts in detail. But just stick with me for now and choose the empty activity option and press the next button. From this page it opens, we will configure the project that we will create. So in other words, we'll determine the name and the programming language of our project right here on this page. So let's make some of those definitions. So I'm going to name my project first up. And you can type in any name that you want, but at the same time, I think that the name that you write here will be the name of your application, don't you? For now, I'll just write first project because I also want it to be very clear what it is. And the second field is where we set the package name of our project. You can think of the package name as your application ID, right? So generally the project package names are created as com.anything.application names. So if you leave it as this example, you wouldn't be able to publish your application on Google Play because Google accepts the phrase, the example, as, well, sample work, and it doesn't allow it to be published on Google Play. So therefore, if you work for a company or, well, even if you're just a private developer, you can enter specific phrases, right? Such as your company name or even your own, last name or whatever. I'm just going to leave it as example for now. because I'm not going to be publishing this anywhere. Now, the third part here is the file path, and this is where our project will be saved. So as always, you can save your project in any folder on your computer. But notice, though, that there are / and project names at the end of the file path. So if you change the file path, just be sure to add the / and project name to the end of the new file path. Otherwise, you won't be able to save your project. Cool? So in the fourth part, we have to choose the programming language that we will use in our project. We will build our applications using Java. So I'll choose Java. Now the fifth section is minimum SDK. So in other words, if we want our applications to run on Android, we can determine it from this section. As you know, Android is continually releasing new versions like Android 9, Android 10, 11. So from this section, we can determine the minimum Android level at which our application will run. For example, if we choose Android 8, well, the application will work on Android 8, Android 9, Android 10, and 11, right? So it's 8 and up. So the version you choose refers to the minimum Android version that it's going to work on. Notice that when I choose any version, Android Studio tells us right here below what percentage of Android devices this application will run on. It's always useful info. So if you're going to publish your app on the Play Store, you can choose a low Android version from this section. Of course, at this point, I should also mention the following. Since some codes are updated in every new version of Android, choosing the lowest Android version can sometimes cause you problems. Therefore, yes, there is another option. I generally choose API 17 as my level. Now, of course, we can change all these settings later, my friends, but I want to show you where they are. But since we are doing some sample projects, for now, you can just choose any version. So finally, a checkbox has been created here, and we'll be able to use the Android support library, which is Android's old library. So we're not going to choose this option because we are going to use the Android X library. And this is the current library of Android. And we're going to be using this in our projects as we continue. So now we'll be able to create our first project just by clicking the Finish button. And depending upon what sort of computer and what horsepower it's got, it might take a little while to create your first project. It is all related, but it's all good. If you have a pretty fast computer, you can create your project course in a shorter period of time. You may encounter an assistant like this when any innovation or update is made in Android Studio. So you can review this document. You can also close this window by clicking the Assistant tab here. Now, in the lower right part of the interface, we'll see an expression regarding the process of creating the first project. So here, we shouldn't take any action before seeing the project is completed. Otherwise, you may encounter some problems in your project, right? So again, opening the Build tab here, we can see if the project has completed. So when the project's completed, or if there are any errors that it encounters, you can see these operations from this section here. So the process of creating the project, like I said, may take some time. That's why I'm going to just stop the screen recording at this point. And when the project completes, we'll continue where we left off. All right, my friends, as you can see, our project's been created. So far, we have set up Android Studio, created our first project. So we'll take a short break here, and in the next lesson, we're going to examine the interface of Android Studio. So I'll see you in the next lesson. Well, hello, friends. So now that we've completed the installation of Android Studio in our previous lesson, now we'll be able to examine the interface of Android Studio. So I'm sure that you're ready, so let's get started. So after creating our first project, we encountered a screen like this. So at this point, I would like to remind you once again, after making sure that your project has been completely loaded in the build section, you should do the necessary action. So if your project has not been uploaded, you can wait for the project to be fully loaded without any further action. All right, so after making this reminder, now we can examine Android Studio's interface. So we can basically examine the interface in 4 parts. The first part is the part where we do the coding and make the necessary designs for our projects. Now you're going to see it better if we close the build window here. And if you notice, there are 2 tabs here. The first is the main activity.java, which we will use to write our Java code. And the second is the activity main.xml file that we can design for our projects. Now, while developing an Android application, we'll first create the design of the application that we'll do, and then we make the necessary coding for the design. Actually, this is the part where we will use as a basis, right? So for now, you just need to know this preliminary information. So after examining other parts of the interface, we will examine this part in detail. Now the section on the left over here is the section where the project files are located. If you see this part differently, you can click on the part, type Android above, and here you may have project instead of Android. You can select the Android option from the pop-up menu. So when we create a project in Android Studio also creates many different files related to our project for us. Thus, we have the opportunity to run our project on different platforms or share it with different people, publish our project. So if the project is selected instead of Android, we will be viewing all the project files that are and have been created here. Of course, this creates a complex view because we will not be able to use every file created. So for a simpler view, let's make sure that this Android option is selected. Now, when we examine the project directory here, a new folder has been created under a Java folder with the package name we determined while creating the project, right? And just below the package folder, the Java class, that is main activity, has been created. So while developing an Android application, we will make applications that will require more than one class. So this stage, the Java classes that we will create will appear here. And of course, we also mentioned the design file. So you might ask, where's the design file, right? Well, if you look a little below the project directory in here, you will see that a folder named res has been created. Now, it's actually the resource folder. It's a folder where design files, images, colors, text styles, and themes related to our project are going to be kept. Don't worry, we'll get to examine them in detail in our upcoming lessons. But I want to tell you that there is also the design file of our application in the layout folder here. So if you close the main activity.java and activity main.xml file, just by closing or pressing the X icon right next to the tabs here, you can open them again from the project directory. So if you double click on these files right here in the project panel, you can open them again. We can also shrink and expand the part reserved for the project directory. For this, you can position your mouse on the line between the project panel and the main panel. Now, if you notice that the cursor changes, so you can drag it left or right to expand or collapse the project panel. You can also completely close and then open your project panel. For that, you can minimize, see the minimize icon here. And if you want to open the project panel again, you can click on the project tab here. All right, so there's the project panel. That's how it works. Now let's have a look at the toolbar window at the top of the interface. Of course, there are many tabs up in here. From the File tab, there's a Help tab, and you see that in many interfaces. So first, let's have a look at the File tab. As you can see, there are many features in here. We're mainly going to examine the features that we're going to be using during the course. We'll examine some of the other features as needed. But first, you can create a new project by using the New and New Project options here. And then by using the Open button, you can open a project that you have created and saved previously. You can also close your open project by using the Close Project option. And there is a settings option here to make some necessary settings for Android Studio. So my friends who are using a Mac can click on Android Studio tab to the left of the File tab and select Preferences on the pop-up menu. So why don't we open up the settings screen now, and you can search the feature that you want right here in the search bar. For example, the size of the text in the area that we will be coding, I think it's quite small. So I'm just going to increase the size of the font, and that way you'll be able to see it better. All right, maybe me. So when I write font, the related features come up, right? So in order to change the required properties, I'll first delete the font text from the search bar, and then the relevant fields become active. So you can change the font in the font section here. You can also increase the size of text from the size option just below. I'm going to make it 18. And as you see, the text becomes much more legible. Now, naturally, you don't have to do this step, but I'm going to do it this way so that you can see it better. All right, so let's take a look at another feature. So I'll type in theme in the search bar. So by using this feature, you can change the interface to dark mode or light mode. Okay, so let's finally examine the SDK section and finish the settings section. So I'll write SDK into the search bar. And here you can see the SDK location. There are also 3 tabs just below. The first is SDK platforms. Now, if there was any sort of a problem during your installation, well, we could always download the SDK that we need from here. As you can see, here's a statement that it is indeed installed. Now, if you also write another statement, you should check the checkbox here and press the Apply button here. And that way you will reinstall SDK. So I'll open up the second tab, the SDK Tools tab. And what you're looking at is there are 4 tools installed. If any one of them is missing, that is, if it doesn't happen to be installed, you should check the checkbox here and press the Apply button. So we can also install Google Play services and USB driver tools here. That way you can test your projects on your personal Android device instead of testing them on the emulator. So you can also install these tools if you want. So for this, I'll tick the checkboxes here and press the Apply button. So when you click on the OK button, the necessary installation processes begin. And as you can see, my friends, if you encounter any errors during the installation process, if the necessary tools are not installed properly, whatever, you can always use this settings section to complete your installation. All right, so now the download process is over, and I'll press the finish button. And yeah, so that's what you can do in the settings section. Now let's have a look at the other tabs that we're going to be using. So I want to show you the View tab. You can use this tab to toggle many views of the interface. For example, using the tool window, it's the tab right here. We can open and close the tools on the edges of the interface. And again, from the appearance section here, you can select which tools you want to appear in the interface. For example, if we select the toolbar from here, the icons for saving the project, opening an existing project, or reloading the project appear in the interface. So I'm going to undo this because that finishes what's under the View tab. So we're not going to really use the other tabs very much, but we will use the tabs that need to be used in our progressing lessons. So that's why I want to show you what's under the Build tab here. So sometimes after the project has been created, a number of errors can occur. So in this case, you might need to rebuild your project. So to rebuild a project, you can use the Rebuild Project tab here. You can rebuild your project from here. And but don't worry, I'm going to explain this section in the tutorial where we will install the emulator. All right. So don't get too carried away. So why don't we go ahead and examine a little bit of the design area. So for this, I want to open the activity main.xml file. So let's just close the project panel, and you'll be able to see it more easily. All right, that's better. So you can also zoom in on the design area just by pressing the plus icon here. All right. So now we are focusing on the design area. And again, the design area incorporates 4 different sections. The first is the palette section on the upper left over here. And these are the components that we will use while we are designing. For example, we'll access many components such as buttons, text views where we can write text, and image view components where we can add images. We'll be able to see their use in detail, of course, in the next lessons. I'm just giving you a general overview at the moment. So we can drag and drop any of these components here into the design area. Notice that the design area looks like a phone screen. In fact, if you click on the eye icon here and select the Show System UI option, you'll get a real Android phone screen. Right, so that's what you could do in the design area. Let's activate the Show System UI option again. So in previous versions of Android Studio, Show Layout Decoration was used instead of Show System UI. So hopefully that's not too confusing, but now you know. And that's how you make your designs better. So let's just delete the text view component where Hello World is written. And to do that, just click on the component, hit delete, right? And now to undo this, I can press Control or Command Z for Mac from the keyboard. I'll zoom in a little bit. And another way to delete any component after selecting the component, you can right-click with your mouse, and then from the options that appear, select the Delete option. And to undo this, I'll press Control or Command Z for Mac from the keyboard. Now, finally, you can select and delete the component from the Component Tree section. So that's the second part of the design area. Again, to add components to the design area, you can drag and drop the component you select from the palette section into the component tree section. And component tree is a section where the components that we use in the design area are going to be located. So we can choose the components from the design area, or we can select them from the component tree and change any properties that we want to change. We could change the properties of components in the attributes section as well, located on the far right. Now, in order to change any property of a component, for example, the text size or color, after selecting the component from the design area or the component tree, we can find the feature that we want in the attribute section and make those changes happen. And again, not to worry, we'll do all of these procedures in detail later on. But I do want to draw your attention to this. Notice that the design file is actually a .xml file. So in other words, XML code is actually created for all the components that we're going to be using while designing, as well as the properties of these components. For example, to add a button to the design area, we can either drag and drop the button from the palette or create it by typing XML code. And for this, we can open the split or code tabs in the upper right corner. And if we open the code section, we will only see the section where XML codes are written. If we open the split section, we can see both XML and design. Now you can also open the component tree and palette if you want. If you open the design tab, you can only see the design area. Now pay attention to this. The XML code of the button that we created, do you see how it's created automatically? So in our next lessons, we will learn to create components using XML code. All right. So my friends, the interface of Android Studio tour is now complete. Now I've shown you the sections that we'll use most frequently in the upcoming lessons. So we're going to learn these 3 sections in pretty good detail. But before we end here, I should also mention that since Android Studio is constantly improving yourself, you may see some differences in the interfaces in our next lessons. For example, the code and design section here was at the bottom left in previous versions, and this split option wasn't even available. So you may see slight differences in the interface like this. Not a big deal. If there is an update about coding, we will update our related course as soon as we can. All right. So now we can end our lesson, and I want to see in the next lesson where we're going to create an emulator, or what's often called an Android virtual device. So we'll take a short break here, and I want to see you in the next lesson. Well, hello, friends. So we examined the interface of Android Studio in our previous lesson. So in this lesson, we will install the Android virtual device, and this is going to be the emulator that will allow us to test the applications that we're going to make. So once you're ready, let's get started. First off, let's just delete the text view and the button components from the design area that we created in the previous lesson. And to do that, I'll select the 2 components from the component tree section and press delete, which is right here on the keyboard. Okay, so my design area is now clear. So before starting the emulator setup, I would like to give you a little bit of extra information just about how to open and close a project, or how to close and open a project, or how to open a new project, how to open a previously created project, in fact. So in order to close an open project in Android Studio, just first click on the File tab in the upper left corner of the interface. So it's here right now, and then you just click on the Close Project option from the menu that opens. So if you follow these steps, you can close a project that's open in Android Studio. So after you close a project, you'll be able to see the start screen of Android Studio. Of course, if your goal is to create a new project, you should just select the Create New Project option from here. We learned how to create a new project in Android Studio in the setup lessons earlier. So for now, the section that you see on the left is the section where projects that you have created before are listed. If a project you've done before appears in this area, you can just open your project by clicking on the project. And if the project you want to open does not appear in this area, the second way you can do that is select Open an Existing Project option from here. So you can, of course, open any project on your computer. This is where you're going to need to know the file path where your project was saved, should you not use the default option. So we had to specify the folder where the files will be saved earlier when we created our first project. Now, your projects are saved to the file path that you specified. If you happen to know where your project's been saved at this stage, you will just need to access the folder with your project. As you can see, I got access to the first project that we created, the first project file. Now you have to make sure that your project is selected here, so you don't want to scroll down the triangle over here to the left of your project. You just have to choose the project file, right? So then after making sure that the project file is selected, we can open up our project by pressing the OK button. Then when you open your project, Android Studio will show us a tip. Tip of the day. You can always tip your hat to the tip of the day. You can read this, but I usually check the don't show tips. But that's just me. I don't want this one to open every time. Cool, so now we have to wait for our project to be fully created. And that means that we shouldn't take any action before our project is completely created. So, cool. Here we go. So our project's been created successfully, and we can now start the setup of our Android virtual device. And before moving on to the emulator installation, I would like to talk just a little bit about one more thing. In order to use the emulator, the virtualization technology must be enabled on your computer. Now, most new computers have this technology enabled by default. It may not be enabled on some AMD processors, but you might as well find out, right? So just go ahead and look in your Task Manager. I'm just typing here Task Manager in the search bar, open up Task Manager, and I'll open the Performance tab. And yeah, there's all kinds of information here, but as you can see, it appears that there is virtualization enabled. So if virtualization technology doesn't happen to be enabled on your computer, you've got to do this by accessing the computer's BIOS menu. Shouldn't be too difficult. Opening the BIOS menu may differ, though, between different computers, depending on so many different things. So by examining the document I will add after this lesson, please remind me to do that now. You don't have to. I've already done it. You can have the information about opening your BIOS menu, all right? Or, you know what? As a result of a simple search on the internet, according to the brand and model of your computer, you can find out pretty quickly. But I don't want to prolong this any further. You just have to know, okay? Now, probably the majority of you have this feature enabled, still just need to point it out. You can also access detailed information about emulator installation by examining the link that I will also leave under this lesson. So why don't we just get to the emulator installation? So in Android Studio, to create a virtual device or to start an existing virtual device, we'll need to click on the phone icon on the top right of the interface. Notice when I move the mouse cursor over the phone icon, AVD Manager appears. Now let's open the AVD Manager by pressing the phone icon, and when we click it, a window opens like this. And this shows us our virtual devices. Of course, since I've created 2 virtual devices before, these virtual devices appear here, but since you are creating a virtual device for the very first time, you might see a different screen, but don't worry about that. We'll have the same screens soon because we'll do everything step by step together. Now, at this point, I do want to show you how you can delete a virtual device that you've created before. So click on the gray triangle at the end line here where each virtual device is shown. So clicking it will open some views. If you select the duplicate option, you'll obviously create a copy of your existing virtual device. If you choose the delete option at the bottom, you will completely delete the virtual device that you've created. And if you choose the wipe data option, well, that means that you'll just delete all the data on your virtual device, on the virtual device only, of course. Sometimes we can use this option because as we develop projects and then we test them on virtual devices, the size of the virtual device on the disk increases, and then it can begin to slow down. So when you're faced with that kind of situation, you might just need to clean the virtual device. And by selecting the delete option here, I will delete the virtual devices that I created earlier. And together we will create our virtual device from the very beginning. All right. So I'll also just delete the other virtual device. All right. So now that we've deleted the virtual devices that I had left over, I created them earlier. We probably are looking at the same screens, right? So now we can create our own virtual device step by step. So first of all, I'll just click the Create Virtual Device. So it's this button here to create that virtual device. And when you click it, a window opens just like this. And this is the first step in creating a virtual device. All right. So the left of the window, you see here, there's a number of categories. And as you know, Android operating system is an operating system that can be used in televisions, phones, watches, tablets, cars. So in other words, choose a category according to what you're going to make your application for, which platform. Now, since we're going to be making applications that can run on the phone, I'm going to choose the phone option. And then later here, we'll see phones built by Google. So you can choose any virtual device here. However, it might be better if you choose any of the devices with the Play Store application installed. And as a result, we'll produce an application, and there may be some things that we have to do in the Play Store regarding the application. So I'll generally choose the devices that have the Play Store application installed. Just a heads up or an FYI. You can also see the size and the resolution of the virtual devices from here. So taking all of the different features into account, you can choose any virtual device. Typically, I'll prefer the Pixel 2 because both the Play Store application is installed and the resolution and size are ideal. So I indeed will choose the Pixel 2 virtual device. So after selecting Pixel 2, I press the next button at the bottom right, and then we'll click the next button, and the window with Android versions opens. Now, we can probably determine which version of Android that we want to have installed on our virtual device. The most current version is Android 11 or Android R, all right? I wonder, your screen probably has the word download next to all versions. But since I have already downloaded the Android R version before, you're not going to see the download statement. So don't worry about that. Usually you just select the most current version at this stage, but you can always download other versions as well. Now, if you do want to download any other version, of course, just click the download option here. And as soon as you click on it, the download will start automatically. And then again, the process might take some time. But since I have downloaded Android R before, I'm just going to cancel this. But I did show it to you, so there you go. When the download is complete, just click on the Finish button, and thus the version of Android you downloaded will be installed onto your virtual device. So now I'll just cancel the download by pressing the Cancel button, and after downloading Android 11, press Next again. So this step is the last step in the process of creating a virtual device. You can name your virtual device from this window that opens. However, usually we want virtual devices with a default name here. You can also specify the startup orientation of your virtual device from here. I'm going to choose Portrait, and generally that's what I use. And sure enough, we can now create our virtual device by clicking the Finish button. And as you see, our virtual device has been created. All right, so now let's test it out. Let's run our virtual device now. So to launch the virtual device, simply press the triangle that looks like the play icon here. And just by clicking on this triangle, it's going to launch our virtual device. This process can take a little time, my friends. So at this stage, you've got to be patient. Don't skip anything just to get ahead. And I'll just close this warning window. All right, so as you can see, the virtual device is just like a real phone. Of course, the installation process takes a long time, so I'll just speed up this part a little bit so that the duration of the lesson doesn't get too long. And I'll also close this window. All right, so now our virtual device is turned on. Now, first, let's log into the Play Store using our email address. So I'll press the Sign In button. You can write your email address in the field here. And after typing in your email address, we'll click the Next button. So we need to confirm the two-step verification. Next, we'll need to accept the Google Play terms of the agreement. And we must also accept the rules of Google services. And as you can see, we can access the application that we want to right from here, just as if we open the Play Store application on a real device. That's cool, huh? Now, of course, I explained these steps just for you to know. It's not necessarily so that you know about application development. It's just where you might want to go one day. We're not going to go there today. Also, I don't recommend installing and running any application from the Play Store to your virtual device, because the virtual device, well, kind of works a lot slower. So no need to slow down by installing more apps, right? All right, so let's take a brief look at the other features of our virtual device. You can turn your emulator device on and off using the power button here. You can also increase or decrease the volume of the device. You can take the phone in portrait or landscape mode. So here you can see the back, home page, and overview buttons. And then by pressing the More option here, we can access the other features. You can use maps. And we will use this section when we're going to make a weather forecast application in future lessons. And here again, you can see cellular, battery status, and from here you can access the photos on your virtual device. And again, there's an area where you can make virtual calls. Of course, we are going to hardly use these features here. I just want to show you for your own information. So maybe we can use the location section when we're going to make our weather application, and we'll just add a Google Maps complication. That'll be fun. But for now, let's close this window just by pressing the X in the upper right corner. Now from here, if you swipe up with your mouse, you can access the apps on the phone. Cool, huh? All right, my friends, the installation of the virtual device is now complete. The question becomes, how do we run a project that we made on a virtual device? That's a great question. And first of all, we can minimize our virtual device by clicking the minimize icon here. So in future lessons, we're going to make some applications, and we'll need to test these applications on our virtual device. So if you notice, here we see the virtual device that we've just completed the setup for. And if we had more than one virtual device, or if we connected a real Android device, we'd be able to see all of those devices here. On whichever device that you want to test your application, you could just choose a device from here. But for the moment, since we only have the one virtual device, I'll choose Pixel 2. Then press the green triangle icon here. This will run the application and test it. So if you want, let's add a button to the design area before we test the project. So I'll select the button component from the palette and drag it to the design area. Now, you don't need to do this. I'm just going to show you how to test a project on a virtual device. So again, don't worry about it. We will learn these in detail in the coming lessons. So I'll just move the design area a little closer. So now let's change some properties of the button in the attribute section. And I'll just increase the width of the button. Make the width of the button maybe 300 dp. And now I'm changing these features quickly. So again, you'll learn them all later. Don't worry. So we'll make a background color red. So to change the property of a component, you've got to make sure that you select the relevant component from the design area or the component tree. We can change the text on the button. For example, we can write Hello World. And after changing any property you want, just apply the change to the component by pressing the Enter key on the keyboard. So why don't we change the size of Hello World again? Finally, I'll make a text style feature bold. Yeah, and then we'll determine the constraint values of our button. And in our constraint layout lesson, we'll explain again this process in detail. So let's just run it and test the application now. So I'm pressing the green triangle right here, and just below the interface, we can see the application has started to run. Now, the first time that you run your project, you may have to wait a bit. It might take some time. But as you can see, our application opens, and we can also see the button that we created in the design area. Now, of course, we haven't written any code for now. I just showed you very simply how to run your project on a virtual device. In our up and coming lessons, we're going to write code along with the designs that we do for our projects. So for now, we can terminate the project that we're running, and I'll show you how to terminate a project. You just press the red square icon here, And then, of course, pressing this will stop your running project. Just press the green triangle to run the project again. All right. So that is how to set up a virtual device. And it's also how to test your very own project on a virtual device. Cool. So we're going to take a short break here. And in the next lesson, we're going to continue to review Android Studio. I'll see you in the next one. Well, hello, friends. So in this lesson, we're going to install Genymotion, which is another emulator. So Android virtual devices may not work correctly on some friends' computers, so you can use the Genymotion emulator as a secondary device if you'd like. So in this lesson, we're going to learn how to install the Genymotion emulator. Now, if you've successfully created the Android virtual device, you can skip this tutorial, or you can still create and use a Genymotion emulator. Either way, you're going to learn something. So first up, let's open up the web browser of your choice. And I'll just type in download Genymotion in the search bar. I then hit enter on the keyboard and go to the Genymotion site right here. All right. So my friends, if you pay attention here, there are Genymotion's download links for Windows, Mac, and Linux. Now, since, as you might have noticed, my system is Windows 64-bit, well, that's what I'm going to download for my Windows machine. So just make sure that you download what you need for your machine. Also, can you see there are two different options here, without VirtualBox and with VirtualBox? If you have a VirtualBox installed on your computer, you can select the without VirtualBox option from here. Since there is no VirtualBox on my computer, I'm going to choose the with VirtualBox option here, my friends, and maybe that's what you'll do as well. So pressing the button here starts the necessary download process. Now the download may take some time, so therefore I'm just going to stop the screen recording and then pick it up when we get back. Now the download's complete. We will continue from where we left off, my friends. So before proceeding with the installation process, I would like to mention one more thing. If you pay attention, here are some system requirements for using Genymotion. For example, for Windows, you must have a computer with Windows 8, Windows 8.1, or Windows 10 installed. Also, your computer must have a 64-bit operating system. And again, virtualization technology needs to be enabled, my friends. And we'll also need more than 4 gigs of RAM. And you can install Genymotion just by considering these system requirements and just proceed after, or maybe you already know what they are. But in any event, it's always good to know. So I'll click on the arrow icon here and select the Show in Folders option. Yeah, so the file with the extension .exe that we've downloaded is here. So I'll double click on this file with the mouse, and here the operating system will ask, do you allow this app to make changes to your device? It asks a question. I answer with the press of the yes button. All right, so now I'll select the installation language. It's going to have to be English. And here it shows the file path where the files will be saved. So I'll press the next button again, press the next button again, and next again. And finally, I get to the install button to press, and that's what begins the installation process. Now, this might take a little time, so I'll just speed it up from here. All right, so now we get to the VirtualBox installation. All right, so I'll just press the next button, and I'll press the next button again. Press the next button again. So finally, I'll press the yes button from here, and now I can start the installation of VirtualBox just by clicking on the install button. All right, very good. So we've successfully completed the VirtualBox installation. So here I'll press the finish button. All right, so that installs Genymotion. All right. So my friends, let's open the desktop and see if a shortcut for Genymotion has been created. Whoa, look at that. As you can see, a shortcut has been created for Genymotion and for VirtualBox. So let's run Genymotion. I'll press the Finish button in the installation wizard. Okay, so as you can see, Genymotion is starting up. So in order to use Genymotion emulators, we're going to need to create an account. Now, if you do happen to have a Genymotion account that you've created before, well, you can just enter your email and password from here. But if you don't have any Genymotion account, not to worry. We've got to create a new account just by clicking the Create Account button here. Now, when you click this button, the Register page opens. And we must enter the necessary information and just go through the fields here. So yeah, I'm writing my email address, and I'll set in a password. And you can choose your country. And again, you can select the Test Automation for Continuous Integration option. And this is the usage type in this field, right? Finally, you can choose Others as company type. And after filling in the required fields, we need to check the checkboxes here. All right, so after accepting the necessary contract terms, there's the Create button. And yeah, see, Create Account becomes active. So then you click this button, and then a verification link is sent to the email address that you used for registration. So I'm hoping that I either didn't mistype it or you're not using a dummy account. So we need to open up that email address and click on the verification link. So I'm going to click here, and as you can see, the activation process has been completed. And that was a success story. So now we can start using the Genymotion emulator using the registered email address and password. So I got to write my email address in this field again, and I'll write my password in this field. Press on the next button. So here I got to choose the personal use option, right? I'll press the next button. Now from this page, we need to accept the user license again. All right. So after I check this box, I can press the next button. All right, so we have now completed the Genymotion installation. Now let's create the Genymotion emulator. So by clicking the button here, you can access all emulators. So from here, you can choose any emulator you want. For example, let's use the Google Nexus 5 emulator. So from here, we need to select the emulator that you want and press the next button. Thus, the emulator installation begins. And again, the process may take some time, so I'm just going to stop screen recording right now. And when the installation process completes, we'll continue right from where we left off. Hey, that was quick. So my friends, the installation process is now complete. You can now run the emulator by clicking the Start button here. But before I run the emulator, I do want to show you one more thing. If you click on the three dots here, you can see some options related to the emulator. You can run the emulator by clicking the Start option here. Or you can rearrange the emulator by clicking the Edit option here. So if you click Delete again, you can delete the emulator. You can also create another copy of your emulator by clicking on the Duplicate option here. You can use the options here, as many as you need. But for right now, let's just run the emulator. So for this, I'll choose the Start option. Of course, you may encounter an error when you run the emulator for the first time. So I want to show you this error and a few of the solutions in a little while, all right? But during the start of the emulator, the operating system might give you some different warnings. Just press the Yes button. So here's an error. Now, you may not have encountered this particular one, but usually when we run the emulator for the first time, this error may occur. So to solve this error, we just need to click the link here. As you can see, this page shows the situations that can cause the error and their solutions. Now, as I mentioned earlier, virtualization technology has to be enabled on your computer. Now, if you are sure about this, you can move on and look at some of these other solutions. You can see there are multiple solutions here, so you got to try them thoroughly and use the solution that is most suitable for you. This is not a course on troubleshooting, but I'll give you an example. I've implemented solution number 1, and that made the emulator work. So probably many of you will run the emulator successfully when you follow this solution number 1. So I would also recommend closing and reopening Genymotion after following any of the solutions. So this will take into account any changes that you make. As you can see, my emulator works. Now let's see what we can use this emulator and how to use this emulator in Android Studio. So I want to open Android Studio. And as you can see, as soon as we run the emulator, Android Studio automatically detects it, and the running emulators are listed right here. So from here, you can just choose the emulator that you want to run your project on. All right, my friends, that's how to install and use Genymotion emulator, which you can use instead of or alongside the Android virtual device. So use Android virtual device if you want, or Genymotion emulator if you want. The choice is entirely yours. I generally tend to use Android virtual device throughout the course, just so you know, but whatever. We'll take a short break here. See you in the next lesson. General information about the Gradle build system. Hello, everyone. I want to give you some information about the Gradle build system in this particular video. And before we start, I want to show you some Gradle files in Android Studio. So let's move on to Android Studio. I should add some reverb in there. Okay, so you can see the Gradle files on the left side here, and there are 2 important Gradle files for us, and that's level here. So these are build.gradle project. It's my first application file, and build.gradle module app file. Now, before we, really get in depth about these files, I do want to say something about Gradle. You're going, Gradle? Gradle is a build system that automates the build of Android application development. Gradle makes testing and building, debugging, releasing much easier. Gradle also makes adding new libraries into our project in Android Studio a whole lot easier as well. So here's the first page. It's my first application page. It's the version of Gradle system. Now, the most important page for us now is what build Gradle module app page. So this page is application, it's features, and you can see some of the values in here. I want to explain these values and what they mean. So the first one is compile SDK version. So this value determines which API level features we can use. For example, if this value is 25, we will not be able to use API 30 level features. If this API level is higher, then our application will have more advanced features, right? So if this API level is higher, then our application will also have more advanced features of higher API levels. Now, the second one is the application ID. This is a unique value. So for this application, it is com.example.myfirstapplication. Now, when we upload this application on Google Play, it will be known with this particular ID by Google Play. And the third one here is min SDK version. So this value determines which API level and above can work in our application. So it's a lower value, so it's a minimum value for this application. It is 22, and that means that this application will not work below API level 21, right? Now the other one is the target SDK version. This value indicates that my application will work well at this API level in particular. Now, we should give the minimum SDK value as small as possible, and the compile SDK as big as possible, right? And also the compile and target SDK should be the same value. That's what I recommend, and I'm sticking to it. Now, another value is the version code. And you're going to use this code when you publish your application on Google Play. It has to be an integer value, like 1, 2, 3, and it continues on and on. Now, after you publish your application on Google Play, if you change something in your app and you want to upload your new version, you must increase this value. Otherwise, Google Play will not accept your new version of your application. And wouldn't that be a shame? So the version name is when people want to update the app on their phone and they see this value. This is unimportant for Google Play, but people will see this value. It can be 1.0, 1.1, and continues on and on. And when you update your app, you should give the new version name for the people who will download your app. And then when you change some value in Gradle, you will now see a sync button. And after you click this button, it will change everything or synchronize everything to the new values. And then lastly, should tell you about dependencies. So this is the part in Gradle that is reserved for libraries. And if you want to add a new library to your project, you will begin here. Android Studio and Gradle make it very easy to add new libraries, as I told you before. Now, before Android Studio wasn't like this. It wasn't so easy. But now you just add library code dependencies in this section and then click the Sync Now button. I won't even tell you about the history, but just remember that everything in your library will be added to your project automatically. All right? So I think this is about enough with Gradle, because this is not a Gradle course. I want to thank you very much for listening, and I'll see you in the next video. Or you'll see me. No, you'll see we're going to do a lot in our next video, so let's just get to it. So here's an introduction to the manifest file. Hello, everyone. I want to speak to you today about Android manifest file. Now, the Android manifest file is an XML file. It is one of the most important parts of Android application projects. The basic information of our application can be accessed from this file. And we also get the basic permissions for the application in this file. So we can continue on to Android Studio, and here I'll open Android Studio, and you can find the manifest file under the app folder on the left-hand side of Android Studio. Now, when I open the manifest file, you can see that its extension is .xml. Now, if you look at this file carefully, you will see the package name. It is com.example.com, my first application. And we spoke about the package name before, right? Also, there's a line in the manifest file that is an Android icon. Now, it's second line under the application line, and we'll determine the icon of our Android application on the phone in this line. So we'll choose a picture for our Android application, and then after that, we'll put this picture in the map folder. and then we'll write the picture name on this line. Now, if we do not choose a picture for our application, Android Studio chooses a default icon, and that is the Android robot icon. Now, the other important line is the Android label line. And you see that the label is my first application for this project. And this line is for how our Android application name will be seen on the phone itself. So if we change this label, then our application name will also change on the phone. Also, all of our activity files are defined in the manifest file. So we have just one activity for this project right now. As you can see, it is defined in the manifest file in the activity line as a .main activity. And it's defined as a launcher activity in the category line. Now, if we create new activities and want one of these activities to be a launcher activity, then we should determine it to be a launcher activity in the manifest file. So launcher activity will, of course, launch first, and then we'll open the application on the phone. There's another important thing that I want to tell you about this Android manifest file. It's about user permissions. So when you develop an Android application, it will use some of the device features, such as camera and Wi-Fi, phone numbers, microphone, location, all that kind of stuff, right? So you cannot reach these features without getting the user permission. So that means, being a good developer, you have to first ask permission of the user. And then you just write it into the manifest file. And you can see it here, which permission you get from the user, such as access Wi-Fi. And this permission gives you access to the device Wi-Fi connection. Now, if you take network state permission, your application can use the device mobile internet. For example, if your application makes a phone call, you have to get the phone call's permission. You can take all of these permissions from the manifest file, but when you take these permissions from the manifest file, the user will see these permissions before downloading the app on Google Play. So after selecting the type of permission you will use in your application from the manifest file, you can press the / or Shift and greater keys on the keyboard to close the tag. Now, the other topic is screen orientation for this level. And when the user opens your app on the mobile device, your application will appear vertical or horizontal. Now, you can specify this in the manifest file. If you choose the screen orientation portrait, your application will appear vertical. And if you choose landscape, it will appear horizontal. And also, you can change your application activity theme in the manifest file. So by that, I mean right here, by theme is the top section of the activity. So you can see this is my first application part, and it's replaceable. And you can change the text color, the background color. You can add icons, a whole lot of things. Everything I mentioned that you can specify in this theme. And you can create a new theme, and then after that, you can change it on the manifest file. So we're going to do some examples about all of these topics and more in the coming videos. I just wanted to give you a quick rundown of all the information. It's enough for this level. So until then, see you in the next video. Introduction to resources. Hello, everyone. I want to tell you about some of the resources in Android Studio in this particular video. So let's get to Android Studio without losing any more time. Now, you know that we've opened a project on Android Studio, and we were going to give some information about our project file within Android Studio. So you can see the resources folder, which is here on the left side of Android Studio. And as it's called, it's a res folder. Now, there are 4 folders within the resources or res folder. These are the drawable, the layout folder, the map folder, and the values folder. Now, first of all, we're going to speak about the drawable folder. Now, this particular folder holds, of course, pictures for our project. And I'll just right-click on the drawable folder and click Show in the Explorer. And I can see this folder in the Explorer. Now, there's an XML file inside it. And I'll put some pictures, icons, and logos in this folder for using within my Android Studio project. And when I need these pictures, I can call it up, giving this folder path, right? And then I'll just copy a picture from another folder, paste it in the drawable folder. And after I close this folder, and you can see now that this picture is under the drawable folder in Android Studio. And if I click it, it will open. And then I can use this picture in my project, such as a background image. Now, another folder is the layout folder. And the layout folder holds XML activities files for our Android application. Now, you know that we have one activity now for this project, and its name is main activity. But there is a second part of this activity. So one is the XML file, the other is the Java file. All right, so the layout folder holds the XML file of the main activity. The main activity Java file is in order under the app Java com.example.myfirstapplication folder. So if we had other activities, our XML files would have been under the layout folder, and then we could work on each activity individually, whichever one we want. Now, another folder is the map folder. The map folder holds pictures and icons like the drawable folder. So I know what you're thinking. If the map folder holds pictures like a drawable folder, then why do we have 2 different folders for the pictures? But the map folder is not the same as the drawable folder. So I'll open up the map folder on Explorer, and then you can see here that there are 6 different map folders. They are mipmap HDPI, MHDPI, XHDPI, XXHDPI, and, well, etc. You can read them yourself. So why are there 6 different mipmap folders? So if you look at it carefully, you will see that there is the same picture in each of the mipmap folders. Now, if you recall, we spoke about Android applications. And before you can develop Android applications, you have to determine screen sizes, because you can develop Android applications for different screen sizes. In fact, you can develop Android applications for small screens, big screens, tablets, or Android televisions. So when you are developing these applications, if you use the same pictures for every screen resolution, of course, the pictures won't appear very well in your application. And we don't want that. It's going to look bad. So to solve the problem, Android Studio uses a mipmap folder. And then what you'll do is you will use copies of the same image in different resolutions, and they'll all be stored here. So whichever size of the device that you're going to be running your application, it will use the required photo from the Android Studio mipmap folder. For example, if your application runs on the small screen device, your application will use pictures in the MHDPI folder. Or if your application runs on a big screen device, it will use pictures in the XHDPI. Now, your application will make this decision automatically, but you also need to write some code for this operation to be successful. It doesn't work just by putting the pictures in the folder. I wish. Well, okay, maybe you wish. So we're going to see some examples about how to do this in the next couple of videos. This video is just giving you the general overview about Android Studio and what you can do in Android Studio. So we'll move on to the last folder, which is the Values folder. There are 2 XML files and 1 theme folder here. Now, in previous versions of Android Studio, there was a style.xml file instead of the theme folder. However, in the current versions of Android Studio, the theme folder was created instead of the style.xml file in order to access the dark theme and light theme features more easily. So we're going to examine this in a moment, but for now, I'll click on and open Colors XML first. So you can define colors for your project in this XML file. So you see there are 7 colors in here. Every color has a code. This code is XML code. And you can define colors using XML code. You can find every color XML code way out there in the worldwide internet. So you'll choose a color, put in its code in this file. So after that, you'll need to, well, name your color. So here the name is purple, teal, black, white. So when I need this color, I will just call it by name. For example, I want to change my main activity background color. I'll go to the main activity XML and I will choose the background in the attributes section where the right side of the Android Studio interface is. Then after that, a window is going to open and I can see the names in the color section in this window. Now also there are other basic colors in here. But of course there are millions of color codes and you won't be able to find every color in Android Studio. So because of this, if you want to use a new color, you can define that color in the colors XML file. All right. So then after that, you can give this color a name. And you can then use this name whenever and wherever you need to. So in other words, you won't need to remember the color code. So we'll write here the code and you can use it everywhere you need. So what I'm going to do is add a new color here. As an example, I'll copy the last line and I'll paste it under. After that, I change the name color red, also change the color code, but we, of course, won't be able to know the code of every color. If we do know the color code, we can write it here. If we don't know the color code, we can find it out there on the internet. Or we could always click on the color box on the left, and that opens a palette where we can choose a color. So we can choose the color that we want from here. I'm just going to choose red for now. So note here, though, that this is the code for the color that I chose. So later when I click anywhere outside of the color palette, I'll be creating my new color, right? All right, so now it's added. That's easy. So I'll go back to the main activity and try to change the background again. And I'll see this new color on the list called red. Yay! Now, the other XML file is string XML. Now, you can give it a name. In fact, you can name every string, word, or sentence. So when you need this string or sentence, you can call it by its name. Also, you can add arrays here. And after that, you can call it from the Java file. Also, we will use this file to design our application for multilingual. All right, so that's cool. I'm not going to get into a detailed explanation for now in this video, but you see that there's a lot of things to learn in here. So the last folder is the theme folder. And what do you think? This folder is for themes. There are two different XML files in the theme folder. First is for light mode. Second is for dark mode. And of course, that gets created automatically by Android Studio. If you're familiar with previous versions of Android Studio, there was a style.xml file instead of this theme folder. And the theme was created for light mode only. So right now, why don't we open up both themes? And as you can see, both have the same XML codes, but only the colors are different. So for this reason, it will be enough for us to examine the XML file containing the light theme. Now, if you notice, there are primary and secondary colors here. The primary colors are the colors displayed in the design area. For example, color primary is for the app bar in the design area. The app bar is commonly known as the action bar. The color primary variant is also for the color of the top part of the application interface. Color primary defines the color of the application where we write the name of the application section. So you can see that here is the app name. Now, when you change these colors from the styles XML file, all of the application activities app bar colors will change automatically. Also, you can create a new theme here, and which activity that you want to use, you can just change the theme from the manifest file, and it too will change. Also, we said that with the new version of Android Studio, it becomes easier to switch to the dark theme. Well, why don't we take a look at this now? So let's open up the design area, and when we click on the orientation icon here, we can see the night mode option. And if you select night mode, your design space will turn into this dark mode, and all components in the design area will have this dark theme color scheme applied. And if you click the orientation icon again and select the not night option, the colors in the bright theme will be applied to your design area. See how easy that is, my friends? All right, so that's all you need to know for now. In our next lessons, we will learn all of the issues in detail, and we'll practice all of the solutions, okay? So why don't we just have a short break here, and I want to see you in the next lesson. Cool. All right, hello everyone. So I want to talk to you a little bit about r.java files in this video. So it's going to be some general information about the r.java file that you really ought to know about. So this r.java file is an auto-generated file by Android Studio. Now you know there are two parts of the Android Studio application project. First one is an XML file. Second one is the Java file. Now we do all of the design over on the XML file, and all the designs that we made in XML file is then translated into Java code by Android Studio. That way we don't have to write things twice, right? So Android Studio gives an ID to every component that you've designed in the XML file. And then these IDs are kept in the r.java file. These IDs can be used on the Java side to perform any action on your XML files. So now we'll go to Android Studio, and you can see here the project files, XML design side, as well as the main activity on the Java side. All right, so first I just want to show you where this r.java file lives. So I'm going to choose Project Option on the left-hand side of Android Studio. Now this R file is respectively under the My First Application folder, App folder, Build folder, Intermediates folder, the Compile and Runtime folder, and of course the Debug folder. So if you've been paying attention, there is an r.jar zip file. Now, we actually can just unzip this file. So for this, I'll right-click on this r.jar file and select Show in Explorer as my option, or the option Open in Explorer. And I'll just unzip this file. So right-click on the R file, select Extract Here as your option. All right, so as you can see, two folders named Android X and COM have now been extracted. And let's expand this COM folder and Company folder. All right, so under the My First Application folder, there is the R class. Now at this stage, I would like to point out that the R file can be found in different places in different Android versions. So this file path might just change over time. However, you don't actually need to know where that R file is. You know why? Because we'll never use this file anyway. The reason, though, that I do want to show you this is because now you're going to know the Android component ID relationship. Scared you for a second there, huh? Just kidding. Now, what you have to do, though, in addition, is run your application at least once for the build folder to be created, right? So when you run your application, the build folder will be created automatically. All right, so now that we know that, we can continue to this. So opening up the R file, you're going to see it's generated automatically. So even if you delete this file, Android Studio will generate it again. You're not going to be able to get rid of it, really. All right, so you see that right here, it should not be modified by hand. All right, so for example, so this is our main activity, and its name is activity_main.xml. So we define this XML file on the Java side as r.layout.activity_main. Right, so activity_main is its ID. And you can actually see this ID in the R file. As you can see here, there are different classes, right? And from here, I just want to find the layout class. All right, so here is the layout class. And notice that an ID is assigned for activity_main, right? Yeah, so this procedure actually is for every XML file under the res folder. So if I go back to Android project file, well, now you're going to see everything under the res folder, such as the drawable folder, map folder, layout folder, values folder. Okay, so now, for example, we have a text view in here, and now I will give it an ID. For this particular text view, its ID is denim, and you can give any ID you want. But now you see this text view is an XML file, and you can see its XML codes in the text section. And now I will call this text view on the Java side. First, I will define this text view here. I will give a name to this text view. The name is the text that I gave. But you can give it any name you want. And after that, I will call this text inside the onCreate method. And I will call it from the R file. So I'll write here r.id.denim. And it is now identified. So I can do any operation on this text view using the text name. I can change its background color or its text size using Java code. We call the activity layout using the same method. For example, if I write here r.layout, it will call XML files under the layout folder. Also, if I write r.string, it will call strings inside the string XML file. So what do you think? I think this is enough for the R file in this particular video. See you in the next one. Layouts. Hello, everyone. So we're going to speak about layouts in this video. So we can start to design levels in Android Studio. But we should learn layouts in order to design Android applications. So just what exactly is a layout? A layout is an interface that we use to place Android components on the Android application. So we're going to use layouts to establish components in a particular order. These components are buttons and text views, radio buttons, and anything you can pretty much think of. There are varieties of layouts, and these are linear layout, relative layout, table layout, and constraint layout. So these are the main types of layouts, and we'll speak about the first three layouts in this video. I'm going to reserve the constraint layout to another video, but most of the projects we're going to use the linear layout and the relative layout. But if you have a table design in your project, you can use the table layout. Now, because I want to stay on topic, we're going to speak about Android Studio. So let's go to Android Studio, and you'll see what I mean. Okay, so you may recall that we have a project, and its name is My First Application. So when we open a new project in Android Studio, it creates a main activity XML file. So we will design right here on this page. And this page's default layout is constraint layout. Now, we will not use the constraint layout. We will start by using the linear layout. Now, if you look at the component section, you will see the layout types under the layout section. So first, I'm going to delete the constraint layout. I know, just delete it. And instead of the constraint layout, I will write linear layout. And I will do this using XML code. So I'll open the text side, delete the constraint layout. After that, I will write in linear layout. Okay, so now our layout is linear layout. But also we're going to need to specify its orientation. Now there are two types of linear layouts. One is horizontal. The other is vertical. You can specify it by writing this code. Now I'll first choose the vertical orientation. So in this layout, components are placed from up to down. If you choose horizontal orientation, the components will be placed from left to right, just so you know. So for example, I'm going to put text view here. And you can see it started from up here. And then after that, I'm going to add a button. And you see it's placed under the text view here. And if I add another button, guess what? It'll be placed under that first button. So now I'm going to change the orientation of my linear layout, make it horizontal. And now if you look at the design page, you'll see everything is placed from left to right. So I'm going to change the layout width. I'll change it to wrap content. And then you can see that the buttons and text views are sorted from left to right. Now if I add one more button, it will take its place after the second button. You know what? I should mention to you about the layout width and the layout height here. They are match parent and wrap content in here. So when you choose match parent, the layout will cover the entire screen. But if you choose wrap content, the layout will be big enough to enclose its content. Right? Makes sense? Also, you can give a numerical value in here. So by that, I mean you don't have to choose just match parent or wrap content. For example, let's give a layout width of 400 dp and layout height of 500 dp. Now also, you can add more than one layout. So now I'm going to choose layout width and height match parent. And I'm going to add another layout, but this time its orientation will be horizontal. Now I added this under the vertical linear layout, and I will add 2 text views under this horizontal layout. And I will choose layout width, wrap content for horizontal layout. And now you can see these 2 text views are side by side. So in the same way, I will choose layout height, wrap content for horizontal layout. And now you can see the button too. So now these 2 text views depend on the horizontal layout, and buttons depend on the vertical layout. So actually, buttons and horizontal layout are elements of a vertical layout. Also, horizontal layout has 2 more elements that are text views. So now let me just add one more button here, and it will take its place under the other button. Now also, I can add one more layout. Now this layout is also going to be a horizontal layout. So this layout is an element of the vertical layout. I will connect these 2 buttons to this new layout, and I will do this with, over here on the XML code sign, and I will cut these 2 buttons XML codes and paste inside the layout. But also I should choose layout with wrap content for this layout. Great, so now we have one main layout and its orientation is vertical. And also we have 2 child layouts and their orientation is horizontal. And then every horizontal layout has 2 child layers, and these are buttons and text views. Now, after the linear layout, we can continue with the relative layout. And I'm just going to delete these components. And I will change linear layout to relative layout. So how does the relative layout work? Probably the best way is to show you. So components are placed right in each other's position within the relative layout. I'm just going to add 2 buttons to show you how relative layout works. You can see that these 2 buttons took place on top of each other because we haven't given them any position. So now I'm going to change the first button text to be a capital letter A, and its ID will be a lowercase a. And for the second button, I will change its text to be capital letter B, and its ID will be lowercase b. So now let's go to the XML side, and I will first find the button and add a new line of XML code. And this code is layout center horizontal true. Now button A takes a place center of this row. And I'm going to add another line of code. So this time, center vertical is true. Now button A took place center of the screen. And now I will give a place to button B according to button A, or relative to button A. Yeah, see where we're going? And I'm just going to add a new line of code in the XML code of button B. And this code is layout below IDA. Now button B will take its place under button A. Now if I want button B to be in alignment with button A, I should just add a new line of code. Layout center horizontal true. And now button B is under button A. Now, if I want to put button B above button A, I should just write the layout above IDA. And now button B is above button A. So you see in the relative layout of the components, they all take their places according to each other's position. Okay, so now we can have a look at the table layout. In the table layout, components take their places by means of a table position. So in the table layout, there are rows and columns. And now I'm just going to delete the relative layout and write table layout. Now also, we need to add some rows in this table layout. So I'll add 3 rows. And then after that, I can add 3 buttons for each row. So now we have 9 buttons on the table layout in a table position. So where can I use a table layout? Let's say, for example, I want to design a calculator. We can use the table layout. So I'm going to change these button text to 1, 2, 3, and you see where we're going. And of course, you can use more than one layout in your design. So I think that wraps this video. We'll continue in the next one. See you then. Text views. Hello everyone, it's time to talk about text views in this video. So we spoke about components in Android Studio in the last video. We mentioned some layouts, and right now we're going to talk about which Android components to place on these layouts. One of them is text view. So what exactly is text view and what can you do with it? So text view is a component to show text to the users. I know it seems elementary, but stay with me. You can use text views as labels or to print some results on the screen or to print some notifications on the screen and that kind of thing. Text views can be used in a lot of different areas. So it's pretty much the most commonly used component. So we'll go back to Android Studio and have a look at how text views work in practice. Now we can add text views two different ways to Android applications. And of course, the first one is to drag and drop it into the Android Studio like this. All I'll do is drag text view, drop it under the constraint layout. And now we have text view and its text is also text view. So we can change this text whenever we want to. This was the first way. Also, of course, there is another way, always another way. And I'm just going to delete this text view and create a new one using XML code. And I'll go into the XML side. And now I'm going to write text view XML code under the constraint layout. And I'm writing here text view and Android Studio will autocomplete it. Now I just need to give some values for the layout width and height, and I'll just write wrap content for both of them. Now this will define height and width of the text view. Now we have a text view here, but we don't see it because we did not write some text. So I'm going to add a new line of text inside the text view using XML code. I'll write inside text view hello world. And to do this, I will just need to write Android : text. And inside the quotation marks, I will write text. So whatever I write inside the quotation marks, the text of the text view will be what I write. So now the text of text view is hello world. So I choose wrap content for height and width of text view. And then setting a text view size to wrap content will force it to expand only far enough to contain the values it contains. Right? So if I add new words to the text, the size of the text view will be bigger. And if I change it to a bigger number size inside the text view, the height of the text view will also be bigger. When I change text size to 20 dpi, and the text view size gets smaller, of course. So when I change text size to 40 dpi, text view's size gets bigger, way bigger. Now, on the other hand, I can choose the width of text view as a match parent. So when I write match parent here, text view will cover all of the device screen from left to right. And then also when I write match parent for layout height, the text view will cover all of the device screen from top to bottom. So now I'll choose wrap content for layout height. Now, of course, also I can give numerical values for height and width. So let's give 150 dpi for width and 75 dpi for height. And also I'm going to drag text view to the center of the screen. So when I click text view, I can see the attributes section on the right side of Android Studio. And I can also see all of the operations I can do right here, everything that I can do to text view. For example, I can change the layout margin here. And then when I change the layout margin, text view position will change on the screen. Now, if I write 250 dpi here, text view's position will go down. If I write 150, it'll go up. And I can give numbers from here for left, right, top, and bottom. Layout margin defines the position of the text view. Also, there's another attribute here. It's called padding. If you're not familiar with padding, padding defines the text position inside text view. So if I write 25 in the left box, see how the text will go 25 dpi from left to right. So if I write 10 in the top box, the text will go 10 dpi from top to bottom. Also, I can change the text size in the attribute section. So if I choose 24 dpi, the text will be bigger. When I choose 14 dpi, the text will be smaller. Now, all the changes that we made in the attribute section will be added in the background as XML code. Now, if you want, you can write XML code to do the same operations, or you can use the attribute section. So let's see what else we can do in the attribute section. We can change the background color from here. I will choose color accent as a background color. And now the background of text view is changed like so. There's gravity here. You can define text position automatically inside the text view from here. So I'll choose center, and text will take the center position vertically and horizontally. But if I choose this, I'll need to change gravity to 0. And now we can change text color from here as well. So for example, let's say that I want to choose white, and the text color will be white. We can do a lot of operations from here. But also we can do these operations on the Java side. You don't think I was going to leave that out, do you? But before we work using Java code, we will need to give an ID to this text view. You remember when we talked about it before? So on the Java side, this text view needs to be given an ID in order to be recognized. So I'm going to give it text example as an ID. And now our ID of text view is text example. And text of text view is hello world to the human. So let's go to the Java side. First up, I need to call text view as my class and give a name to this text view. And I'm going to use this name on the Java side. You can give it a name, whatever you want. I gave the name text. I'm creative that way. Now, after that, I do need to call this text in the create method. So I will write text equals, and I will write find view by ID. And I will call text view from the XML side using its ID. And I'll write inside the parentheses r.id.text example. So see, now we have assigned text view to the text we created on the Java side. Now I can do all of the operations that I've done on the XML side here, but how will I do this? I'll just write text here, and I will add point here. Then after the point, I can see all of the operations automatically. And I can set a new text from here. So there are plenty of operations here that I can choose from. For example, I can choose set text color. So I'll choose a color, writing color.black. And then when I write this code, nothing has changed on the XML side. The changes will be applied when I run this application on the device. So I'll click Run. And then, after the device opens, I can see the changes in the application. So it'll take some time to get to the device online. There we go. Now you can see that the text color is black. Cool. Okay, so also I can change the text using set text code. I'll write text.setText, and inside the parentheses, I will write new text I want to change, and I will write this as an example. But you should be careful now. You need to write text inside the quotation marks, right? And I'll just run it again. There you go. Now you see that the text has changed. So in addition, we can add a feature to text view. And if we click to text view, we can start the operation. So for example, when we click onto the text view, we can open a new activity, or we can change the text size or text color. So let's try it like this. How are we going to do this? I will add a click listener to this text view. You see it? I will write text.setOnClickListener, and then inside the parentheses, new view on click listener. And I will write new codes inside the onClick method. Now, of course, these codes will work only when I click to the text view, right? I will write inside the onClick method text.setTextColor. Color.white. Click run again. And after a while, the device is running. And now you can see here that there's not any changes in the text view. How come? After I click on the text view, the code will work and the text color will be white. So let's change the background color of the text view. I will write text.setBackgroundColor, color.black. And I'll click run again. Now you can see that after I click text view, the text color will be white and the background of the text view will be black. So we can do a ton of other operations here. But for now, that's enough for one video, believe me. There are other components that we need to learn, so make haste. I'll see you in the next video. Buttons. Hello, everyone. I want to speak about buttons in this video. No, not the ones on your jumper, your sweater, anywhere else, your shirt. Buttons on Android components. So when you click on buttons, buttons will do specific operations. Buttons are one of the most useful components, and I'm thrilled to be able to tell you about them. So if I want to count 3 of the most used components, I'll definitely say buttons, text views, and edit texts. So in the last video, we spoke about text view. This video is about buttons, and we're going to speak about edit text in the next video. I know, I'm transparent, aren't I? So let's go ahead into the Android Studio without losing any more time. So we have an open project from the last video, and we have a text view in this project. So now we're going to add a new button to the project. And as you perhaps remember before, we can add a new button in 2 ways. First one is drag and drop. Boom, I added a new button. And of course, I can drag it wherever I want and change my mind. And That's because I use constraint layout. Just snaps like that. Now, the second way to add a new button is by using XML code. So why don't we add a second button using XML code? Now, just go over to the XML side, and you can see here XML code that I've added a button before. I'm going to write button here, and Android Studio will autocomplete it. Okay, so now I need to define height and width, and I'll choose match parent for 2 of them. And you can see here we have a second button, but it covered the whole screen. So I'm going to change height to wrap content. Okay, so now the button covered the screen just from left to right. Now we need to give some text to this button. And I'm going to write here Android text, and inside the quotation marks button 2. And now you can see the button and button 2. So why don't we change the width of button 2 to be wrap content. And now we have 2 buttons. The first one is created by drag and drop. The second one is by using XML code. Now we can do a lot of operations with these buttons, right? We can do these operations in the attributes section. So we can define height and width here. We can specify layout margin from here. Also, we can define padding here. You remember that I mentioned that before, right? Padding defines the text position inside the button. So let's just go over it again. If I write left 20, text will go 20 dpi to the left. Also, when I write 20 dpi, text will go 20 dpi down. Now I can change the button text from here too. So I'll just write in here quickly, do your magic, and you can see the button got bigger because the button width is wrap content. Okay, so when the text gets longer, the button will get bigger in order to cover the text. And I can change the background color of the button from here as well. And I'll choose a color from here, and the button color will change. Now also I can choose the button to be clickable or not. Now you can probably think of why I put a button in the project, and I didn't do it to be clickable. So if I do not click the button, why did I put a button there? Well, this is important because you can do regulation on your project, and you can do your buttons to be clickable after some other operation. So in other words, before these operations happen, the button will not be clickable. You get me? For example, if you design a game, and inside the game there is a next section button, but you don't want the player to pass on to the next section before they, I don't know, make a, specific score. Well, you can specify that after the player collects a score, the next section button will be clickable. So then the player can pass to the next level after they make the required score. Also, we can change the text color from here. We can change the text size from here. Also, another important thing, we can do our button to be visible or invisible. Now you get it. So if I choose invisible, the button will not be seen. So this feature, of course, can be used for the same purpose and that I mentioned about being clickable or not clickable. Inclickable, I almost said. Inclickable. All right, so now we need to give this button an ID to be able to work on the Java side. So Android Studio gave this button an ID. It is button. All right, so if you want, you can change it. But you know what? I'm going to change it, and I will give it the ID do magic. Great. So now the ID of this button is do magic, and the text of the button is do your magic. So are you ready? Let's go over to the Java side. So there are some codes here before we wrote, so I'm going to delete some of it. And now I need to define that button in here. So I expanded import part above. And you can see here when I defined text view, Android Studio imported android.widget.textView. Now you must import it in order to work with TextView. And in the same way, when I write here button and I do not choose autocomplete, the word button will be red because we did not import the button class inside the project. So that means I'll just need to import the button class. How am I going to do that? See here, when I write button, and then after that I press Control and space at the same time on the keyboard. After that, Android Studio will show me what I can import. And then I'll just double-click Android.widget as my option. And you see here, Android Studio imported Android.widget.button. And the button word is not red anymore. So now I need to give a name to this button in order to work here on this button. Let's see, I'll give the name button, but you can give whatever name you want, of course. Also, I'm going to need to define this button inside the onCreate method. So I'll write button equals find view by ID. I will write inside the parenthesis r.id.doMagic because the ID of my button was doMagic. So now I've defined the button on the Java side. I can do everything in here. So I will write button after dot, and you can see the operations that I can do. Now I will add a click listener, and inside the parentheses, new view on click listener. And then after that, I write inside the onClick method will be executed when I click the button. And I will write inside the onClick method button.setBackgroundColor and inside the parenthesis color.black. So this code will then change the background color of the button after I click that button. I mean, that's a predicted result. We'll run it and we'll see. Whew, boy, it is working. You can see that, right? Cool. So we can do operations on other components from here as well. For example, we can change the text of the text view from here. So let me write text.setText, and inside the quotation marks, I have done my magic. Okay, so let's run it. And you see when I click on the button, text of the text view has changed. Now also I can do invisible for this text view. So I'm going to write text.setVisibility view.invisible. Let's run the app. And you can see, or you can not see, that it is working. So when I click the button, text view gets invisible. So in other words, you see that it is working because you don't see. Well, okay, well, never mind. You see that invisible is visible. No. Okay. Now I will do the invisible button itself. For my next magic trick. So you see here that there is another button, but when I click it, it doesn't work. Why? Because we haven't written codes for this button. Now, of course, we can do many more things here, but I just want to point out another topic about buttons. I know, I'm button crazed. I'm obsessed. The design of buttons is as important as its codes. So because of this, you need to learn different types of button designs. Do I need to say it again? Button types or button designs are as important as its codes. For example, you would want to shape a button to be oval or circular or rectangular. And then when we want to change the button design, we'll need to create a new XML file. So I will right-click the drawable folder, and then after that, I will choose New, Drawable Resources File, and it will open in a new window. Now I need to give a name to this new XML file, and I will give the name Button Shape to this file. Click OK. And now we have a new XML file, and its name is Button Shape. Stay with me. There are some codes here, and these are the codes that when we click each button, how its design will be created. So I will delete these codes because I will not work with this right now. I just want to change the shape. So I'm going to define the shape, writing Android shape oval. Now also I need to choose a color for this button. So there are two types of colors, basically solid and stroke. I will define a solid color, and I'll choose a color from here, but you can choose whichever color you want. I'm not looking, so go ahead. So we defined the button shape, but has anything changed on the main activity XML page? Because we need to set as a background, we created the button shape XML. Now, how will I do this? I'm going to go back to the XML side of the activity main page, and I will change the button background. I will add the button shape XML file under the drawable folder that we created before. And now you can see the button has taken the oval shape. But we defined the width and height to be wrap content. Need to change that too. So I'll change two of them to 150 dp button. Yes, took the shape of a ring. So you can do this square or rectangular. It's up to you. Go, play. You're going to have a great time. It's enough for this video. I will see you in the next one. Edit text. Hello, everyone. Today we're going to speak about edit text in this video. So edit texts are Android components, and it's used to basically get data from the users. You can see edit text in many Android applications, and they get the data from the users, such as name and surname, password, address, all that kind of stuff. Now, there are different types of edit texts, and we're going to see these types in this video in practice. So we'll go to Android Studio, and let's have a look around. All right, so here you can see edit texts on the left side of Android Studio in the palette window. And under the text section, its name is plain text. And under the plain text, there are other types of edit texts, such as password input, email input, phone number input, date and time, multi-line input, etc., etc. Now, before we start getting into edit text, let's change the relative layout to the linear layout. And now we can learn how to work with linear layout. So what I did was I deleted relative layout from the XML side and wrote linear layout here. Also, the orientation of the linear layout is vertical, and you can see that here. So what I'll do is I'll drag and drop a plain text under the linear layout, and there we go. We have an edit text. Now the idea of this edit text is edit text, and the text of edit text is name. So when we run this application, the users will enter data from here, such as name, right? So let's just run it and see what happens. Application running now, so you can see here users will enter their data from here. Now I'm going to delete the word name that we wrote before, and I can just write everything here. You know, also I can always enter numbers from here as well. So let's add another edit text. Let me add password edit text and numerical password edit text and numerical edit text that you can just enter numerical numbers from here, and also the multi-line edit text. And we'll run the application with these edit texts. Great, so the first one is standard edit text, and you can enter numbers and characters. The second one is the password edit text. So when you enter password in this enter text, numbers and characters will not be seen, right? And you can enter this password edit text, numbers and characters. It's alphanumeric, just like you would want it to be. And the third one is also a password edit text, but users can only enter numbers and not characters. Also, numbers will not be seen in this type of edit text. And let's have a look at the fourth one, the number edit text. And then here, of course, users can only enter numbers in this edit text, but the numbers will be seen in this edit text. Now, where can this edit text be used? For example, if you want to, grab a phone number from the user, you can use this edit text, or you want a user to enter his or her age. So when you want the user to enter digits only, this is the type of edit text to use. Now the last one here is the multi-line edit text, and the user can enter more than one line of information in this type of edit text, obviously. So I will write here some text, just to show you how it works. And then you can see here, after the first line, the second line continues under the first line, just automatically. For example, you can use this type of edit text to get user comments or address, or address a complaint even. There are not going to be many of those, but whatever you need it to do. But in the first one, when the user enters more than one line, after the line has finished, the head of the line will not be seen. Of course, we are not done yet. We've just placed the edit text here. So we need to get the information and use it somehow, right? And we will do this on the Java side using Java code. So let's do up an example, shall we? So I'm just going to delete the edit text except the first one. Now also let me add a button and a text view. So I will develop an Android application, right? And the user will enter the name from the edit text, and after they click on the OK button, the name will be seen on the text view. So I'm going to delete the text of the edit text, but it will not be empty. And I will add a hint to the edit text. Now the hint, of course, is a tip given to the user to understand what the user will write in the edit text. I mean, unless you're making a guessing game, but for this example, we're just going to write in the hint section, please write your name. And I'll change the text of the button as an OK. And I also deleted the text of text view. So let's change the design of the application a little bit. Now I'm going to give a layout margin here of 50 dp from top to the edit text. And I will give some space between the edit text and the button, about 30. And in the same way, the button and text view. And let's do, 30 as the height of the text view. And I'll change the width of the edit text. And let's make it 200. It's a little too small. Let's make it 300. Yeah, that looks okay. So in the same way, I'll just change the width of the button to 300. Now, for the text view, I just do the same. So that means I will place these three components into the center of the screen horizontally. So how can I do this? That's when I select linear layout. And then after that, I'll go to the gravity option from the attribute section, and I'll choose center horizontally, and then all the components placed in the center. Now I will add a text on the text view. Could be, result. And I'll change the background of the linear layout. And let's change the background of the other components too. And I'm going to choose white for these three components. Yeah, that button looks a little big, huh? So let me change it to 200. And now I'll give an ID to these components. So edit text name is for edit text. Button OK is for the button. And text view result is for the text view. So I think it's okay. Let's have a look. We'll run it and we'll see it on the phone. Okay, so the application is working. Now you can see the hint in here. And I write Arnold here, click OK. Arnold should be seen on the text view instead of result. So the application is not doing this right now. Well, because we have not written the Java code, right? That's what you were thinking. So why don't we go over to the Java side and write some code? So the first thing I need is to define these three components. And I'll define edit text. Now, when I write edit text and choose from the autocomplete, Android Studio imports the required class android.widget.editText. So after I wrote edit text, I'll just need to give a name to this edit text. Let's just call it name, just to be clear. Okay, so secondly, I'll do the same thing for the button and give a name, okay. And the last component is text view. I'll just call it result. So now I'm going to assign XML components that I designed before to use these names using the findViewById code inside the onCreate method. So here I'm going to write name equals findViewById r.id.editText name. On the second line, OK equals findViewById r.id.button OK. And in the same way, the result equals findViewById r.id.textViewResult. Yeah, you with me so far? Because it's so far so good. So now I'm going to add a click listener to the OK button, right? So OK.setOnClickListener, and inside the parenthesis, new view on click listener, and autocomplete will take care of the rest. And I'll write code inside the onClick method, and I'll get the data that the user enters in the edit text. But how am I going to do that? You tell me, you're the one who's teaching the course. Okay, what I'll do is I'll write it here, name.getText.toString. So this code will take that text that the user enters in the edit text, and then it converts it to the string, right? So now I'm going to write this string to the result text view. But before I do this, I'm going to need to define a string container, and we'll call that username. I will assign the text that I took from the edit text and put it into this username string. So because of this, I will write here username equals name.getText.toString. And then I can set the username on the text view. And I will write here result.setText, and inside the parenthesis, username. Right, so this is very important, and I hope you understand this. So rewind, set it up again in case you miss something. So what I did was I defined a container, and its name is username. After that, I took the text that the user entered and converted it to a string. And then I assigned this text to the username. And then lastly, I set this username to text view. So let's run the application and see how it works or not. All right, so the application opened. And I'll just write here a name and click OK. Good, so it's working, right? So it takes the name I wrote in the edit text and then writes it to the text view instead of result. So I think that's plenty enough for this video. I hope you understood the edit text. Like I say, if not, just rewind and do it again. You'll get the hang of it. Until then, see you in the next video. Image view. Hello, everyone. So today we're going to talk about image view in this video. So image view is an Android component to, guess what? Display images. Now, you know that showing images is really important for your Android application. And if you use good photos, good graphics, and all that, your design's going to look great. And because of all this, image view is important to master. So let's get to Android Studio and learn image view and practice. Okay, so you know that we have this project from before and we'll continue to work on it. So I will add an image view in this project. So where do we find image view? It's inside the palette window under the widgets on the left side of Android Studio. And I will drag image view and drop it in the linear layout. Now, first I'm going to rearrange this so that I put it as first component. Now this is a linear layout and its orientation is vertical. Now because of this, all the components will get their place from up to down, top to bottom, right? So when I drop image view, a new window opens. And this window is the resources window. And what I'll do here is choose a picture for the image view. And I'm just going to choose a picture that's inside my project that I had before. And I'll click OK. So now I can see this picture on the phone, but see there's a problem. Because I cannot see the other components. And the reason is the sizes of image view are match parent and wrap content. So the size of my image is too big. And then when image view uses the wrap content for height, the image covered all of the screen from top to bottom. So I will change the layout height and width to 300. And now you can see all the components. So image view is now in the center of the screen horizontally. Now because I chose layout gravity center horizontal for my linear layout in the last video, all the components are placed in the center of the screen horizontally. Now, if you look carefully, you can see that the image is placed inside the center of image view. So if you want your image to cover all of image view, you should just choose the size of the image exactly the same size for image view, right? So for example, if the size of image view is 300 by 300, then the size of your image should also be 300 by 300, or vice versa. But also, we can do some arrangements within image view. So when I click on this button, some attributes will open and I will go to the scale type. Okay, and we'll choose from here. We've got a few options. So if I choose fit start image, will take place at the start position. And if I choose fit center, the image will be seen in the center. And if I choose fit end, guess what? It'll take its place from the end position. Now, if I choose fit XY, image will cover all of image view. But the image will be enlarged and it doesn't necessarily look good. So because of this, fit center is a good option. However, of course, it's up to you as the designer of your application. Alrighty then, so these are the things that we can do on the design page. We can also do something on the Java side using Java code. But before we go to Java side, I need to give this image view an ID, right? So let's give the image view example as an ID. And now let's go to the Java code side. So what can we do here? Well, let's say, for example, when I click on the OK button, the image in image view will change, right? So then we'll see another image inside image view. So how do we do this? Well, first, I'll need to decide and define this image view on the Java side. And I will write the image view image. I'll give it a name such as image, and you can give a name whatever you want. And now I'll need to define its ID inside the onCreate method. And I'll write image equals find view by ID, and inside the parenthesis r.id.image example. I can do every operation on the image view using image word, and I will write operation codes inside the OK button, click listener method. And let me just delete these codes that I wrote before. Now I'll write image.setImageResource. But before we continue, I'll need to do one more thing. You know what that is? I'll need to add a second image in my project. That's right. So I will right-click to my drawable folder on the left side of Android Studio and choose Show in Explorer. Drawable folder opens, and inside the drawable folder, I have one picture, and its name is A. So I will add a new image to this folder and call it B. And now when I close this folder, I can see my picture B in my project. So now I can call this image. And I'll write inside the parentheses r.drawable.b. All right, everything's okay now. So when I click the OK button, the image will change to image B. Good. So let's run it and see if it's working or not. Application opens. When I click OK, image changes. So you see how you can do a lot of operations like this, but I think it's enough for this video. Play around with that, and I will see you in the next one. Checkbox. Hello, everyone. Today we're going to talk about the checkbox. It's very important. That's why I've devoted a whole video to it. So the checkbox is yet a different type of component in Android Studio. It is a kind of a button. It just accepts two positions, checked or unchecked. And it's often used as a component while developing Android applications, so we need to talk about it. Let's say, for example, that we want to develop a survey application or even a note-taking application. We'll pretty much want to use that checkbox, right? So let's go to Android Studio and see it in practice before we lose any more time. So we have an earlier Android project from before, yes, and we will continue to build on this project. And what I'm going to do is add two checkboxes to this project. And the checkbox is under the Buttons section in the palette window. And I'll just drag two checkboxes and drop them here. Now, what should we do with these checkboxes? Okay, so let's say, for example, asking for the gender of the user, right? So we'll have two checkboxes. One is for male, second one is female. whichever one the user checks, we will write its gender into the text view here. And let's look at some of the features of the checkboxes. So we can define its height and width from here. And I can change the layout width from the match parent to the wrap content. And now its width is wrap content, but it's placed in the center, right? So that's because we defined gravity of the linear layout center horizontal. So let's do the same for the second checkbox. Okay, so now the two of them are placed in the center. So let's ask a question to the user. And for that, I will need to change the text of the text view and write what is your gender. And then the user will give an answer to this question, male or female for now. This is just an example. And I will change the text of the first text box to male and the text of the second box to female. All right, so what do you suppose we can do in here with these checkboxes? First off, let's define the default position for the checkbox from here. We can choose checked or unchecked as a default. And let's continue. So I'll change the text color of the checkbox to white. And I'll do the same for the second checkbox. And let's make the layout margin from the top 10 dp for the first checkbox. Yeah, do the same for the second. If user checks male, text of the text view will change to male. And if user checks female, text of the text view will change to female. Okay, so now we'll need to give an ID to these checkboxes. So I will give the ID checkbox male for first checkbox and checkbox female for the second. Okay, so now we got to go to the Java side. And I'll go to the main activity. Okay, so first up on the Java side is define the checkboxes. So I will write right here, checkbox. And, you know, if I click here, it will import the checkbox class. But I don't want to do that, so don't get ahead of me. So before the import checkbox, it's red. So I want to show you yet another import method. So when the checkbox is red, you can see a small lamp here. You see that? When I click this lamp, I can see the import class option. So I'll click the import class option and it will import the checkbox class. And that way I can put names to these checkboxes, male and female. So these names are my choice. Of course, you can give the names to be whatever you want. And now I need to assign these IDs to these checkboxes. And I will write male equals find view by ID r.id.checkbox male. And for the second checkbox, female equals find view by ID r.id.checkbox female. Then after that, I'm going to add a click listener to the male. So when the user clicks the checkbox, it will do these operations. And I'll write them here. Male dot set on click listener, new view on click listener. So now I can write my codes inside the onClick method. And now there are two options for the male checkbox, checked or unchecked. And I will write if male dot is checked, This will control the checkbox is checked or unchecked. So if it is checked, it will return true. And if it's unchecked, it will return false. Okay, so quiz time. If it's checked, what's going to happen? I want to write mail to the text view. So I will write result.setTextMail. Now, why did I write result? Because we gave result to the text view as the name from before. So if it's unchecked, I will write this question again, and I will write else, and then inside the brackets, result.setText. What is your gender? And I can do the same thing for the female. Female.set on click listener, new view on click listener, and inside the on click method, if female is checked, result.setTextFemale. And if female is unchecked, result.setText, and question again, what is your gender? Right? So now that I break it down, it's pretty simple, right? So let's run it and see what happens. So the application is opening, and it's fully open, and you see if I check mail, text of the text view is changing to mail. Now let's uncheck mail. Text of the text view is changing to the question again. And if I check female, text of text view is changing to female. And if I uncheck female, text of the text view is changing to the question again. But I don't know if you see, we seem to have a problem here. What if I check both of them, right? So for this example, I really don't want to let the user check both of them. So what am I going to do? How do I avoid this? We're going to need to write some extra code. So I'm going to do this here. If male is checked, female must be unchecked. So I'll write female.setCheckedFalse. And then this code defines the position of the checkbox. If it's true, checkbox will be checked. If it's false, checkbox will be unchecked. So with this code, if the male is checked, female will be unchecked. And I will do the same for the second checkbox, right? So this time I'm going to write male.setCheckedFalse. If female is checked, the male will be unchecked. So let's run it again just to make sure. Okay, so there you go. It's working now. So when I check male, female is unchecked. When I check female, male is unchecked. Okay, so I think that's enough for this video, don't you? See you on the other side. We got another video coming up. Radio buttons. Hello, everyone. I want to talk to you a little bit about radio buttons for this video. Radio buttons are similar to checkboxes that we spoke about in the last video. Radio buttons are inside a group, and the user can choose one option from this group, one option only. So radio buttons are separate from checkboxes with this feature, right? So, for example, you can use radio buttons on a test application where there's only one answer. The user can choose only one option from the answer. Yeah? You can use radio buttons to get information from the user, sort of like checkboxes. But the checkbox, there's two options for one checkbox, right? It's either checked or unchecked. But for radio buttons, the user has to choose one option from the group. Also, one option is chosen by default. So let's go into Android Studio and see it in practice. All right, so we had a project from the last video. Let's continue on that one. And the radio buttons are under the buttons section. But before we add radio buttons, we will need to add a radio group. And I'll choose radio group from here. Just drag it into the text view. And now we can add radio buttons under the radio group. And I'll add 3 radio buttons here. And now you can see radio buttons, but the other components cannot be seen. So let's check the layout width and the height of the radio buttons. All right, so you can see here that the layout width and height, the radio buttons are wrap content. So we should see the other components normally, but if you check the layout height of the radio group, then you can see it is match parent. So because of this, we cannot see the other components. So let's change it to wrap content, and everything's fine. Now, when I choose wrap content for layout width, the radio buttons will take their place center horizontally. Why? Because we chose gravity of the linear layout center horizontal from before. So what do you suppose we can do with these radio buttons? All right, let's make an example of this. I will give these radio buttons some colors. And when the user chooses a color from the option and clicks the OK button, the background of the main activity color will change to whatever the chosen color is. So let's write the text of the first radio button, green. And for the second one, I'll just write in red. For the last radio button, I'll write yellow. And then when the user clicks OK, the background will change. So let's change the text color of the radio buttons to white. And I can do that from here. Also, I need to give an ID to these radio buttons. So for the first radio button, I'll make the radio button green as an ID. For the second one, I will write radio button red. And for the third one, I'll just write in radio button yellow. Now also, I will define the first radio button to be chosen as a default. And I can do that from here. And I clicked checked option. So after we finish the design, we can then go to the Java side. Now, first of all, we will need to define these radio buttons and the radio group here. And I'll write radio group and give a name, and we'll just call it radio group. And then after that, I'll need to define the radio buttons. So I'll just write in radio button green. When I write radio button, Android Studio imports the necessary class. And then I'll put red for the second button, yellow for the third radio button, and then after that, okay, so I'll need to define IDs for these radio buttons and the radio group. Write in radio group equals find view by ID. But before we continue, I will need to give an ID to the radio group. So we'll go back to the XML page and give it an ID here. And I gave group as the ID. So now I can write r.id.group. And then here, green equals find view by ID r.id.radio button green. And for the red one, red equals find view by ID r.id.radio button red. And lastly, for the yellow equals find view by ID r.id.radio button yellow. Great. So we have now defined our radio buttons. Okay, so what do you want to do after that? So when the user chooses a color and clicks OK, the color of the layout will change, right? Now to do this, I will add a click listener to the OK button. So we've already defined the OK button here. So I will write here OK.set on click listener, new view on click listener. And then inside the on click method, I will write my conditions. If green dot is checked, and again, before I continue, I will need to give an ID to the linear layout. And I will give linear as the ID. And also, I'll need to define this linear layout on the Java side. And I'll write that here, linear layout. And inside the create method, layout equals find view by ID r.id.linear. And now I can change the background color using layout. So I'm going to write here inside the brackets, layout.set background color, and then inside the parenthesis, color.green. And of course, that's my first condition. If the user chooses the green radio button, background color will be green. And then after that, I can write the second condition. Else, if red dot is checked, layout dot set background color, color dot red. And for the third condition, else if yellow dot is checked, layout dot set background color, color dot yellow. So far, so good. So let's run it and see if it's working or not. Application opens. So when the green radio button is selected, click OK. Background color is changed to green. And now I'll choose red and click OK. Uh-oh, the background color is red. Shall we go 3 for 3? I choose yellow and the background is yellow. Now, you should see that I can only choose one option on these radio buttons, right? So pretty much the use of radio buttons is easy. And again, I think it's enough for this video. See you in the next one. Toggle button. Hello, everyone. We're going to speak about toggle buttons in this video. The toggle button gives us two options. Well, technically, it gives two options to the user. It will be on or off. That's the position of a toggle button. The thing is, you define what needs to be done whenever the user turns the toggle button to the on position. It is easy to use, so we'll go to Android Studio and we'll give it a go, see it in practice, because you know what? Time is running. Okay, so we had a project before. Let's continue this project, and we will add a toggle button. Now, you can see the toggle button under the button section. And I'll just drag a toggle button and drop it under the image view. The layout width of the toggle button is match parent. I'll change it to wrap content. And it's centered horizontally. Now, you know that because layout gravity of the linear layout is center horizontally. And now the toggle button will basically have two positions, two options, if you will. I will define what will happen in the on position as well as in the off position. So, what can we make it do when it takes the on position? For example, when it's flipped on, we can make it hide this image. And when it's flipped off, we can show the image again. Also, I'm going to want to change the text of the text view to images hidden when toggle button is in the on position. Okay, so after that, I will change the text of the text view to image is shown when toggle button is in the off position. So let's do this. Before we start, we can change the text of the toggle button. Where do I do that? Well, you know that we've all changed all of the text of the buttons from text attributes, but we're not going to do that for this toggle button. There's another text attribute, and it is text off and text on. Pretty handy. So we will define a text in the text off section when the position of the toggle button is off. And also we can define a text when the position of the toggle button is on. And I will write hide image for the text off and show image for text on. So also we're going to need to give a name to this ID and to this toggle button. In other words, we need to give it an ID. So I will give toggle button show as an ID. So now I can go to the Java code section. Now, first of all, I will need to define this toggle button on the Java side. I will write toggle button and toggle button again. Now, of course, you can give it another name if you want to, but then after that, we will define its ID inside the onCreate method. And I will write here toggle button equals find view by ID, and inside the parentheses r.id.toggle button show. And in order to do the operations on the toggle button, I need to add a listener. Now, normally I would just add a click listener, but for a toggle button, I will add checked change listener. So I'll write it here, toggle button dot set on checked change listener and new component button dot on checked change listener. And I will write my code inside the onChecked change method. So when the checked position of the button is changed, the listener will detect this change and then apply the codes that I wrote here. Now it can take two positions, of course, checked or unchecked, or on or off. So it means that when the toggle button is on, it takes the checked, and the toggle button is off, it takes the unchecked position. So I'll just write it here that if it's checked, and inside the brackets, I will hide image. Okay, so how do I do that? Well, if you remember correctly, or if I remember correctly, we defined the image view here before, and its name was image. So I will write here image.setVisibility view.invisible. Now also I will want to change the text of the text view. We have defined text view here already, and its name was, you remember, don't rewind, result. So I'll just write it here, result.set text image is hidden. Okay? So after that, we can write the else condition. So that means that when the toggle button takes the off position again, I will write here image.setVisibility view.visible. Also, result.set text image is shown. Okay, so let's run it and see if it's working or not. And now the application's open. So you see here on the toggle button, the text is hide image. When I click the toggle button, image is hidden and text of the text view is changed. Cool. Also, the text of the toggle button is changed. So when I click it again, the image is shown and text of the text view changed again. Also, the text of the toggle button is changed to the hide image. So that's, I don't know, I think it's easy. I hope that you think it's easy too. But in any event, it is enough for this particular video. I've got another one coming up, so see you then. Spinner. Hello, everyone. Today, I want to speak to you about Spinner in this video. Spinner is an Android component that we use in Android application development. Spinner opens a list, and then the user can choose an item from the list. So when the user selects an item from the list, some operations can start by choosing the selection. So why don't we go to Android Studio and get to work and do some practice? All right, so remember we had a project before. We'll just continue with the project so that we can see the progress on the build. And we're going to do an example in this video. So let's set up the example project just like this. There's a list of countries. And when the user selects a country from the list, the country name will be written here on the text view. So for example, if I want to select Germany, then text view will display Germany. If I select the Netherlands, on the text view, it will write Netherlands. Right, so this is how Spinner works, basically. So why don't we start to do this in the application? So first of all, we need a spinner. But before I add Spinner here, I want to add a new horizontal linear layout here. And I added this layout under the image view. I'll add Spinner under this layout. And Spinner is under the container section. Also, I'll add a text view. So this text view will display and explain what the user will do with this spinner. And you see that the other components are not seen. And here I can change the height of the new linear layout to the wrap content. And now you can see the other components. So also, I want to change the width of the spinner to wrap content. And now we have a text view and a spinner. So I'll change the text of the text view. I will write it here to select a country. I'll also change the text color of text view to white. Okay, so now we need to give an ID to the spinner. All I do is write spinner country. And then after that, I just need to fill in the spinner. Now to fill in the spinner, I will create an array. I'll do this under the values folder in the strings XML file. I'll just open the strings XML file and write here string array. Now I need to give a name to this array. The name could be, I don't know, countries. And I will write between the string arrays items. I'll write an item here. And I will write the country names between two item XML code. So every item is an element of the array. All right. So the first country should be England. Second is Netherlands. Third is Belgium. Fourth is Germany. And fifth is Finland. Okay, so now we have 5 items inside the countries array. All right, so the spinner is ready, and also the array is ready. So now we can go over to the Java side. So first, I'll define spinner. I'll just write here spinner. Also, the name could be spinner again, doesn't matter. Well, I mean, for me it does because I like clarity. And then inside the onCreate method, spinner equals find new by idr.id.spinner country. All right, so now I need to take a moment to explain a very important bit here. We have a spinner and we have an array. To transfer information from the array to the spinner, I'll need to create an adapter. So in this case, what is an adapter? So let me just show you with a picture, because it's very important. I want you to have a look at this in detail. We will use the adapter in some of the other components as well. So now we're going to use this adapter for the spinner, but we'll also use it for the list view and the grid view for some of the next videos. So we will call the adapter, and then what makes a connection between a data set and a view. In this example, the data set is array list and the view is spinner. Then we need to create an adapter between the array list and spinner. And I'll just do this in the main activity using Java code. So I'll write here array adapter, and its name is adapter. And I'm going to define this adapter inside the onCreate method. So here the adapter equals array adapter.create from resources. Now I need to define 3 parameters in here. First is context, and I will write here. All right, that's right. So this means that this adapter will work in this class. The second parameter is array ID. And I'll write r.array.countries, and I'll define array ID to the adapter. Now the third one is the spinner layout. I need to specify how each item looks inside the spinner. So I'll write android.r.layout.simpleSpinnerItem. So now I need to specify the drop-down layout. I'll write adapter.set drop-down view resource. And then inside the parenthesis, android.r.layout.simpleSpinner drop-down item. And now the adapter's ready. I'll just need to assign this adapter to the spinner. How do you do that? I will just write spinner.setAdapter and adapter. So now these codes will fill in the spinner with the countries array. Now, let's check it just to make sure that we have done this so far so good. You with me? Okay, so the application is open. And in the text view, writing select a country, spinner filled in with the country names. So what have we done up until this point? We have created a spinner and a data set, and then we have connected the spinner and the data set using the array adapter. And then after that, we needed to do one more thing. When the user selects a country from the spinner, the name of the country should be written in the text view. So let's continue. I'll need to add a listener to the spinner. And this listener is set on item selected listener. And inside the parenthesis, new adapter view dot on item selected listener. So when I write this code, two methods are created by Android Studio. First one is on item selected. The other one is on nothing selected. So I'll write my codes here. When the user selects an item from the spinner, this method will work, and I will write here parent dot get item at position. And inside the parenthesis, position. Okay, so now what will this code do? It will take the text of the item in the selected position. And then after that, I will assign this text to a new string. So I've created a new string, and its name is country. And lastly, I will write result.setText and country. And now this code will get the country name and write it on the text view. All right, so let's run it again and look. Oh, I get excited, I know. Okay, so the application is open, and when I select Netherlands on the text view, it will write Netherlands. And when I select Germany, it will write Germany on text view. And which item I select from here, it will write the name of the item onto the text view. And that's the way the spinner works. So I think that's plenty for this video. I will see you next video. Toast message. Hello, everyone. In this video, we're going to talk about toast messages. And before you pick up that drink, listen to me. The toast message is used to show short time information to the user. So in other words, let's say that when a user clicks a button or opens a new window, or you want to give some kind of information to the user, that's when you use the toast message. So let's go to Android Studio and see it in practice before we lose any more time. You can pick up that drink now. All right, so you know that we have a project that we've been working on, so let's continue working on this project. But before we start, let me just show you a toast message. So you see here when I click the OK button, a toast message displays. And the message is, this is a toast message. So after a while, the toast message disappears. You can show this toast message whenever you want. I display it whenever the user clicks the OK button, but you can display it when the user, clicks an image or downloads something. So why don't we look at how to actually do it? So displaying the toast message is pretty simple. We don't have to do anything on the design page. We'll do it just right here on the main directory.java page. So what I want is when the user clicks the OK button, the toast message will be displayed, right? So I'll just add a click listener to the OK button. And I defined the OK button before You can see it here. And I'll just write inside the onCreate method, OK dot set on click listener and new view on click listener. And after that, inside the onClick method, toast dot make text. And after make text, it will get 3 parameters. The first one is get application context. Second one is message, and I will write a message inside the quotation marks. So what I write inside the quotation marks will be shown as a message. Message is, this is a toast message. Now the last parameter is how long the toast message is shown for. There are basically 2 options here, toast.long and toast.short. So I'll just select the first one, and then after the parenthesis, I will write .show. And guess what? That's it. Your toast message is now ready. So why don't we run it and see? The application's open, and when I click OK, the toast message displays. And then after a while, it's gone. So I think that pretty much covers the toast message. I'll see you in the next video. Snack bar message. Hello everyone. In this video, we're going to talk about the snack bar message. Now, okay, before you start going to the obvious, like I wanted to, the snack bar message is a message method to, well, impart information, not wisdom, just information to the user. So it kind of looks like a toast message, but it's a little different. So it's displayed at the bottom of the device screen, and it has a close button in order to close the message whenever the user wants. So let's have a look at it in Android Studio. And of course, you know by now that we have an Android project here, and I'll just continue building this project. But before we start to create the snack bar message, I want to show you how it's going to work. So when I click the OK button, it'll display on the bottom of the screen, and when I click the close button, it will close, right? So in here, this is the message that is what we call the snack bar message. So you can give a message to the user here. You can see the difference between the toast message and the snack bar message here. So in the toast message, the message is shown, and after a while it disappears. Also, the user cannot close the toast message. But in the snack bar message, the user can close the message whenever the user wants. All right, so let's create a snack bar message. It's pretty similar to the toast message. There's not much on the design page, and we will create it on the Java side. So what will we do? Okay, so let's say that when the user clicks the OK button, the snack bar message will display. And to do this, I'll just add a click listener to the OK button. All right, so after this, we need to do one more thing. We need to define where we will show this snack bar message. And let's just show it on the main activity layout and on the linear layout. So I'll need to define the linear layout on the Java side. Now to do this, I'll need to give an ID to the linear layout. Of course, I've done this before, and the ID is linear. Also, I define linear layout on the Java side with this ID, and its name is linear layout. Okay, so after I do that, I'm ready to create the snack bar message. And what will I write here? OK dot set on click listener. New view on click listener. And I will create a snack bar message inside the onClick method. And I'll just write snackbar.make. It'll take 3 parameters inside the parentheses. So let's see, for the first one, that's where I will show this message. And I want to show it in a linear layout. So I will write here linear layout. The second one is message. So I will write my message inside the quotation marks. The message is, how about this is a snack bar message. And the third one is how much time the message will be displayed for. So here it gives you 3 alternatives: long, short, and indefinite. So in the long and short, the message will disappear after a while. But in the indefinite, the message will not disappear until the user closes it. All right, so I will choose indefinite. And then after that, I just write dot set action. Now, this also accepts 2 parameters. The first one is text of the close button. And let's just give it some text for the close button. And I'll write here close, but you can, of course, write whatever you want. And the second is click listener. Now, I'll need to define a new click listener, because when the user clicks the close button, the snack bar message needs to be closed. So when I add click listener, Android Studio understands this is for close snack bar message. And I don't need to write anything inside the click listener. And then after that, I will add here dot show. And that should do it. Snack bar message is now ready. So let's run it. Okay, so the application opens, and I'll click the OK button, and the snack bar message is displayed. And then when I click the close button, the snack bar message disappears. So let's see what happens if I choose snackbar.length short. Let's run it again. So this time when I click the OK button, the snack bar message displayed, and then after a little while it disappeared itself. So this is how snack bar message works, and I think it's enough for this video. So I will see you in the next one. Dialog messages. Hello everyone. This is the video where we're going to talk about dialog messages. So a dialog message is another message type to give information to the user. Now, of course, unlike the other messages, the user interacts with a dialog message. So in the dialog message, a small window opens, and the user is informed. And then after the information, the user decides what's going to happen next. So you can see how the dialog message, how it's going to work in a lot of different applications. You probably already recognize it. Let's say, for example, if you want to delete something, a dialog message opens and then asks you, hey, do you really want to delete this? And then after that, if you really want to delete it, you can click yes. Or if you don't want to delete it, you can click no. Another example could be if you want to close an application. A dialog message is shown, and then after that, you can choose to close it or not. So dialog messages are probably one of the most used messages, so why don't we just get to it and open up Android Studio and see how to create it. Now, of course, you know that here we are back in our project, and we will continue to build it. And this is what we'll do. So we have a button here. Its text is delete text of text view. And also we have a text view here. So when I click this button, it will show me a dialog message before it deletes the text. So then after that, if I click yes, it will delete the text. If I click no, it will not delete the text. Now, before we start, I just want to show you what it will look like. Okay, can you see? When I click the delete button, it's asking me, do you want to delete text? And there are two options, yes and no. And when I click no, it disappears. When I click yes, it's deleted. So, let's create it. So we create dialog messages on the Java side. So where will I write my code? When I click the delete button, I want to create a dialog message. And this is the delete button. We defined it before. Its name is OK. So I added a click listener to this OK button. So now I can create a dialog message inside the click listener. I'll write a method. Its name is show dialog message. And I will call this method here. But I'm going to write this method below because I don't want to mess in the onClick method, right? So I can do it in two ways. First one is I can write this method myself here. The second way is I can click this red lamp and choose create this method. So after that, I'll need to choose the main activity here. And it created this method automatically. So now I will create a dialog message in here inside this method. Name of the dialog message is alert dialog. Okay? And then I'll write here alert dialog.builder. And after that, I'll need to give a name to this alert dialog message. And I'll write alert dialog equals new alert dialog builder. And I'll write inside parenthesis. So when I wrote this here, I defined the context. So it will work on this activity. So I created a dialog message and give it a name, alert dialog. Okay, so now I need to define its features. So I'll write here alert dialog dot set title. And then whatever I write here will be shown as a title. And you can see that here. Delete is the title. So now I need to define this title, and I'll write inside the quotation marks, delete. Okay, so I'll continue. I write here dot set message, and I will write here my message that I want to show to the user. You can see here, message. Message is, do you want to delete text? Okay, so far so good. So after the message, I will define the yes and no button. And how will I define these buttons? I'll write this here, set negative button. Negative button is no. So now I need to define the text of the button. I will write inside the quotation marks, no. And then after that, I need to add a listener to this no button. Because when the user clicks no, it needs to sense that and trigger some operations. So I will write after the comma, new dialog interface dot on click listener. So now when the user clicks on no, I'll write down what I want it to do. Also, I need to define the yes button. So I can just write that here, dot set positive button, and inside the parentheses, I will write the text of the positive button, yes, and I'll add a click listener to this yes button as well. Now when the user clicks on yes, I'll write down what I want to do, and then after that, I'll just write here dot show. And then what that does is it shows the dialog message. Oh, and lastly, I will write alert dialog dialog.create. So that should be pretty clear. It's a few steps, but I hope you understood. I created the alert dialog here, and I defined the title here, and defined the message here, and defined the yes button here, and then added a click button to this yes button. Now also, I defined the no button here and added a click listener in the same way. And I added here the show and writing alert dialog.create. Alert dialog is now ready. So after that, I'll need to specify what will happen when the user clicks on no, right? So when the user clicks no, the alert dialog will be closed. So what will I do? I'll write here dialog.cancel. So also I'll need to specify what will happen when the user clicks yes. When the user clicks yes, text of the text view will be deleted. So we defined this text view before. Its name was result. And now I'll just write it here. Result.setText. And I won't write anything inside the quotation marks. And that way the text will be deleted. So why don't we have a look? Let's run it and see. Applications open, and when I click the delete button, the alert dialog opens, and let's see what happens if I click no. The alert dialog is closed. If I click yes, it deletes the text. Great, so this is a fairly simple but accurate example of two buttons for the alert dialog. So there are other types of dialog messages. We learned this type, and we will see some other types in the next upcoming videos. So I'm excited. I hope you are too. I'll see you in the next video. To the button. So now I want to show you how this design will be seen on the different screen sizes. You can change the screen types from here. Okay, so for example, I use 5 ink, 1080 by 1920, 420 dpi pixel screen. And I'll change 5.5 ink screen size, and now look at my design. Look at how that's seen. And you can see it here. Constraint layout. Hello everyone. This is the video where we're going to talk about constraint layout. So as you know, I mentioned about the constraint layout in some of the previous videos, but I didn't really give you much information because I wanted to make a separate video on this topic after you learned a few of the skills. So the constraint layout has appeared with Android 3.0, and the constraint layout is an advanced model of the relative layout. Now, if you remember the relative layout, the components can take places according to each other's positions or relative to each other's positions. But there could arise some problems with different screen sizes. So we won't be able to, get the full performance for different screen sizes in that relative layout. But with the positions and screen edges. So that way, these are the features that solve most of those problems and give us some flexibility in order to create different views for different applications on different devices. The constraint layout is a basic layout in Android Studio 3.0 and higher versions. So before any more delay, let's get to Android Studio and see constraint layouts in practice. So of course we have this project from before and we're continuing to build on it. Is linear layout. And now I want to show you how you can change this linear layout to the constraint layout So I'll go to the XML code of this activity and delete linear layout. And then after that, I'll just write constraint layout. List view. Hello everyone. So this is the video that we're going to talk about list view. So list view is of course used to show a list of items to the user. Now you can see an example of it in the picture. So for example, you can use a list view in the phone contacts application. You can show phone numbers and names in list view. And of course, the action is when the user clicks a name, the phone calls a selected person. Or you can also use the list view in a message application. You can show the message list in list view. You can give a lot of examples about the use of list view, so I'm not necessarily going to give them all. But the logic here is you will show a list of items in list view, and when the user chooses an item on the list, it will do a particular action. So why don't we just get right to it, get to Android Studio, and we'll see it in practice. So of course you know that we have a project lurking here that we've been building on, and we'll continue to build this project. But before we start to create a list view, I want to show you what it will look like when we finish. So you can see here, there is a country list. And when the user clicks a country on the list, a toast message will appear, and it will write each country that is selected by the user. So let's see how we can do that. So here we have a constraint layout. And I'll add a list view to this layout. And where is list view? Well, it just happens to be under the legacy section. So I'm going to drag and drop this list view. And now we have a list view. So after that, we need to fill in the list view. So we'll need a list of a few items. So what is our list of items? It's country names, that's correct. And I will create an array with country names. Remember, where do I create arrays? I'll create it inside the strings.xml file under the values folder. And I'll open the arrays.xml file. And I created an array with country names before. And because I don't want to take too much of your time, you can do that yourself. And all you do is just write the string array and give a name to your array. And then after that, you'll just write every country name between two item XML codes. Everything you write between two item XML codes will be an item of the array. Okay, I wrote 16 countries names here, and so that means my array has 16 items. And now we have an array and a list view. So we can go to the Java side now. Come on, let's go. So I'll define list view and array on the Java side. I will write here list view, and after that, I need to give a name to this list view. So I'll give it the same name, list view. And also, I need to create and define an array. So I will write here array. And the name of the array would be countries as well. When I add closed brackets after the array name, Android Studio will create an array and its name will be countries. And then I will fill in this array with inside the onCreate method. Now we'll write inside the onCreate method, list view equals find view by ID. And what was the ID of the list view? If you don't remember either, I will go back to the design page and check it. We did not give an ID to this list view. So I will give it list as its ID. And now I can go back to the Java side. So I'll write inside the parenthesis r.id.list. In the second line, countries equals getResources.getStringArray r.array.countries. And do you see that? We've got an error. Okay, so this is good because we can learn how to solve errors, right? Okay, so what is my error? So I created the array wrong. So I need to define the type of the array. So I will change it to string countries and close brackets. So string is the type of array. Countries is the name of the array. And close brackets creates array. So now the countries array is filled in with the country names. Cool. All right, so now we defined list view and array. So after that, we need to connect this list view and array to each other. How do you do that? Okay, I guess you're relying on me. So we will use the adapter for this. I heard some of you out there thinking it. So what is the adapter? Some of you may remember, some of you may not, so I'll just let you know that the adapter connects a data source and a view to each other. So the data source, in this case, is array, which is in here. View is list view, and I need to create an adapter. So I'll write here, array adapter, string adapter. And in the onCreate method, adapter equals new array adapter string. And adapter will take 3 parameters. First one is context. That means where this adapter will work. And I'll just write here this. So it will work in this class. Now the second is the list view layout. So I need to define how the items will be seen in the list view. So there are predefined layout designs, so I can choose one of them. And I'll write here android.r.layout.simplelist item 1. And then the third one is the array name. So I'll write here countries. Now because the array name is countries, well, makes sense. And now after that, I need to assign this adapter to the list view. So go in here, list view dot set adapter, and that's it. And the list view is ready and it's full. So we filled in the list view. Let's run it and see it. All right, so the application is open. Now we transferred the country names to the list view. But when I click on an item in the list, nothing happens. It needs to show a toast message with which country I clicked. So we filled in the list view, but we did not define what will happen when the user clicks an item. All right, let's do it right now. So I need to add a listener to the list view. I'll write it here. List view dot set on item click listener. New adapter view dot on item click listener. I'll write my codes inside the on item click method. And I will write here parent dot get item at position. When I click an item on the list, it will return an integer. So if I click on the first item, it will return 0. If I click on the second item, it will return 1. Click on third item, it'll return 3, and so on. So that means it will take the next of the items that I clicked from the list view. So I'll need to convert it to string. So I will add dot to string. And now, so we took the text of the item I clicked and convert it to the string. And after that, I need to assign it to a string container. And I will create a string with its name as country. And now I can create a toast message. So I will write toast.makeText. And the toast message takes 3 parameters, and we talked about that before. The first one is get application context. Second is message. I'll write my message inside the quotation marks. The message is you selected plus country name. So whichever country I choose, it will write first you selected, and then after that, add country name. And then the last parameter is how much time it will stay on the screen. So I'll just write toast.length_long, and then lastly, .show. All right, so now it's ready. So let's run it again. Application opens. So when I click England, it writes in the message, you selected England. And when I click Netherlands, it writes you selected Netherlands. Let's click Germany, and it writes you selected Germany. And I'm sure it'll continue on like that. So that's perfect. That's how list view works in this video. Okay, so it's just the basic use of list view. There are, of course, a lot of ways that you can use list view, but I think it's enough for this level. So go back and practice if you want to. We'll finish up here, and I'll see you in the next video. Recycler view. Hello, everyone. So in this video, we will speak about the recycler view. So recycler view is an advanced model of list view. So as you know, when we spoke about list view in the previous video, we covered most of its basic function. Recycle view is used to show a group of information to the user, like list view. And when the user clicks one of the sort of information groups, recycle view will do a particular action. Okay, so recycler view gives the developer more comfortable, shall we say, working features. You can see it here on the right side picture. This is recycle view. So it'll do an action when the user clicks one of these items. Also, you can do your design in recycle view as well. So the list view shows information from top to bottom. Recycler view can show you information both from top to bottom and from left to right. So let's go to Android Studio and see how to create a recycler view in practice. All right, my friends. So first of all, I want to show you the finished version of the application that I've made with recycler view. So as you can see, here are the country flags in a circular image view. And again, here are the country names and the related flag information. Now, of course, this information is displayed in the recycler view here. So we will also create a card view, and that design will be here as well. So we'll always try to use recycler view in conjunction with card view. And you can increase the number of categories here. So also, when we click on any category, a toast message will be displayed indicating that we clicked on that category. And the final version of our application will look just really similar to this. You might customize it a little bit differently, but it's generally going to look like this. So I'll tell you that recycler view offers us a more flexible operation compared to the list view component. So if you if you notice, here we can curl the corners of card designs. We can leave a space between the cards. We can color the cards. So in general, our Recycler View application will kind of look like this. So let's start making our project. So first I'm going to create a new project. Click on the File tab in the upper left corner. Click on New, New Project. And after selecting Empty Activity from the page it opens, I'll just click the Next button. I'll make the name of the project Recycler View Example. But of course, you'll be able to type any name. I'm not looking, I promise. The package name will be, as shown here. I don't want to change the location where the project will be saved, but of course that is up to you. Just remember, and then you can click here. Now the minimum SDK can be API 21. All right, so finally, let's start creating our project by clicking on the Finish button. So our project is currently being created, and you can wait for just a little bit. And sure enough, as you can see, our project has been created. So first, let's go ahead and do the design of our application. So to do that, I'll open the activity main.xml, and we can close the project directory just by clicking the icon here. I choose the Show System UI option. So the design area will look like a phone screen. So now let's delete the XView component here. All right, so I've completely emptied my design area. We'll add in a Recycler View component to the design area. For this, I'll choose a Recycler View component from the palette. And here I have to tell you this. In order to use the Recycler View component, you will need to add the material design library to your project. I'm sure you don't remember, unless maybe you've heard about it, but in previous iterations of Android Studio, we had to manually add this library to the dependencies section in the Gradle build file in the project directory. But with all the new updates, the material design library is now automatically added to the project. And that means that we can just go right ahead and use the Recycler View component directly. Excellent, excellent. So if you see a download button right next to the Recycler View component here, just click on it, and that'll add the material design library required to use the Recycler View component to your project. Otherwise, you won't be able to use the Recycler View component, right? And of course, if you're using the current version of Android Studio, the material design library is automatically added to your project, and you can just use Recycler View component just like we're doing. So now I'll drag the Recycler View component and drop it on the design area. And what do you know? It takes up the entire design area. Since our root element, that is the bottom layout, is the constraint layout, I have to determine the constraint values of the Recycler View component. So for that, I can just pin the Recycler View component up, right, down, left from the layout part in the attribute section. Also make sure that the constraint values remain 0, and that way they'll fill the screen completely. All right, cool. Now let's set the ID of the Recycler View component. I'll write Recycler View to the top ID section. You can specify the ID as you wish. I'll create the ID just by pressing Enter on the keyboard. So actually, this is the design of the main activity. If we want to show some data in the Recycler View component, well, we'll have to make a separate design for that later. Now, as we carry on with our course, we will import this design into the recycler view with an adapter class. But at this point in the design, it's just going to be a card view, all right? So let's get started making our design. First of all, I have to create a new design file. So for this, I'll select the layout folder under the resource folder from the project directory and right-click with the mouse. And here I'll choose New Layout Resource File options from the drop-down menu. And here we'll just determine a name of the layout design that we will create from the window that opens. Write card design in the file name section here. You can give any name that you want. However, leave the root element as constraint layout. Cool? All right. So I'll press the OK button without changing anything else. And as you can see, a new design file has been created under the layout folder. So whatever design that we want to appear on the screen, we must design it in this layout. Now we can start making our necessary design. We can close the project directory and we'll move the design area a little closer. So first of all, we'll add a card view component to the design area. So if you type card view into the search bar in the palette, you can see the card view component. So what I just explained for the recycler view, that is the material design library, has been added to the project. So it's also valid for card view. And, just to make your study complete, in previous versions, we could use the card view component manually by pressing the download button right here. So if you are working with an older version, that's probably what you're looking at. But now it's automatically implemented in the project. So I'll drag the card view component and drop it in the component tree area this time. And you can drag and drop components into the design area or the component tree area. So as you can see, the card view component took up the entire screen. And if we look at the application once again, we can see the area covered by the card view component. So in other words, the height of the card view component will be just like this. It'll take up this much space on the screen. So we'll set this up in a moment. Now let's add the image view and text view components to the design area. Now, at this point, I got to say that we're not going to directly import components into card view. First of all, we will place a layout inside the card view component. Then we will transfer the components into this layout. You follow? So for this, I'll choose one more constraint layout from the palette and drag and drop it into the card view component. So now let's determine the height of the constraint layout component. I'm setting the layout height value to 75 dp. We must also set the layout height of the card view component to wrap content. Now, as you can see, the height of the card view component is about 75 dp. And another point that you'll need to pay attention to here is you should change the height of the constraint layout component, which is the root element, to wrap content. Otherwise, only one card view component will appear on the entire screen, right? So after doing all these operations, we can transfer the image view and the text view components to the design area. Notice that there are one image view and two text views in the design area. The image view components are circular, not square. So our images will look a little rounded. So to get this look, we'll need to add a different library to our project. So for this, I'll open my browser and I'll write circle image, view, GitHub in the search bar. I can click on the first result and scroll down the opened GitHub page. And you can see the necessary library to show your images in circular form. So we have to add the library here to our project. I choose a library here, and I'll just copy it. Now I can open the build Gradle file under Gradle scripts in Android Studio from the project directory. So here we'll just paste the library that we copied into the dependencies section. Then after doing this, I can press the Sync Now button in the upper right corner of the interface. That way we'll add the relevant library to our project. Cool. So as you can see, sync is now complete, and we can proceed with our design. All right, so first we can add an image view into the constraint layout component. And of course, this time we'll not select the image view component from the palette. If we select it from the palette, we'll get a square image view instead of a circular view, which is what we're going for. So to add that circle image view, I'm going to select the split option on the right and open the section with the XML codes. So this way I'll create the circle image view component in the innermost constraint layout. After creating the less than sign and typing DE, we can access the circle image view component. Now you can create the circle image view component by selecting this component and changing its related properties. Now there is a second method to do this. On the GitHub page where we've provided the relevant library, you can copy the XML code block here and paste it into the tags of the constraint layout component in the design area. So yeah, that's it. Of course, we did not transfer the images that we will use to our project yet. For now, let's move the country flags to the drawable folder. I'll select the drawable folder in the project directory. After right-clicking with the mouse, I'll select the Show in Explorer option. And from the window that opens, I'll open the drawable folder, not the drawable v24 folder, my friends, only the folder that says drawable. Now I can select the 3 flags that I have previously obtained from the internet and drag them into the drawable folder. All right, so that way we have now transformed the images that we will use to the drawable folder. Now, as you can see, these 3 images have been added to the drawable folder. Cool. You can view the images by double-clicking the mouse. All right, so now let's continue where we left off with the design. I can write the name of any of my images inside of Profile. If you notice, we have determined the height and the constraint layout of the component as 75 dp. But here, the height of the image is 96 dp. Therefore, part of the image is not visible on the screen. So what I'll do is I'll change the height and the width of the image to 60 dp. Notice that the components are marked in red because we're using the constraint layout and we haven't pinned the components yet. So we still haven't set their constraint values. If you want, we can determine the constraint values now. So I'll choose the card view component and pin it to the left, right, and up. So now let's pin the circle image view component and pin it to the left. Also, I will center the circle image view component vertically. I'll right-click with the mouse and select Center Vertically. And that way we have now centered the image view component vertically. Notice that the margin start value of the image view component, you see that? It's 0, right on the left of the screen. There it is, 0. Well, I'm going to want to leave some distance here, don't you think? So what I'll do is I'll make the margin start at 5. Now let's add some text view components. I'll select the text view component from the palette and drag it to the component tree. And when you drag the components to the component tree, the components are positioned in the upper left corner of the design area. Cool, so let's pin this. Now let's add the second text view component. So what we'll do is we'll determine the constraint values of the text view components. I'll pin the first text view component to the left. I'll choose the second text view component and pin it to the left. And I'll now select both text view components, right-click with the mouse, select Chains, Create Vertical Chain as my option. Thus, both text views will be connected to each other at equal distances vertically. Since there will be country names in the first text component, I want it to be more specific. Now, the second text view component can remain in the background. Therefore, I'll choose the first text view component. First, I'll determine its ID, and I'll write text view country name. Now, let's increase the text size. So if we do 24 SP, I think that'll be fairly obvious. I'll also make the text color black. So now we can select the second text view component, edit its ID as text view detail. Press enter on the keyboard. Now we can change the text size. I'll just make the text size 16, and I'll not change the text color. So it'll stay that way. And finally, let's change the ID of the image view component. I'll change to image view. All right, my friends, we actually finished our design in general. However, I would like to show you a couple of advantages of using the card view. So we'll select the card view component and just look at the attribute section. Now notice here, the card corner radius feature. All right, so using this feature, you can curl the corners of the card view component, like I mentioned before, maybe. But for example, let me just make this value 7 again. So by using the card elevation feature, you can add height to the card view component. So this feature is also 7 dp. We can also leave some space between each card view on the screen. So for this, let's select the card view component. I'll write margin into the search bar in the attributes section, and I'll make the layout margin value 7 dp. And as you can see, there is some space around the edges of the card view component. That's cool. So after selecting the card view component, we can change the background color just by using the background tint property. You can choose any color that you want to from the color palette here. And if you want, we can choose a yellow color. So yeah, notice here that you can see the gap in the edges and the curvature in the corners of the card view component. All right, so we have completed our card view design. Now, I want to show you one more feature in order to learn how the card view design we made will look in the recycler view. In the activity main design from the attribute section, of course, we must select the recycler view component. Otherwise, we will not find the feature that we're looking for. So after selecting the Recycler View component, we can select the card design that we made by using the list item feature. All right, so that way we can see in advance how our card design is going to be displayed on the screen. So when we run the application, our screen will look like this. All right, so we've finished the design section, my friends. We'll take a short break here, and I'll see you in the next lesson. Well, hello, my friends. So in the previous lesson, we completed our design. So we'll do what we'll have to do for coding in this lesson. So I hope you're ready to get started. I'll open up the main activity.java class. Now, first we've got to define the components that we've made. And of course, we will define only the recycler view component in the main activity. We'll define the components that we use in the card design in the adapter class, and we're going to create that shortly. So for this, I'll write private recycler view, and I'm creating an object called recycler view. So now in the onCreate method, I have to match the recycler view with its ID. So for this, I'll write recycler view equals find view by ID. I'll write r.id.recycler view in parentheses, because we gave this ID to the recycler view component in the design area. So also I'll need to determine how the data will appear on the screen. So I've got to determine whether the data will be displayed to the user in horizontal or vertical format. So for this, we can use the recyclerView.setLayoutManager method. Then after writing new in parentheses and press the Control and Space button, we come across many different options. So if you use the Linear Layout Manager method, your data will be displayed to the user in a single column from top to bottom. And in this case, it will be sufficient to just write context in parentheses. Now, if you use the Grid Layout Manager method, your data will be sorted from top to bottom, but you'll also have the chance to specify the number of columns. So you can view your data in 2, 3, or more columns. And in this case, you've got to write the context and the number of columns in parentheses. And finally, if you use the staggered Grid Layout Manager method, you will be given a chance to display your data vertically or horizontally besides the number of columns. So in this case, we've got to specify the number of columns and the way the data is displayed in parentheses. All right, my friends, so those are the 3 different methods to display data on the screen. All right. Now, since we will display the data one underneath each other, we'll choose the Linear Layout Manager method. So that means we must write the context parameter in parentheses. So context represents the activity that we are in. That's why I'm writing here main activity.this. Okay. So we defined the recycler view component. Now we need to transfer the country flags, country names, and detail information that we will show on the screen into the arrays. So for this, I'll create 3 array lists. Let's create the first array list. I'll write private array list. I'll create tags by pressing the less than button on the keyboard, and I will create this array for country names, so the type of the array will be string. I'll set the name of the directory as country name list. I'll write equals after typing new. I'll select the array list option by pressing the Control and Space keys on the keyboard. Cool, so now let's create the second array list. I'll create the second array list for detail information. So the type of the array will be string again. I'll set the name of this array to be details list. Now let's create the third array list. I'll create the third array list for country flags. So we'll keep the images inside the array. And the images are kept as integers in Android Studio. So the type of the third array will be integer. I'll set the name of this array as image list. All right, so we defined array lists. Now let's add the necessary information to these array lists. First, I'll add the country names. So for this, I'll write the name of the array, that is the country name list, using the .add method. I'll write United Kingdom in parentheses as a string expression. So that's in double quotation marks. And that way, the first element of the array named country name list, the element with the 0th index, right, becomes United Kingdom. All right, so now let's add my second country name to the array. I'll write Germany in parentheses. And finally, we'll add the third country name to the country name list array. I'll write United States of America in parentheses. So now we created our first array. Let's add the elements of the details list array. So I'm writing details list dot add. I'll write a sentence like this. This is the United Kingdom flag in parentheses. Now I'll copy this line of code and paste it twice. I'm writing Germany here. So here I'm writing United States of America. All right. So now let's add the country flags. I'll just type in image list.add. As you can see, we must write an integer type expression inside the parentheses. And like I mentioned before, images are stored as integers, so we should write the position of the image that we will add in parentheses. So our images are in the project directory in the drawable folder within the resource folder. So in brackets, I'll write R, representing the resources folder, then .drawable, and finally the name of the flag in the drawable folder. And then similarly, I can add my other two flags to the image list array. I'll write r.drawable.germany, and then I can add the USA flag. All right, r.drawable.usa. All right, guys, so we've added all the necessary information to the arrays. So in fact, that's all we'll do in the main activity for now. So we can show these images on the screen. For this, we will need an adapter class. If you remember, we needed an adapter class to use list view. So that means in the next tutorial, we will see the grid view component. And we will create an adapter there as well. All right? So let's just create the adapter class without wasting any more time. So first of all, I just create a new class. For this, I'll select the project package folder and right-click with my mouse, select New and Java class from the pop-up. And now we have to determine the name of the adapter class that we will create. So I'll define the name of the class as Recycler Adapter. Create my adapter class by pressing the Enter button. And first we'll need to create 3 array lists in the adapter class, just like in the main activity. So this, I can copy the arrays that we created in main activity, paste it into the adapter class. Now I'll create an object from the context class to use the properties of the activity in this class. So by using the context object, we'll be able to show the toast message on the screen by clicking any of the cards. And now we'll create a constructor for this class. So I'll right-click with a mouse. I'll choose Generate Constructor. I select all variables and click the OK button. So that creates for me the constructor. So we can now delete these sections. We won't add anything to the arrays here. But now we will create an inner class within this class. So this class that we will create will represent the card design, and we will define the components in the card design in this class. So I'm writing public class. I'll set the name of this class to be Country View Holder. Also, this class will be derived from the recyclerView.viewHolder class. But wait, what's this? Android Studio warns us because we need to create a constructor for this class. All right, so for this, I'll just click on the light bulb here on the left, choose Create Constructor, Matching Super option, and boom, just like that, the constructor is created. So now we can define here the image view and text view components that we use in the card view design. First of all, I will create two objects from the text view class. Now I'm creating an object from the image view class. Now we will match the components to their IDs in the constructor. So I'll write text view country name equals, but here we can't do a match directly using the find view by ID method like in the main activity. To be able to use the find view by ID method, we must first access the card design that we created. So we'll make a match just by using the item view object representing the card design. So here I'm writing item view.find view by ID. All right, r.id.text view country name in parentheses. And similarly, I'll match the text view details component with this ID. So I'm writing item view.find view by ID. I write r.id.textView details in parentheses, and that way we finish the process of defining the text view component. Now, similarly, I'll match the image view component with its ID. So I'm writing item view.find view by ID. I write r.id.imageView in parentheses, and that defines the components in card design. So now we'll derive the recycler adapter class we created from the recyclerView.adapter class. So inside the tags, I'll write recycleradapter.countryViewHolder. And now, as you can see, Android Studio is warning us again because there are methods that we have to implement. So I'll just click on the light bulb again. Choose Implement Method. And there are 3 different methods that we have to implement. So we just want to add all 3 of these. They are indeed required, so now they are added. So I want to talk a little bit more about these methods. The first method is the onCreateViewHolder method. So as soon as the country view holder class that we created below has been created, the method gets called. So in this method, we will define the card design that we've made. So it's thanks to this method that we determine which design will be displayed in the recycler view. The second method is the onBindViewHolder method. This method is also a method in which we will specify what should be done when the design is created and then connected to recycler view. So in other words, we will show the data on the screen in recycler view using this method. Now the third method, getItemCount. This is the method where we specify the amount of data to be displayed in recycler view. All right, so now let's finish the necessary options for the onCreateViewHolder method. So first of all, I'll create an object from the view class, and I will transfer the card design into that. So we use the layoutinflator.from method to link a design we created to a view. And now I have to write parent.getContext, and that's going to be in parentheses. Here, the parent object given as a parameter is the object of the view group, that is, main activity. Now you can write here the context object that we created or parent.getContext here. So I write .inflate outside parentheses. Now we'll write 3 parameters in parentheses. The first is the card design that we made. I'll write r.layout.cardDesign. The second parameter is the parent object here. The third parameter will be false. Now finally, because this method will return an object from the country view holder class, I write return new country view holder. I'll write the view object in parentheses. Cool, so that finishes that method. Now, let's do what we need to do for the getItemCount method. So we've got 3 countries for this application, but we cannot know this number in more, when you make more complex applications, such as when retrieving data from the internet or working with databases. That's what I'm talking about. So that's why we always write in here the size of the array that we created. So I write country name list.size. Now let's show the data on the screen. In the onBindViewHolder method, I'm going to transfer the data in the arrays to the components. So now let's write the country name in the text view country name. And of course, we won't be able to directly access the text view and image view components from here. That's why we've got to use the holder object here. So I'll write holder.textView countryname.setText method. I'll write country name list.get method in parentheses. Inside the parenthesis, I'll write the variable position given as a parameter. All right, and that way we print the country name in the text view component. So now let's show the detail information on the screen. So I'll write holder.textView detail.setText method. I'll write details list.get method in parentheses. Inside the parenthesis, I'll write the variable position given as a parameter. So finally, we can show the flags on the image view component. I'll write holder.imageView.setImageResource method. I'll write image list.get. So that's in parentheses. Inside the parenthesis, I'll write the variable position given as a parameter. All right, so finally, we will need to do our necessary steps for the onBindViewHolder method. So for this, we'll need to send the ArrayList object that we created in the main activity to the adapter class. To do this, I will create an object from the Recycler adapter class in the main activity. I'll define the name of this object as adapter. We will now define the adapter class after the ArrayList methods. So I'll write adapter equals new adapter class. So now I've got to write 4 parameters in parentheses because there are 4 parameters in the constructor that we created in the adapter class. So for this, I'll write country name list as the first parameter. I'll write details list as the second parameter. I'll write image list as the third parameter. And I have to write context as a last parameter. So for this, I can write main activity.this as the context. And then finally, I have to set the adapter object in the recycler view. So to do that, I'll write the recyclerView.setAdapter method. I'll write adapter in parentheses, and that will transfer the data from here to the adapter class. All right, so let's run it and test the application. So the application opens, and yeah, so you can see the country flags, country name, and detail information have been created. Yeah, quite successfully. But we do have one last step left. So here, whenever we click on each card view component, we should create a toast message that tells us which category that we clicked. All right. So why don't we just go ahead and do that now? We will create the process of showing the toast message in the Recycler adapter class in the onBindViewHolder method. Because we have defined the card view component here, and we must do all of those operations concerning the card view component from here. So I'll make the necessary coding in the onBindViewHolder method. First of all, I'll need to define the card view component. And I do this in the CardViewHolder class. Now I will match the card view component with its ID in the constructor. Okay, so I think we haven't set the ID of the card view component, so let's set the ID. So I'll just type in card view. I'll open the adapter class again and match the card view component to its ID. All right, card view equals item view dot find view by ID. I write r dot ID dot card view in parentheses. Now let's add a click feature to the card view component. All right, holder dot card view dot set on click listener. I'll write new in parentheses, and after leaving a space, I'll select the view.onClickListener method just by pressing the Control and Space keys on the keyboard. Now, lambda is used instead of this method. So if you hover your mouse over the view.onClickListener method here, you will see a description text pops up, right? So from here, if you choose the Replace with Lambda option, you'll actually get a simpler look. Of course, there's really no difference between the two uses. It's just looks a little simpler and cleaner to me. Now, yeah. So now we can create our toast message. So first of all, we will determine which card view component was clicked. How do you do that? Well, just use the position parameter here. I'll also create an if-else statement. So if the position parameter is 0, that is, the first card view component is clicked, we can create a toast message. If we choose the create a new toast method, after typing toast, it will automatically generate the toast message. So we need one context object to create the toast message. And that's why we created an object from the context class at the very beginning of the adapter class. Otherwise, we wouldn't be able to create the toast message, right? All right, so now let's write our message. And now let's create our other situations similarly. If the position parameter is 1, that is, the second card view component is clicked, then we can create a new toast message. If the position parameter is 2, that is, the third card view component gets clicked, we can create a new toast message. All right, so now let's run the application to test it. Application opens. I'll just click on the first card view component. Hey, there you go. Perfect. So we've created the toast message very successfully. So sure enough, my friends, this is how the recycler view component is made and how useful it is. I know perhaps you might be a little confused, but in general, these actions that we do are fixed and they don't really change much. So let me just summarize what we've done here, right? So first of all, you need to add one recycler view component to the main activity.xml design. Then you have to create one card design that you will show on the screen. You must also create an adapter class that connects the design and the recycler view component. And finally, you must define your adapter to the recycler view in the main activity. All right, that's it. It's pretty easy. All right, so why don't we take a short break here, and I'll see you in the next lesson. Grid view. Hello, everyone. Today in this video, we're going to talk about grid view. So grid view shows items in a two-dimensional grid. You can design rows and columns in grid view. It's similar to recycler view and list view. And if you remember, the items are shown from top to bottom in the list view. And the recycler view items are shown from vertical or horizontal. But you can only choose one orientation, right? So in grid view, you can use 2 dimensions to show your items. So you can see a grid view design in the picture here. Now you can also see, hopefully, that items are listed both horizontally and vertically. And you can define the number of columns and rows. So let's go to Android Studio and see it in practice. Of course, there is one more thing before we start. I want to show you what the project looks like. Here we have 9 pictures, and under the pictures are written the names of the pictures. And when I click a picture, a toast message shows which animal I chose. Okay, so this is a 3-column grid view. Now, actually, the purpose of all the views is pretty much the same. The aim is to show data. And when the user selects one of them, it will do something. It will do an action. So every view shows data in a different way. Now you can decide which view you will use according to whatever project or application you're developing. So let's continue to develop the project. I will drag a grid view and drop it into the main activity. And right now I will define some of the features on the XML page. And I will define the number of columns. Now I want 3 columns. Now also I defined here the gravity center. I will give an ID to this grid view. Its ID is grid view. And now we have 3-column grid view. And I will define this grid view in the main activity. And I will just write here grid view. Grid view equals find view by ID r.id.gridView. Great, so now I need to create 2 array lists. Now, these are for pictures and animal names. So I'll just create it in here. The first one is a string array list for the names, and its name is text. The second one is integer array list for images. And its name should be image. So now I'll need to fill in these array lists. I'll do it by creating a new method below. Public void fill array. And I can start to fill it in. Now I will write here text.add, and inside the quotation marks I will write animal names. I have 9 animals, so I will copy this code and paste it 9 times. So now I will fill in the image array. But before I continue, I will need to add images into the project. So I'll open up the drawable folder and paste my picture inside this folder. And now I can continue. And I will copy and paste this code. I'm going to do that 9 times. Okay, so after the arrays are finished being filled in, I will call this method in the main activity. All right, so now the grid view is ready. The arrays are ready. We need to create an adapter class. So for that, I will right-click mainActivity.java and select New Java Class. And I'll name this class Grid Adapter. Now this adapter class will extend the base adapter. And then after that, I will click this lamp to implement the methods. And it will implement 4 methods. Okay, so now we have the getCount method, the getItem method, the getItemID method, as well as the getView method. Great, so before we continue in the adapter class, I'm going to do another thing. So you know that every item in grid view has its own layout. So we need to create this layout first. So I'm going to right-click the layout folder and select New, Layout Resource File. I need to give a name to this layout file. The name could be Grid View Layout. And click OK. Now I need to design this layout. So inside this layout, I need 1 image view and 1 text view. I will change the constraint layout to linear layout. And also I will define its orientation as vertical. And I will add an image view. I'll select an image for the default one. And also a text view. And I'm going to continue on the XML side. I will change height and width of the image view to 100 dp. And the width of the text view can be wrap content. Okay, so now you can see how it looks like a design. Okay, so right now I will change the center of gravity of the linear layout. Also, I'll give a padding value, let's just call it an 1/8. And this will give 8 dp spaces for every side of the layout. So now the layout design is ready, and okay, now I can continue on to the adapter class. So in the adapter class, I'll need to define some variables. First one is context. Second one, I need to define array lists in here too. Okay, so I will copy these array lists and paste them here. And after that, I'll need to create a constructor for this class. And I will right-click here, select Generate Constructor, and select these 3 variables and click OK. Now Android Studio created constructors automatically. And after that, I'll change this return to 0. So you can remember that from the recycler view. If this is 0, the grid view will be empty. So it should be the number of the element. And I'll write here text.size. So it'll return the number of elements of the text array. And it will create a number of the array size from this layout. I'll need to define a view variable. Now, first of all, I'll create an object from the view class. We'll use the layout_inflator.from method to link a design that we created to a view. So I've got to write context in parentheses. And you can write in here the context object that we created, or parent.getContext here. So here the parent object is given as a parameter is the object of the view group, that is the main activity. So I write .inflate outside the parentheses, and we'll write 3 parameters in parentheses. r.layout.gridViewLayout. So this grid view layout is this layout that we defined before. The second parameter is the parent object here. The third parameter will be false. All right, and now that that's done, I'll need to define text view and image view here. Text view equals view.findViewById r.id.textView. Alrighty then, so I have to assign data to these, both of these, text view and image view. So first I will start by assigning text view dot set text dot get position, and I will get data from the text array and set it to the text view. Of course, I'll do the same for image view. Image view dot set image resource image dot get position. And then the last one, it should be return view. And the adapter class is ready. All right, so now that that's done, I will create an object of this adapter class in the main activity. So the grid adapter equals new grid adapter, and it will take on 3 parameters. First one is this. Second one is text. Third one is image. Context, text, image. And after that, I will set this adapter to the grid view. Grid view dot set adapter. All right, so it looks easy, right? Well, let's run it and see if it's correct. The application opens, and we have 9 pictures, and under the pictures, it's written the name of the pictures. Now, I want to show you something here. I want to change the size of the text view. So it can be 150 dp. And let's run it again. And all of the pictures are bigger now. See, so we just changed one image view size, and all of the pictures are bigger now. So this grid view has 3 columns. Why don't we change it? I'll just write it here, 2. Let's run it again and see what's changed. And now the grid view has 2 columns. So all of the pictures are not actually seen on the screen, right? But it created a scroll bar automatically. So that means you can scroll it from top to bottom to see the pictures. And now we need to do one more thing. So when we click an item, it should show a toast message, right? So that means I need to add a listener. Now I'll add this listener to the grid view. Grid view dot set on item click listener. New adapter view dot on item click listener. Inside the on item click method, toast dot make text. Get application context. And then after that, I'll just need to write a message. And the message is you selected plus text.getPosition. So it'll take the selected item name from the array and then add it to the message, right? And toast.length long. And lastly, .show. So let's run it again. All right, so it's working. So when I click an item, it shows the toast message. Now, the important thing is here, even though I click the text, it still shows the toast message, right? So the whole layout has listener. Now, you can use grid view to do great designs in your projects. I'm sure that you can be far more creative than I am. So let's finish this up here, and I will see you in the next video. Scroll view. Hello, everyone. This is the video that we're going to talk about scroll view. So we use scroll view when the components do not all fit on the screen. Scroll view creates a scroll bar so that we can scroll the screen from top to bottom, from left to right. It's very easy to use, so I just want to show you how Android Studio makes it pretty quickly. So I've got a project here, and before I start, I want to show you what it looks like when we finish. So you can see here that there are 8 buttons in the application. They don't all fit on the screen. And there's a scroll bar on the right side of the screen. And the user can scroll top down. And let's see how we can do this. So in the main activity XML file, there's a constraint layout. And I'll delete the constraint layout and write scroll view. Okay, so now I've got scroll view. But scroll view doesn't have a scroll bar right now because when the components don't fit on the screen, it automatically writes in a scroll bar. So the most important thing here is scroll view can have just one child. So that means you cannot add more than one component to it. And because of this, we'll need to add another layout under the scroll view. So I can add other components in the new layout. And for that, I will add a linear layout under scroll view. And then I will add the other components into this linear layout. So I'll add a button in linear layout. I will change width and height of the button to 150 dp. And also I'll change the text of the button to button number 1. And I'll change the gravity of the linear layout to the center. Now that's done. I'll copy this button and paste it 3 times. And now I have 4 buttons. So I'll change the names and IDs because, of course, each ID should be unique. I will run my application in this state. Okay, so you can see here that there is no scroll bar because 4 buttons fit on the screen. So even when we have scroll view, if the components fit on the screen, scroll bar doesn't appear. So let's just add a couple more buttons and run it again. Now we have a scroll bar, and we can scroll the screen from top to bottom. So this is a vertical scroll view. Can we do it horizontally? So first, I'll just change the orientation of the linear layout, and let's make it horizontal. Okay, so now the buttons are shown horizontally on the screen. I will run my application this way, and let's see, it doesn't work, or does it? Let's change the orientation of the linear layout, and you see, no, it's not working. So what do we do? So let's add horizontal scroll between scroll view and linear, and its width and height can be wrap content, and I'll just put linear layout between these two XML tags. And I'll cut this from here and paste it under linear layout. And let's run it again. There it goes. It's working horizontally now. So you can use scroll view on your application design friendly pages. Until then, I'll see you in the next video. Web view. Hello, everyone. Now we get to the video about web view. So let's have a little chat about it. Web view is used to show internet sites in Android applications. So you can use web view to show an internet site in your application. I'm sure you're very familiar with that, so let's go to Android Studio and see how you build it in practice. So using web view is really very easy. So I have a project here, and I will just add web view to my project. It happens to be under the widget section. So I'll just drag it and drop it under relative layout. Layout width and height of the web view can stay as match parent. And I'll define this web view in the main activity.java file. And I'll just write here web view. And inside the onCreate method, of course, I do need to give an ID to this web view. ID can be web. So web view equals find view by ID r.id.web. And now that's done, I will give a URL to this web view to load the internet site. And I'll just write here webview.load URL and internet address. I want to load Google into this project for now. But if I leave it like this, it will open this site in an external explorer. Okay, so that's why I'm going to need to add this code. Webview.set webview client new webview client. So now after this code is in, it will open this internet site inside of the application. So let's run it and see. So the application is open, but the website is not loaded. Now, well, that's because if an application wants to connect to the internet within the device, it needs to ask for permission. So you can't connect to an internet site using a person's device without that permission. I think we talked about that before. Why don't you go back and have a look at the permissions video if that doesn't make sense. So where do we get the permission? Let's get it from the manifest file. So I will write in the manifest file, uses permission. And then after that, it shows me the permissions. And one of the permissions is internet. So then I can take the internet connection permission from the user, and the second one is Wi-Fi state. And I'll need to get the user permission to use its Wi-Fi connection, and the user will see these permissions when downloading the application. And of course, say yes, and let's run it again. So again, it's not working. Do you know why? I mean, I know why it's not working, but I just want to show this to you. So after Android 9, yeah, this is the problem that you got. So I'm not going to tell you too many details about this, but you should just know that if you see this error, you need to add this code line into the application section in the manifest file. So I'll write this, you know what, I think I wrote this code before. And then so after that, I can just run my application with all the peace of mind that I can muster. And sure enough, it's working. So now I can connect to Google in my application, and I can basically go to any internet site from here, and I can search for something in here. But when I click the back button, it won't go back. It closes the application. So here's a problem we need to solve. And I can do that in the main activity file. Yeah, so there is a method. Its name is onBackPress method. So this method controls the back button on the device. And I will write in this method if WebView.canGoBack, WebView.goBack, else apply backpress method. So let's run it again with that added. Okay, so Google is opened, and I'll write Android to search. Okay, so it's searched. And when I press the back button, it goes back to the previous site until the previous site history is finished. And then after it finishes the previous site, it closes the application. So this is basically how we use WebView within Android applications. I hope this is useful for you because you can include it in the applications that you will construct, develop, and deploy. I will see you in the next video. We've got some great stuff in store now that you know some basics. Application lifecycle. Hello, everyone. We're going to talk a little bit about lifecycle in Android applications. So what do I mean when I say lifecycle? So the lifecycle basically starts from the moment we first start to open the application up to the moment the application is opened. Certain operations are carried out and closed. It also includes these two endpoints in the process. And all these phases of the application are called the life cycle. So an application passes through certain phases from the first open until it closes. And all of these phases are what's known as life cycle. Now, life cycle has a very important role in Android application development because when you develop an Android application, you will need to consider these life cycles. So first, let's talk about what these life cycles are, and then we're going to talk about, well, pretty much where and how we're going to actually use these life cycles. So LifeCycles have different stages. First one is the application lifecycle. The second is the activity lifecycle. And the third one is the fragment lifecycle. So in this particular video, we're going to focus on the application lifecycle because we are developing Android applications. So right here is an Android lifecycle algorithm. You can see every lifecycle in this algorithm. So when we first open the Android application, the onCreate method works. And this is the first stage for an Android application. And you should remember that we write most of the code in this method. Application is created in the onCreate method using Java code. After the onCreate method, the onStart method works. Then after the onStart method, onResume is the method that works. So this means that when you open an application, these are the three methods that will work. The onResume method continues as long as the application is running. But sometimes Android apps can be a little finicky. They can be thrown into the background or forced to pause. How does that happen? Well, for example, when you work on an Android application or when you play an Android game, let's say a phone call or message comes in and your application or game is forced to pause, right? Now, because when a phone call comes in, the Android device needs to show you this call. The time the phone call comes in, your Android application is forced to pause. So when the application is paused, the onPause method starts to work. After the call, when you continue your game, onResume method starts to work again. So this time, just the onResume method works because the application is paused. But when you first open the application, three methods are employed. After the onPause method, the onResume method starts to work. So this is the part that the application continues from where it paused. The application pauses in the onPause method. Now, when you go out of an application, the onStop method works. And then after the onStop method, if you want to open the application again, the onRestart method works this time. Then after the onRestart method, onStart and onResume methods will work. So, when will the application pass to the onDestroy method? Well, that's after the application is closed, it passes to the onDestroy method. Then, after the onDestroy method, if you want to open the application again, respectively onCreate, onStart, and then the onResume method will work. Now, also there is another situation when you jump from one application to another application. The first application goes into the onPause and onStop method. And then after a while, if you do not go back to that first application, Android operating system will close the application itself. But before it does this, the Android operating system checks the device memory. Now, if all of the open applications force the operating system to work, it will close any unused applications itself. So now it brings us to the question, where are we going to use these life cycles? For example, you play an Android game, and when you play a game, a phone call comes in. And when a phone call comes in, your game application goes to the onPause method. Then after the phone call, you're going to need to continue where you left off, right? So to be able to continue where you left off, your scores, your stage, and all the other information needs to be saved. And we do these saving operations in the onPause method. So let's think about that for a second. After the pause method, your application goes to the stop method, sometimes some codes need to work in the on-stop method. So some applications should continue to run in the background. For example, let's say that you developed a GPS tracker app. Well, this application is doing location tracking using the device's GPS. When you put this application into the background, it should continue to track the location. So this application continues to run in the on-stop method. Now also there's another thing. When your application runs in the background, device GPS will continue to work. And we all know what that does. It will drain the device battery pretty quickly. So if your application consumes the battery fast, people, they're not going to like that very much. They're going to complain. They're not going to use your application. So what can we do about this problem? Well, for an example, let's say that when the application goes to the on-stop method, you can close the device GPS. So then after the application comes back to the on-resume method, you can open the GPS again. That's how you reduce the battery usage. Okay, that's all well and good, but there are some applications that need to work even the on-destroy method. For example, a mail or a message application. So these types of applications need to check the server periodically. So now that you know what's going on with these explanations, you should really know what the application is doing in its particular life cycle. You should know these processes so you can control your application better. So let me give you another example. Let's say that you develop a mail application. So when the user is writing an email, a phone call comes in. And when the phone call comes in, your application passes to the on-pause method. And then after the phone call, the user goes back to the mail app again. Now, if you don't save in the on-pause method what the user wrote, well, the user's got to start all over again from the beginning. Who wants that? That's frustrating. So in other words, you need to consider all of these particular life cycles when you develop an Android app. So this was the theoretical part, okay? And that's only just a few of the variety of scenarios that you may encounter when developing your app. But right now, let's put the theory to the side and let's go to Android Studio and see it in practice. Now, you know that we have a couple of projects by now in Android Studio, so I want to show you these particular methods on this project. So here you can see the onCreate method. Now, we have worked most of the time in this method, but it's really not the only method. I want to show you some of the other methods. There's an easy way to call methods in Android Studio. When you write the first letters of the method, Android Studio shows you the methods that start with these letters. So I will call onDestroy method first, and then second, onPause method. Third, onStop method. After that, onStart. And onResume method. Now, which method did we forget? The last one is onRestart method. Now, when we run our application, we need to track which of these methods are currently working. How the heck do you do that? Well, I'll teach. That's what I'm here for. I will teach you how to track application stages. When you develop an Android application, Android Studio keeps log records. So you can use these log records to track the application workflow. So here I will put a log record, and it will take two parameters. The first one is log name, and this shows me how I will track this log. The second one is message. So when I find this log, it will show me this message. And I'll write here log.d. Now D means debug. And I can see this log message in the debug logs. Now I'll write a message for the tag, and it will show me the debug logs with the message title. And second is the message. And I'll write here on create, whichever method works. I want the name of the method to be written. For the onCreate method, I want to be written onCreate. Now, in the same way, for the onDestroy method, it will write onDestroy, and then that way I can do the same for the rest. All right, so let's run the application and see which methods will work. Okay, so before we run it, I do need to show you where you see your log records. So there's a logcat section on the bottom of Android Studio. After you click the logcat, I will select debug records. Now, because I write the log.d, it will track debug logs. Let's say if I write log.i, it will track info logs. So I selected the debug records. All right, so now I can run the application. And what do you see here? So when the application was first opened, the onCreate, onStart, and onResume methods worked. So we showed you this on the algorithm. Let's continue so that when I put the application in the background, the onPause and the onStop methods work. So let me put my application on the background again. Now, because I want to pass to another application, I will go back to my application again. When I go back to my application again, on restart, on start, and on resume methods worked. Okay, so good. Let's look at the algorithm. Okay, so you can see on the algorithm, after the onStop method, on restart, on start, and on resume methods all work. So what if I closed my application using the back button? So after I click the back button, on pause, on stop, and on destroy method worked. So what needs to be done at these stages? We will write into these methods. So we will write in onCreate method what we need to write in the onCreate method. When the application goes into the onPause method, and if we need to save some information, we will write codes in the onPause method. And when the application goes into the onStop method, if we want our application to do something in the background, we can just write these codes in the onStop method. So, for example, I'll continue on from the earlier example. If you want to close device GPS when the application is in the background, I will write these codes in the onStop method. Now, I didn't want to get too serious in the beginning, but I want to tell you that, and I'll emphasize again, this topic is important. I'm going to finish up this video here, but you will be able to continue to work on the device and see some of the other methods yourself. I do want to get started in the next video, but review this if you need to. In the next video, we're going to continue this topic on the activity lifecycle. So I'll see you then in the next video. Activity lifecycle. Hello everyone, just as promised, I want to talk to you about the activity lifecycle in this video. Now, at first glance, the activity lifecycle is very similar to the application lifecycle. This time, though, we will focus on the activity and not the application. So it's going to be a little different. How does the lifecycle work with activity? This lifecycle algorithm is also valid for the activity. Now, we have just explained how the lifecycle works in the previous video. I don't want to necessarily repeat all of that. I just want to show you in practice in Android Studio. So let's go to Android Studio. Of course, you remember we've got a project that's been cooking, and we'll continue with this project. Now, in the last video, we added some log records to see the methods working. And I'm going to add a couple of components on this project to see how the activity lifecycle works. And I will add to this main activity one text view and two buttons. So now I have three components. I'll organize them just so that I can, see it comfortably. And I will change the layout height and width of this text view to 50 dp. For the layout height, 50 dp is too big, so I will change it to 30. Also, I will change text of the text view to 0. And also, I will change the text size of the text view to 24. And the text color of the text view can be white. And the background color of the text view can be green. And the gravity of the text view can be centered. Okay, so now I've done all of this to see the number on the text view comfortably. So now when I click on this button, I want to add to this number +1. So I will change the text of the button to +1. Also, I have another button. When I click this button, I want to go to another activity, so I need another activity. Now, how do I create another activity? I click on the app folder, and after that, I select File, New Activity, and Empty Activity. Now I need to give it a name. Well, let's call it just Second Activity, and click Finish. So now Android Studio will create a second activity for me. And here's the second activity. And here's the main activity. So when I click this button, I want to open the second activity. So I will change the text of this button, and I will write, go to the second activity. So now that that's done, I will write Java codes for these components. Now first I will define these components. So I will write text view, and button 1, and button 2. I will continue in the onCreate method. Text view equals find view by ID r.id.textView. Button 1 equals find view by ID r.id.button. button 2 equals find view by ID r.id dot button 2. So now I will add a click listener to, let's see, button 1, and button 1 dot set on click listener, new view on click listener. And also I will add a counter here. So integer counter equals 0. And so every time that I click the number 1 button, I want the counter to increase. So I'll write counter equals counter plus 1. And also it should write this new counter to the text view. Okay, so text view dot set text quotation marks plus counter. Now if I add quotation marks before the counter, it will change the integer counter to the string. It's a quick and down and dirty quick, but it works. So now it will increase the counter every time I click this button and write it to the text view. Then after that, I will add another click listener to button number 2. So button 2 dot set on click listener, new view on click listener. And when I click this button, it should open the second activity for me. But how's it going to do that? I will use intent for this. That's a topic that I'm going to leave to explain a little bit later, but I just want you to write exactly what I write for now, and we'll talk about its details later. So intent, I equals new intent, and inside the parenthesis, get application context, second activity dot class. After that, start activity I. Now, when I click button 2, it will open the second activity for me. So when I go to the between two activities, I want to see which methods work, right? Because of this, I will write the first activity before the word onCreate. And this will show me the onCreate method works for the first activity. So I can copy this first activity word and paste it to all of the methods. Okay, so I'm done with the first activity. So when I click this +1 button, it will increase this number on the text view. Also, when I click this button, it will open the second activity. Okay, so now I can pass on to the second activity. And I'll add a button to the second activity. This button is for going back to the main activity. And I will just bring this button into the center. And let's change the text of the button. So I'll write, just go to the activity number 1. And when I click this button, it should open the first activity. So I need to define this button on the Java side. So I'll write here, button, button, and in the onCreate method, button equals find view by ID r.id button 3. And I'll add a click listener to this button, button.set on click listener, new view on click listener. And then after that, I will use the same intent codes for this button. Intent I equals new intent, get application context, main activity dot class, and start activity I. Also, I need log records for this activity to see which methods work. So I'll copy the log records from the main activity and then paste it into the second activity. Also, I will change the first activity, and Well, instead of first activity, I'll just write in second activity. And I can do the same for the rest. So that means that after that, the second activity is ready to go. So that means that when I click this button, it should open the main activity. And when I click this button, it will open the second activity. And if I click this button, it will increase the number +1. Okay, so before I run it, though, I want to open the log records. And after that, I can run the application. All right, so the application's opening, and now you can see when the application was first opened, 3 methods worked. First activity on create, first activity on start, and first activity on resume. So if I click go to second activity, what's going to happen when I push this button? Okay, so when I clicked the second activity button, the first activity on pause method worked. And then after that, the second activity on create, on start, and on resume methods worked. And after the second activity opened, the first activity on stop method worked. Wow. Okay, so here's where you got to be careful. So I'm going to click go to activity 1. And when I click go to activity 1 button, the second activity on pause method worked. And then after that, the first activity on create, on start, and on resume methods worked. Okay, so that means the first activity created again. After the first activity opened, the second activity on stop method worked. All right, so do you get why this is so important here? I want to show you, because you remember, right, that I put a button here. So when I click this button, it will increase the counter +1 and then write it on the text view. So I'm going to click this button 6 times. And now it writes 6 in the text view. So after that, I'll click to go to the second activity, and it opened the second activity. Then after that, I'll go back to the main activity. And when I go back to the main activity, what does the counter say? Counter says 0. So when I go to the second activity, the main activity is closed. When it closed, boom, everything is gone. So when I go back to the main activity is created again. Because of this, it deleted everything. It's like we never even saw each other, never even fell in love at first sight, never even began. So what if I want to keep the counter value? I must save it before the activity is closed. That's right. So this also happens, by the way, when I rotate the phone. So let me click this button again, and the counter is 5. After that, I'll rotate the phone into the landscape position. So when I turn the phone, the first activity on pause, that worked, on stop, and on destroy, those methods worked. After that, on create, on start, and on resume methods worked for the first activity again. So that means that when I turn the phone, the activity is destroyed and created again. And when I turn the phone, also the counter is reset. So that means before I return the phone, I need to save the values too. You see how important it is to think ahead. We're going to learn how to save values in some of the later videos, but I just want to show you how important it is. I think that by now you certainly understand how the activity life cycle works. And for me, and for you, and for, let me speak for all of us, That's enough for this video. We are going to talk about the fragment life cycle, though, in the next video. Let's make a date. I'll see you in the next video. Hello, everyone. We're going to talk about the life cycle in fragments. All right, so we will discuss fragments in detail in the following videos. We're not going to go into too much detail about fragments in this particular video. We just want to talk about life cycles in fragment first, okay? So just a little bit of information about fragments. Right, so fragments are presented to the developer after API level 11. Fragments are basically a user interface that works in the activity. We can define fragments as small activity particles, right? So fragments are the more useful and more dynamic user interfaces. And because of that, developers prefer using fragments. For example, you can create fragments as much as you want, one activity. Also, you can use one fragment in more than one activity. And you know what? I think that's enough right now about fragments. It gives you a little bit of a taste, right? So we got to continue with the life cycles because that's what we got to do. So fragments, right, have their own life cycles. So that means a fragment has a life cycle from the moment it was created to the moment it was closed. We're going to talk about this particular life cycle right now. So when a fragment first starts, these three methods start to work. OnAttach, onCreate After that, these three methods start to work. OnViewCreated, onStart, onResume. Now, with the onResume method, the fragment continues to work. When the fragment closes, these methods start to work. OnPause, onStop, onDestroyView, onDestroy, onDetach. Also, there are these milestones. If you start again a particular fragment, after the onStop method, it will begin from the onStart method. Now, if you start again after the onDestroyView method, it's going to begin from the onCreateView method. You follow? So after the onDetach method, the fragment closed completely. All right, so we've talked about these algorithm milestones in previous videos, and now I want to show these methods in Android Studio. So first, I'm creating a new project. I'll click on the File tab in the upper left corner, and then I'll click on the New Project. Cool. So after selecting Empty Activity from the page that opens, I'm going to click the Next button, and I'll just pick a name out of a hat, and I'm going to name this project Fragment Lifecycle. Of course, you can name it whatever you want. The package name will be shown just like it is here. Now, I do not change the location where the project's going to be saved, but if you want to, just keep track of it. Change the location, and you can do that just by clicking here. Okay, so the minimum SDK can be API 21. All right, so finally, we're going to start creating our project just by clicking on the Finish button. Right, so our project's currently being created. It just takes a moment. Okay, my friend, so as you can see, our project's created. So first we got to open the activity main.xml page. By clicking the eye icon here, I'll choose the Show System UI option. All right, so the design area will look like a phone screen. Natch. So let's delete the text view component here. I've completely emptied my design area. Now I want to show you how to create a fragment, okay? So for the fragment, we'll need to create a design file and a class. And then we need to define this fragment class in the main activity or in which activity we want to show the fragment, in, right? So therefore, first of all, I'm just going to create a design file. And I will go to the Layout folder, right-click the Layout folder, and select New Layout Resource File. All right, so after that, I can give a name to the layout file. And my name here is going to be Fragment New. I'm going to click OK. All right, so layout's created. I'll add a text view to this layout. Now I want to change the background color. And the background color can be dark red. Yeah. Okay, now I'm going to take this text view and bring it to the center. I will change the text of this text view. And I'm going to write, this is a new fragment. Now also, I want to change the text size, the text color of this text view. The size can be 24 SP. Text color can be white. Okay, so now we can see this fragment comfortably. So after that, I need to create a class for this fragment. I'll right-click on the main activity class and select New Java class. Now I just need to give this class a name. Name can be fragment example. Now that that's done, this class will need to extend fragment class. And then after this, I'll need to add a method in the class. So this method is onCreateView method. When I select this method, Android Studio will take care of the rest. And now that that's done, I'll need to change this return part. So this method will inflate our fragment. And I'll write here, return inflator.inflate. And this inflate method will take on 3 parameters. The first one is fragment layout name, and I'll just write that here. r.layout. And I'll write here the layout name. Name is fragment new. Second parameter is container, and this is a constant. And the third one is false. All right, so now the fragment class is ready. Now I'll just need to add this fragment to the main activity. So we'll open the activity main.xml file. You see, there is a component in which we can view the fragment design that we have created. The name of the component is fragment container view. You can always find this component in the containers section of the palette. So I'm going to drag the fragment container view from the palette, drop it in here, and after that, a window is going to open up. Yep. And I will select here fragment example as my class and click OK. Okay? Okay. Now, the fragment is added to the main activity. So I will change the sizes of this component. Layout height, layout width can be 300 dp. Yeah, also I'm going to center this component. Now, the fragment is ready. So let's run it and see. All right, so there you go. You see how the fragment's ready. And of course, this is just the simplest of fragments. Yeah, of course, we're not going to use it like this. Just put a fragment in the activity and leave it like this, okay? Fragments aren't usually like this. I just wanted to show you how to create a simple fragment because in this video, remember, we just wanted to see the fragment life cycle, not how to use fragments in your project. Anyway, so after all that, we can now see which methods work in the fragment lifecycle. Where will I write the lifecycle methods? But of course, in the fragment class. So I'm going to create another lifecycle method in the fragment example class. And I'll first call the onAttach method. And we can add some other methods together. Second, I will call the onCreate method. Third is the onCreateView method, right? We already created this. The fourth, onViewCreated. the 5th on start, the 6th on resume. After the on resume function, the fragment will run, right? So the 7th on pause, the 8th on stop, the 9th on destroy view, 10th on destroy, and the last function is on detach. All right, so I added all these methods in the fragment lifecycle. Now, after that, I'll just need to add log records in these methods because I do want to see which method works, when and where, right? So log.I, and it takes 2 parameters. First one is the title. Yeah, and I'll write fragment for the title. Second one is the message. Which method works? I'll want to write the name of the method in the message, right? So I'll copy this log record line and paste it into the other methods. So after that, I'll change the messages. So for the onCreate method, I will write in the message onCreate. Right? For the onCreateView method, I'll write onCreateView. For the onViewCreated method, onViewCreated. And of course, it'll be the same for the rest. OnStart method, I'll just write onStart. For the onResume method, I can write onResume. OnPause method gets onPause. And for the onStop method, I'll write onStop. For the onDestroyView method, I'll write onDestroyView. For the onDestroy method, I will just write onDestroy. And for the onDetach method, I'll write onDetach. So now I can track records here, right? I'm not going to select debug anymore. I'll just select info because the letter I is shortened to stand for info. So there you go. Also, I want to be able to filter records with the fragment keyword. So I'll write fragment into the search bar. See, now I can run the application. And my friends, what you can see here when the application first opens, on attach, on create view, on view created, on start, and on resume methods all work. So until this fragment's created, right, these 6 methods work. And we can see this on the algorithm. So if I close the application, on pause, on stop, on destroy view, on destroy, and on detach methods will work. Now, if I open the application again, these methods, of course, will work again. I say of course, but you might not know. Now, this is the caveat here. It doesn't mean that other methods do not work in the main activity, right? They'll also continue to work. When we open the application, the main activity is created, and then after that, the fragment is created. So let's have a look in practice, all right? So let's just open up an old project, and I will copy the log records that we wrote in the main activity and paste them into the main activity in my new project, right? You see what we're doing? So that way we can follow the life cycles of both the activity and the fragment at the same time. Pretty cool. Okay, so now we can see the main activity log records in the logcat screen. But here I got to select the debug log records because we use the log.d in the main activity. And also I'm going to delete the fragment keyword in the search bar. And here I'll just write message. All right, so let's run the application again. And there you can see when I run the application, activity lifecycle methods work. And now if I change the debug to info, and also I got to write the message keyword instead of fragment. Okay, see, the fragment lifecycle methods also work at the same time. All right, so you can see these methods in detail for yourself. You just need to play around a little bit. You can change these log records and see all of the methods together. That's pretty much up to you. But in any event, that's enough for this video, don't you think? That is pretty much all I want to tell you about the life cycle of fragments. So I'll see you in the next video. Services. Hello, everyone. In this video, we're going to talk about Android services. So services are one of the basic features in Android. So when you develop an Android application, services play an important role. So because of this, you should learn services back and front and forward. Well, you got to know them real well anyway. We're going to talk about services in pretty good detail in this upcoming video. So a service, as I said, is an Android application component that can perform long-running operations in the background. Service is also an Android component like the other Android components, but it works in the background. So another feature of the services of Android is that there is no user interface. So services don't need a user interface because services don't actually interact with users, right? So normally other Android components are in constant interaction with users. You know, mail inputs and password inputs and clicking buttons and all that good stuff. But services don't need that. A service can be started by other Android components. So, for example, when you click a button in an Android application, a service can be started in the background by this button, right? So, let's say in a real-world example, I can give a file download example as a real-world example. In an application, when you click a download button, a service starts to download the file in the background. Now, sometimes this file can be a huge file size, and it can take a while to download this file. A service takes this download task and does it in the background. Meanwhile, you can go on working within your application, right? So, in this download example, first, the download works in the background. Second, this download service does not have a user interface. It can show the user a download bar or a notification, but these are not in the activity or in the application. Third, the service started with a download button, which means that the service component started with another button component. Now we can give another service example. So a music player application can be an example for some services. A music player can continue to play selected music in the background. And another example could be something like an application can download a photo from the internet in the background. Or an application can send information to the server in the background. Of course, you can give millions of examples of services. There are many extensive uses of services in Android applications. But there are 3 different types of services in Android applications. So the first one, I think you probably know, is foreground services. So in foreground services, the user can see the process. For example, your application will download a file in the background. This is a foreground service. In the foreground service, the user needs to see notifications. Also, the user needs to see the download process, or when the download finishes, there should be some information that's given to the user. Also, even though the user does not interact with the application, the service has to continue to work in the background. For example, your application starts to download a file in the background. This file could be a huge size, let's say a gigabyte, and while the download process continues, the user can continue to work within the application. Even if the user leaves the application, the download process must continue. So the second one is background services. So in the background services, the user does not see the process. The application does not show the notifications to the user. Now, sometimes the user doesn't even know anything about the service process or what's going on. It does everything in the background. Let me think of an example. So you develop an application. This application stores some photos in the device memory. And while the application is storing photos on the device, it can compress the photos in the background. Now, the user doesn't have to know about this compression process. But what the application does in the background, or how the application compresses photos in the background, is circumstantial. The user doesn't know anything about the processes. What the user does, the user just takes the photos and saves them to the device. And while you store these photos in the background, you can create a compression service in the background so that the photos take up less space in the memory to make the application work better on the phone. The user's going to be very happy about that. So in other words, you can compress photos in the background, and when you need these photos, you can uncompress them again. So in these examples, this service, you're doing some operations in the background and without the user's knowledge. Also, the user doesn't interact with this service. Now, the third one is bound services. We talked a little bit, maybe you remember that I mentioned it before, but this is the service that is dependent on the component that calls itself. So service interacts with the component permanently that calls itself. So when the component that calls itself stops, the service also stops. The service does not continue to work in the background. And in the literature, this relationship is called client-server relation. So in this relationship, the server is in service and the client is the component that starts the service. A music player application could be an example for bound services, because when you start a music player application, the service sends data to the player periodically. This data could be which music could be playing, or which is the name of the next song, or which minute of music is playing, and this kind of thing. When the user closes the application, the music will stop. Now, when you start the application again, music will also be able to start to play again. So you see that the service is in continuous interaction with a component. And that's why we call this kind of service bound service. Now, when you come up to the service writing part, there are two service classes. The first one is the standard service class. So what is the standard service class? This is a traditional service class. The service class takes on the whole task on its own. But this service class has a feature that uses the main thread of the application. So I'm thinking that I'll give you a few details for this part. So Android operating system gives each application a share of the processor. So that means that your application uses this share of the processor. Also, your service will use the same share of the processor. That makes sense, right? But if the service uses most of this share, your application will slow down. So because of this, if your service has a big task, You should not use this standard service class because it will slow down your application. But if your service task is small, you can go ahead and use standard service class. So for an example, your application will download a movie from the internet, and at the same time, you want to be able to use your application. So the download process will take some time and will use resources of the application. And then when you use the application at the same time, it works slowly. Users do not want a slow application. So how do you solve this problem? So this is where another service class type helps us. It's called intent service class. So the intent service class is a subclass of the service class. The intent service class does not use the application's main thread. It creates an other work thread and uses its own thread. So that means the intent class requests an other share of the processor from Android operating system. This doesn't slow down the application, and the intent service class is used in long-term background processes. So of course, now that you understand everything there is to know about service, we can shuffle on over to Android Studio. Now, because I don't want to just, give you theoretical information that, might be okay, and you can tell your friends all about it at your next party, but I need to show you this in practice so that you get practice so that you can develop some great Android apps. So, have you got Android Studio open? We have a project in Android Studio, and let's continue with it. Before we start, though, I do want to show you what the finished version looks like in this example. So we've got two buttons in this example, and if we click on the Start Service button, it, of course, will start the service. Now, if we click the Stop Service button, it will stop the service. Sounds magical, right? But I do want to track these steps from the log records. So when the service starts, the log records will show us that the service has started, and when the service stops, the log records will also show us that the service has stopped. All right, so now we can start designing the project. And I will add two buttons here. I will change the layout width of the buttons to 200 dp. And we'll give some distance between the buttons. And I'll give an ID to these buttons. And now that that's done, I will define these buttons in the main activity. I'll just write in here button start, and button stop. Now in the onCreate method, button start equals find view by ID r.id.button start, and button stop equals find view by ID r.id.button stop. Okay, so once that's done, I will add click listeners to these buttons. Now you know how I will add a click listener. You are very well practiced in that by now, so that's all standard. So now that that's done, we need a service class to run services. So I'm going to create a service class from here First, I'm going to right-click the main activity Java class and select New Java Class. And I will need to give a name to this class. Name is Services Example. All right, so Android Studio created a Service Example class. And the Service Example class needs to extend Service Class. So I'll just write here, extend service. Now, you know we mentioned two service classes, right? Standard service class and intent service class. So first, we will extend standard service class. And when I extend service class, Android Studio wants to add methods. So let me just have a look and select from here, implement methods. And it will add this method. Now you see that Android Studio added onBind method. You remember that we mentioned the bound service before? We're not going to create a bound service. Because of this, we're not going to use that, but it does have to stay here. So I'm going to add other methods. First, the onCreate method. Second, onStartCommand method. And then the onDestroy method. And now we'll write service codes in these methods. And we will write the onCreate method, operations that should be done when the service is first created. And we will write in the onStartCommand method the operations that should be done when that service is started. And we will write in the onDestroy method the operations that should be done when that service is stopped. So what you want the service to do, you will write in each of these sections. For example, if you want to download a picture from the internet, you will write these codes in this class. So we're not going to write a service in this video for now. I just, want to check whether the system is working or not. So let's check that when I create a service, I need to see whether this onCreate method is working or not. Now, to see if these methods work, I will need to add log records into these methods. First, I will add in the onCreate method. And of course, you remember from the previous videos how we will add log records, right? The log records have two parameters. The first one is title, and I will write service for the title. And the second one is message. And what will I write for the message? Service is created. And I'll write the same code in the onStartCommand method. I'll just change the message. I will write service is started. And in the onDestroy method, I will write service is stopped. So how do I run this service? So we have a service class. We also have a main activity class. Hopefully you remember that when we explained services, we also said that a component should start the service. So in this example, our component is button. Now, while we're on the subject of buttons, let's go ahead and change the text of the buttons. And what will I write for the first button? Start service. And what about for the second button? Stop service. Okay, so if you want, you can write something here, start download instead of start service. The time that it will start the download process, or I don't know, something. But of course, you will need to write the download process codes in the service class. So now when we click the Start Service button, the service will start in the click listener. And then after that, the service class will start to run operations. Now we do need one more thing at this point. We'll need to define the service class in the manifest file. So let's open up the manifest file. And in here, under Activity, XML code, I will write service XML code. And in this part, I just need to write service class name. You remember what the name of the service class name is? Service example. All right. Now after that, we just need to write code to run the service. So what I'll do is I'll write these codes in the onClick method, and I will start this service using the intent method. So I just write that in here, intent, I equals new intent, and the intent method has two parameters. And the first one is get application context. The second one is service example.class. On the second line, I will write start service I, and this start service command will start the service. So I promised you, and I will, explain this intent topic in the next video. But now that we've done all that, I will open the log records, and in the log records, I will select debug records, and in the search area, I will write service. Okay, so now I can run the application. And the application's working. So when I click the Start Service button, in the log records, the service is created, the service is started. So first, service is created. After that, the service is started. Okay, so now the service is running. After the service started, if I click Start Service button again, you can see here that this time it just writes service is started. Because when you first created the service, after that, it won't create again until you stop the service, right? So it will just start again, created service. Now also, I need to mention to you that if I write here the stop self method, it will stop the service automatically after the service finishes the task. So for example, if your service task is to download a file from the internet, the service will stop automatically after it finishes downloading. So let's run it again and see how this method works. So you can see here that when I click the Start Service button in the log records, the service is created, service is started, and service is stopped. And I've not stopped the service yet, but it stopped automatically. That is the stop self method. And if I wanted to stop the service manually, I will write my code in the Stop Service button. I'll write it here, the same intent method, and on the second line, I will write Stop Service I. So now when I click the Stop Service button, the Stop Service method will work. And in the service class, onDestroy method will also work. In the onDestroy method, this log record will work. So let's run it again. And the application is working. So first I will start the service, but I need to delete the stop self method. Now, when I click the Start Service button, it writes service is created and service is started. When I click the Stop Service button, it writes service is stopped. So this example is classic service class. Also, you should remember that there is another service class. It's the intent service. Classic service class uses the main thread. intent service class creates its own thread. And I think we'll leave it there. So this time I will extend the intent service class. So when I write here extends intent service, I can delete this onBind method, and the other methods will stay. So I'm going to click here and select Implement Methods. It will add onHandle intent method. Now also, I will need to create a constructor for this class. I'll click here and select Create Constructor, and I create a constructor with argument. So I'll delete the argument, and I'll just write it here, return name. Now the intent service is ready. And I'll delete this part, it's not necessary. I can see methods in these log records. And I'll just add a log record in this onHandle intent method. Okay, so everything's ready. And yeah, we're ready to run the application again. So when I click the Start Service button in the log records, service is created, service is started, onHandle intent method worked, and the service is stopped. And look at that. I did not even write stop self method. It stopped the service itself because the intent service handles everything itself. When it finishes the task, it stops the service itself. So that's about it for services in Android applications. I really do hope that was useful for you. And you can take it and run it and mash it up and create some wonderful services and applications of your own. I'll see you next time. Broadcast receivers. Hello, everyone. Now, we're going to talk about broadcast receivers in Android devices in this particular video. The broadcast receiver is a messaging system used on Android devices, but this messaging system is used between the Android operating system and Android applications. The Android operating system shares device-related information with Android applications. Bet you didn't know that, huh? So this device-related information can be just simple stuff like the device battery level, whether it's connected to Wi-Fi or not, whether the device starts to charge, or is the device in airplane mode or not, all that kind of stuff. So if the application wants to know some of this information or all of it, it will subscribe to the operating system in order to get this information. So when these system events occur, the operating system sends a broadcast message to any of the subscribed applications. The Android operating system sends these messages when these system events occur. So this is really important because whenever one of the system events occurs, Android operating system sends broadcast messages at that particular time. For example, if you want your application to learn when the device battery is low, you will need to subscribe your application to that specific system event. And when the device battery is low, the Android operating system will send a message to your application. That's why it's called a broadcast message. Or if you want your application to know when the device is connected to Wi-Fi, you can subscribe your application to that system event. And whenever the device is connected to Wi-Fi, the Android operating system will send a broadcast message to your application. Now, when your Android device gives a warning to you that the battery is low, it also sends this message to all of the subscribed applications. Also, when the Android device switches into airplane mode, or the user does that, uh, the system sends this message to all of the subscribed applications. So all this makes sense, right? So how are you going to use this information for Android application? So our application subscribes to the information that we want. Android operating system does not send every bit of information or system events. We subscribe to system events, whichever one we will need in our particular application. I cannot be more clear than that. So we take information from the system, but where are we going to use this information? For example, you develop an application, and this application saves user photos on a server. Now, such an application allows a user to access their photos from anywhere. Okay, it's a great feature, really useful. But how will you send the photos to the server? If you send every photo to the server when the photo was taken, it will pretty rapidly use up the user's mobile data, right? Because a user can even take hundreds of photos in a few seconds. So this is probably not a good feature for an application. Nobody wants to use that kind of data-sucking application, right? So what you do is you save photos in the device memory, and then when the device is connected to Wi-Fi, you can then send the photos to the server. So it's this kind of thinking and this kind of feature that will reduce the user's mobile data consumption. That's how you get a good reputation, by the way. So if you want to develop this kind of application, you will need to learn when the device is connected to Wi-Fi. Your application can subscribe to system events, and when the device is connected to Wi-Fi, the Android operating system sends a broadcast receiver message to the application. And then after this message, your application starts to send the user photos to the server. Now also, when the device is disconnected from Wi-Fi, the system will send a message again to the application, and your application will stop sending photos to the server, right? Now, where else do you figure we can use this broadcast receiver? Well, let's say, for example, applications that verify by message can use the broadcast messaging system. You know, many applications are using message validation systems such as WhatsApp and Viber, and some of them, when the message comes in, read the message automatically. So you can develop this kind of application using broadcast messaging. Your application subscribes to the system event, and when a new message comes into the phone, your application will know this. And then after that, your application can read this message automatically. Now, let me give you another example. When a device battery is low, the system will send a message to the subscribed applications. So after the application gets the message, the application can stop its background tasks. So then this both reduces the device battery consumption and it prevents sudden interruption of the background task. And then when the battery level is normal, the system sends another message to the applications. Then after they get this message, the applications can then restart their background tasks. So the use of broadcast messages when designing an application is really important for the more efficient and better quality applications, which is what you want to build, I'm sure. Okay, so I also want to mention this. So broadcast messaging system can be used between two applications. That's right, we're going to step it up. It means that one application can send a broadcast message to another application, but most of the time it's used between the Android operating system and Android applications. Okay, so that's all the theory. Let's go into the Android Studio and learn broadcast receivers in practice. So here I've created a new Android Studio project. If you want, you can use your previous project. Now, if we want to get the broadcast message, first we will need to create a receiver class. So I'll just right-click on the main activity class, and then after that I'll select New, Java class, and I need to give a name to this class. Name can be Broadcast Example, and click OK. All right, so now we have a Broadcast Example class. So this class needs to extend the Broadcast Receiver class. And I'll just write here, extends Broadcast Receiver. Then after that, we'll need to add some unimportant methods. I will click here and select Implement Methods. Now in here, I'll select OnReceive method and click OK. Now, Android Studio added the OnReceive method. So after that, I'll write my codes in the OnReceive method. Now before I continue, I need to define this class in the manifest file. There are two ways to get these broadcast receivers. First one is the manifest declared receivers, and the second one is context registered receivers. And we're going to learn both of these in this video. So we're going to start with manifest declared receivers. So I'll open up the manifest file, and under the activity tag, I will define my receiver class. And I'll just write in here, receiver, Android, name, and class name, receiver example. After that, I'll close the receiver tag. And inside the receiver tag, I will write action tag. So in here, I will select broadcast receiver type. And I mean which system events I want to know when it happens. That's what I select here. And you can see here which system events you can take from the receiver. For example, action power, connected and disconnected. This event sends a receiver to the application when the device is connected to the charger or disconnected from the charger. Another one is airplane mode. When the device switches into airplane mode, the system will send a receiver to the application. Another two are battery low and battery OK. You can learn the device charge status by using these methods. Now another one, device storage is low. So this is also a very good method because when the device storage is low, your application can take a receiver, and then after that, you can start a background task to delete some useless files on the device storage. So of course, there are a lot of methods here, and you can research every one of them yourself. I just want to give you that hands-on, nitty-gritty, nuts and bolts kind of feel, right? For example, reboot. This message will send a broadcast message when the device is rebooted. Another two are screen on and screen off. So if you want to start something when the device screen is on or off, you can use these methods. What I'm going to do is select airplane mode in this example. And after that, I will close the action tag. Now when the device switches to airplane mode, the system will send a broadcast receiver to my broadcast example class. And I will take this message in the onReceive method. Then after that, I can do whatever I want with the message. In this example, I will show a toast message when the device is switched to airplane mode. And I'll just write in here toast.makeText. And it wants three parameters. The first one is context. Second one is message. And the message can be devices in airplane mode. And the last one is toast message time. And I'll write toast.length long and .show. Now, when the device is switched to airplane mode, the system will send a broadcast message to the broadcast example class. After it gets this message, the broadcast example class will show a toast message to the user. Now, if you want to do another thing or start another task, you can write it in the onReceive method. So let's run the application and we'll see if it works or not. So the application opens. I will change it to airplane mode. So I will change it. And you see, when I change the airplane mode status, it showed me the toast message. So this method notifies the application when the device changes into airplane mode. What does that mean? When the device switches to airplane mode or switches back to normal mode, the system will send a broadcast message. Cool. So now, how will I understand the device is switched to airplane mode or to normal mode? I need to learn the device is in airplane mode or not. So while the system is sending a broadcast message, it also sends a Boolean parameter. Now, if I use this Boolean parameter, I can learn the device status. When the airplane mode is open, let's say, the parameter will be true. When airplane mode is off, the parameter will be false. And I'll create a container to catch this Boolean parameter. And I'll write Boolean is plane mode equals intent dot get Boolean extra. So this method will take two parameters. First one is keyword, and it will take the message using this keyword. And the system sends the message with the same keyword. The keyword is state. Second one is default value. And I'll give the default value false. If the device switches from normal mode to airplane mode, the system will send true. If the device switches from airplane mode to normal mode, system will send false, right? And I will create an if-else condition. If is airplane mode equals true, it will show this toast message. Else, it will show an other toast message. Message will be device is not in airplane mode. So let's run it again and see that. So the application opens, and when I switch to airplane mode, it shows the toast message. Device is in airplane mode. And when I switch to normal mode, it shows the toast message. Device is not in airplane mode. Excellent. So this is how manifest declared broadcast works. Now, of course, I can grab some other system events using this broadcast message. Also, there's another way to get those broadcast receivers. It is called context registered receivers. I'm sure you remember that from the beginning. So now I want to show you this method, and then you can choose whichever one you want for whatever purpose you're going to do, which is designing excellent applications. So first I'm going to delete this declaration in the manifest file because I really won't be using it like this anymore. I will not change anything in the broadcast example class. So you know what? Let's go to the main activity class and create an object of the broadcast example class. And I will write here broadcast example BR equals new broadcast example. Now after that, in the onCreate method, I will create an object of intent filter class. And I will write intent filter, filter equals new intent filter. Then on the second line, filter dot add action. And then inside the parenthesis, intent dot. And now, can you see this right here? All of the methods you saw in the manifest file are all here now. So now you can select one of these methods. For example, airplane mode, screen on and off, boot completed. All of these methods are here. So I'm going to select airplane mode changed. Then after that, I'll write this dot register receiver. So this method will take two parameters. The first one is object of the broadcast receiver class, BR. Second one is object of the intent filter class, filter. Okay, so now it's going to work. So when the application works, it will take the receivers in the receiver example class. So while the system is sending broadcast receiver, it will also be sending the Boolean parameter. If it is true, it will show this toast message. And if it is false, it will show another toast message. But before the run, I do need to say something. Are you ready for this? Just plan. So I need to register this method in the onStart method and unregister it in the onStop method. Yeah? Hopefully you thought of that too. But why is that? Because it will take receivers when the application is open, and it will not take receivers when the application is closed. Right. So I will write in the onStop method this dot unregister receiver, BR. And when I unregister the receiver, I'll write just the object of the broadcast receiver. So let's go ahead and run the application. Application is open. Device is in airplane mode. And when I switch back to normal, it shows a toast message. Device is not in airplane mode. And when I switch to airplane mode again, it shows a toast message. Device is in airplane mode. Now, if I close the application, will it continue to take the receiver? So I close the application and change the device to airplane mode status. And as you see, it does not show the toast message. So what does that mean? The application will not take broadcast receivers anymore because I unregistered it in the onStop method. So when the application passes onto the onStop method, it will not take those broadcast receivers anymore. That makes sense, right? So the application will take broadcast messages when the application is in the foreground. You can change this according to your needs, of course, but I'm going to be leaving it all up to you. So what do you think? I think it's enough for this video. I hope it's useful for you. Go back and practice if you need to review anything, and I will see you in the next video. Intense. Hello, everyone. I know it seems intense, but what I want to do is speak about another kind of intense in this video. An intent is an object that provides runtime binding between separate components, such as two different activities. At the same time, it will also provide data transfer between these two activities. So the intent represents to an application intent to do something. Does that make sense? Cool. So it's used for a variety of tasks, and it has a very important place in Android application development. So we're going to talk about how intents are used to pass between two activities in this video. And also we're going to learn about how to transfer data between two activities while passing one activity to another activity. What do you think? Let's do it. So we'll go to the Android Studio and see it in practice. So here you can see I created a new project in Android Studio. And of course, you know how to create a new project, so I don't have to tell you that anymore. Now, also, I added two components to the main activity. First one is an edit text, and the second one is a button. So what are we going to do in this example? We're going to write a name in edit text, and when we click on the button, it will open another activity. Also, it's going to get the name from the edit text and send it to the second activity. That's why it's important. So first, let's change the text of the button. I'll just write go to the second activity. And when I click on this button, it will open the second activity. So now I need to create a second activity. I'll click App. And after that, I will select File, New Activity, and Empty Activity. Now I need to give a name to this activity. What do you think? I'm just going to call it Second Activity. Very creative, but it's clear. Stay with me. Click OK. So now I've got two activities. All right, so I just need to add a text view to the second activity. So when this activity opens, we will just grab that name from the main activity and write the name on this text view. And I can change the text size of the text view to see it better. So first I want to show you how to open the second activity using intent. That was the intent of this video. So I'll just go to the main activity and check IDs of these components. So the ID of the edit text is edit text. ID of button is button. Also, I'm going to delete the text of the edit text, but I will add a hint. And the hint will be, write your name. So the hint just explains what you want the user to do. And then after that, I'll define these components in the main activity Java file. So first, I will define edit text. I'll just write here edit text name. Second, I will define the button. I'll write here button go. You can, name it whatever you want, of course. I really can't see you. Now, in the onCreate method, the name equals find view by ID r.id.editText, and go equals find view by ID r.id.button. I will check this ID too. And after that, I will add a click listener to the button. And I'll write go.set on click listener, new view on click listener. I will start new activity in this click listener. So, how does intent work? First, I will call the event class and create an object of this intent class. I will write intent, and that way, when I call the intent class, the Android Studio imports the intent class. After that, I'll need to give a name to this intent object. I'll just give the name as intent, but of course you can put whatever name you want. So intent equals new intent. Now this intent method takes two parameters. The first one is activity name, and that will start the intent. So I'll write main activity dot this. The second one is activity name that will open using intent, and I will write second activity dot class. So now this method will open the second activity, but I will need to start this method to begin with, right? So in order to start this method, I will write start activity, and inside the parenthesis, I will write the name of the intent object, and its name is intent. So let's run the application and see. So the application's opened. So after I click the button, the second activity is opened. In the second activity, I have a text view. So that means the intent is working, but it needs to write the name on text view. So I need to write the necessary code for that. So now we know how to open another activity using intent. So while intent is opening another activity, it can also transfer the data to that second activity. And if we want to transfer data to the second activity, first we will need to take this data from the edit text. How do we do that? That's why we're taking this course. Okay, then let's continue. So when I click the button, it should take the name from the edit text, right? So because of this, I will just write my code in the click listener. And I will create a string container, and I will write string username equals name dot get text dot to string. Now this code will take the name from the edit text, convert it to string, and assign it to the string username. Then after that, I can send this username to the second activity. I will write intent dot put extra. This method also takes two parameters. First parameter is keyword. The keyword matches that of the sender and receiver. And I will write keyword here. You can use your keyword just as long as it's the same for both sides and it's unique. And the second parameter is data. My data in here is username. So after I write these codes, the username will go to the second activity, right? But I need to catch it in the second activity. So in that second activity, I have a text view. The idea of this text view is text view, and I will define this text view in the second activity Java file. So I'll just write in here text view username, and in the onCreate method, username equals find view by ID r.id.textView. Now I define the text view. So after that, I'll write intent equals get intent. And I'll create a string container again. String name equals intent.getString extra. Now, why did I write this code? Because I send string from the main activity. If I want to take it in here, I've got to write a get string extra. If I sent Boolean from the main activity, then I would just write get Boolean extra. Get it? So if I send integer, I would write get int extra. I can send every data type from one activity to another activity using intent. So I will write get string extra, and inside the parenthesis, I will write keyword. And my keyword is keyword. See why I keep it simple? So after that, I will need to write this data onto the text view. And I'll write username dot set text name. Now let's run the application again. So the application opens, and I'll write a name here. And click the button. And after I click the button, the second activity is open, and the name is written on the text view. What do you think? That's it. That's how intent works. So using intent, you can open another activity and then transfer data between activities. Now, I don't know about you, but that's enough for me for this video. If you need to review something, go back. Otherwise, I will see you in the next one. Shared Preferences class. Hello, everyone. We're going to speak about the Shared Preferences class in this video. So sit back. It's going to be a great ride. So first, let me tell you that Android provides many ways of storing data in an application. Shared Preferences class is just one of them. So in the Shared Preferences class, you can save primitive types of data. These are integer, string, Boolean, all that kind of stuff. In the Shared Preferences class, you can save and retrieve data in the form of key value pair. For example, if you want to store an integer type data, you will save this integer data type and a key that matches the data. You can save a relatively small collection of data in the Shared Preferences class. And also, we can reach these saved data types anywhere within the application. So, where can we use Shared Preferences class? What do you suppose the better situation is to be using Shared Preferences class? We can use the Shared Preferences class, especially in the sudden exits from an application. Now, you must remember that we spoke about a life cycle in Android. So a feature of Android applications is that you can switch between the applications. So while you're working on one application, you can, let's say, take a phone call or make a message, or let's say you want to just check something from another application. So during these transitions, your applications can be closed, paused, or passed to the background. You may need to save application data during these transitions. See where I'm going? So the Shared Preferences class is very good for this type of situation. So let's say, for example, while you're playing an Android game, you need to exit from the game suddenly. You can save your last score. You know how important that is. So while you're playing a game, you can take a phone call or message somebody. If you want to answer this phone call, your game application will pass to the on-pause method or on-stop method. When you come back to the game again, you should be able to continue where you left off and also with your last score. So you can use the Shared Preferences class to save this kind of data, such as last score, highest score, game level, So let me give you another example of the Shared Preferences class. You can use this class in login operations. So most of the applications have a login page, yeah? So on this page, the user has to enter a username and password. If the user does not want to enter this information every time, the user can check a Remember Me checkbox, right? And then after checking the checkbox, the application will save user data. And when the user comes back again to the application, the user will not have to write the username and password again. The application will remember it and write it automatically into the necessary fields. Guess what? You save this kind of data using the Shared Preferences class. So this feature provides user convenience, we'll call it, right? Now, another example can be using mail or message applications. So in these kinds of applications, the user can write long texts. We've all get them. So while the user is writing a long text, if the user needs to exit from the application or switches to another application, the text should not be deleted, right? So before the user goes out of the application, you can save what the user wrote using the Shared Preferences class. And when the user comes back to the application, they'll be able to retrieve the data, and then the user can continue where he or she left off. So this is how you use Shared Preferences class for these kinds of applications. So I think the explanation is enough. So let's get to Android Studio and see how to save local data using the Shared Preferences class. Shared Preferences, saving data in the local memory. Hello everyone, today we will learn how to save data in local memory using the Shared Preferences class. So you can see here I created a new project, and if you want, you can use your older project. I'm just keeping it clean. And I will add 4 components to the project. I'll add 1 edit text, 1 multi-line text. Now, you know that multi-line edit text is used on the message applications, right? So the user can write a long text message using multi-line edit text. Also, I'm going to add 1 button and 1 checkbox. So now I have 4 components, and I will change the design of the components a little bit. I'll select 4 components, and I'm doing this by pressing the Control key on the keyboard. And I'll change the layout margin. So I will change the layout height of the multi-line text to 200. And I will change the text of the button. I'll write 0. All right, so now my crude design is ready. So now I want to save data in these 4 components using the Shared Preferences class. So first, I will define these components in the main activity Java class. So what do we have here? 1 edit text. I will write edit text, username. 1 multi-line text. I will write edit text, user message. 1 button. I will write button counter. And 1 checkbox. I will write checkbox, remember. And I will continue to define these 4 components in the onCreate method. But before I continue, I do need to give an ID to these components, yeah? So the ID of the edit text is edit text name. The ID of the multi-line edit text is edit text message. ID of the button can stay the same, button. And the ID of the checkbox can also stay the same, checkbox. Okay, good. So now I can continue. Thanks for waiting. So I'll just write here, username equals find view by ID r.id.edit text name. User message equals find view by ID r.id.edit text message. Counter equals find view by ID r.id.button. Remember equals find view by ID r.id.edit checkbox. Now, why on earth did I call the checkbox remember? I mean, you know generally that a checkbox is used in these kinds of applications to, it's like a remember me button. If you check this checkbox, it will remember you for next time. So because of this, I named it Remember. Do you remember? Because I do. Hopefully it was part of it. Maybe I better rewind and check it. No, I'm just kidding. You can name it whatever the heck you want, but now you know my intent. So I'm going to add an integer container. I will write int count equals 0. After that, I will add a click listener to the button, and I will write counter.set on click listener, new view on click listener. Inside the onClick method, I will write count equals count plus 1. I want it to increase plus 1 on every click on this button. And it will write the new count value on the counter button. And I will write counter.setText. And inside the parenthesis, quotation marks plus count. Now, I really do want to mention this, that normally you cannot write integer values on the button because the text should mostly be a string. You can write it after the convert integer value to string value, but this is just a shorter way to convert an integer to a string. If you write quotation marks before the integer value, it will convert it to a string. So I'm going to run the application in this state to show you what I'm going to do. So the application is running. I've got 4 components, 2 text edits, 1 button, 1 checkbox. So I'll write a name in this edit text. Now also I'm going to write something in this multi-line edit text. Now it's not important what I'm going to write here. So, also I'm going to click this button several times. So every click, the counter is going to increase plus 1. And let's see. I'm going to click the checkbox or check. I guess we check checkboxes. Check. So if I leave the application without saving this state and then open the application again, I will see that everything is gone. So think about that. You wrote a name here. You wrote a long text message here. This counter can be a score or something, and you check the checkbox. So after these operations, if you have to close the application suddenly, everything is going to be deleted. So why did I use these 4 components? Because this edit text uses string. So this multi-line edit text also uses string, but it's a long string. This button uses integer, and this checkbox uses Boolean. So you know that the checkbox can take 2 states, checked and unchecked. It's either true or false. So I want to show you how to save a string, integer, and Boolean values. And here we are. We are now going to finally get to the idea of how to save these values in local memory in this video. And then after that, we're going to learn how to call back these saved values. Before we continue, I want to show you again what happens on the device. So I'll write a name here, and I'm going to write something here. And I will click this button several times and check the checkbox. And then after that, just close the application. Now, open it up again, and you see that everything's deleted. So that's why I'm going to show you how to save these values using the Shared Preferences class. So I will first go to the main activity file. Now, before I call up the Shared Preferences class, I will create containers. I'll write string name, and this, of course, will be a username, string message, And I will take the user message, and Boolean is checked. And of course, this will take a checkbox status. Now, I already have an integer count container, so I don't have to write it again. Now, after all that, I can call the shared preferences class. And I'll write shared preferences. Now, I need to name the shared preferences object. And the name can be the same, shared preferences. Okay, so now after that, I do need to decide when I will save these values. So if you look here, when I close the application, the values are deleted. So if you can remember back that far, because I don't know if I can, when I explained the Android lifecycle, remember that I told you that if you close the application, it will pass it to the onPause method first. And then after the onPause method, it will pass it onStop and then to onDestroy. So if I save the values in the onPause method, I won't lose the values, right? So I will do my shared preferences operations in the onPause method. I will call the onPause method, and I will save the values in the onPause method, but I will create a save method, and I will write the saving codes in this method. Then after that, I can call this method in the onPause method. So this will make my job a whole lot easier, and hopefully yours too. And now I can use this save method wherever I want. So I'm going to write here public void save data. And then inside this method, I will call the shared preferences object. I will write shared preferences equals get shared preferences. And this method will take two parameters. First one is name. So this name is for the main shared preferences class. Second one is mode. Mode will be the context.mode private. So this mode private will give me access permission to save data from everywhere in the application, but it will restrict accessing outside the application, right? So that means that other applications will not be able to reach the saved data. Now, if you want to reach saved data from other applications, of course you can use other methods. Okay, so after all that, I want to put all this data into containers that I created here. So first, let's get the username, and I'll write name equals username dot get text dot to string. So this line of code will take the name from the username edit text, convert it to the string, and assign it to the string named container. Okay? So second, I want to take a message. So message equals user message dot get text dot to string. And then third, I'm going to need to take that count value, but I don't need to take it here because it increases after every click. And then assign it to the above. Okay, so lastly then, I will grab that checkbox state. So when I close the application, if it's checked, its state will be true. And if it's unchecked, its state will be false. And I will save its status. Okay, so I'm going to write if remember dot is checked. And then this is the checked method. and it will control the checkbox status, checked or unchecked. If it is checked equals true, else is checked equals false. So I grabbed every piece of data from the application. So now we need to save this data. I will call the editor class. I will save my data using this editor class. It's a subclass of the shared preference class. So when I write editor, Android Studio shows me shared preferences.editor. So all I have to do is select it. So let me give a name to this editor object. It can be editor as well. Editor equals shared preferences.edit. This shared preferences is an object shared preferences, the one that I created above. So then after that, I will save the data using this editor. And I'll write editor.putString. If I want to save the string, I will write putString. If I want to save an integer, I will write putInteger. And if I want to save Boolean, I will write putBoolean. So all of these methods will, of course, take two parameters. The first one is keyword. Second one is the data to be saved. Now you remember that shared preferences class stores data using a key value method. So if we want to call this stored data, we will call it using this keyword. So I'm going to write for the keyword key name and what was the data to save name. Okay, so let's continue. Editor.putString key message. Editor.putInt key count. Now, I gave the keyword key count, and I want to save the count value. But the last one is editor.putBoolean key remember is checked. Now, of course, you need to be careful about the keyword. The keyword has to be unique, and that's because if you use the same keyword in another place, it can be confusing. Now, after that, I will write editor.commit. This line will store the data. And if you don't write this line, your data won't be stored, right? All of that work, and if you don't put in the right editor.commit. Now, my save method is ready. So I can use this method, again, wherever I want. So let's, finally, let's add a toast message. After the save, it will show us a toast message. Message is, your data is saved. And now I will call this method in the onPause method. But of course, if you want to, you can use this method in another place. But for now, let's stay with this. But just to give you an example, you can create a save button and then use this method in the button click listener. If the user clicks the save button, it will, of course, save the data. So why don't we right now run the application and see if it works or not. No, I'm confident. I know it does. You might not. So the application is open. I will write a name here. And I'll write something here. And I'll click this button several times. And I will check the checkbox. And now I will close the application. And after I close it, toast message is seen. So now my data is saved. What do you think? Let's open up the application again just to see. And what do we see? Do you see what I see? When I open the application, nothing came back. Oh, it's a disaster, right? Don't worry, the data is saved. Actually, the data is saved in the device. But if we want to see the saved data, we've got to call it back. So what do? We call it back in the next video. So I'm going to see you over there. Shared preferences, calling back data. Hello, everyone. So we're going to learn how to call back saved data using shared preferences class in this particular video. I'm sure that you must remember in the last video we saved data into the local memory, but we did not call it back. No, it's not a fault. It is called incremental experiential learning. We'll get to that later. Anyway, when we open the application again, the saved data did not come back, right? So what we need to do is we know that the data is saved into the device memory. Now we just have to learn how to call it back. First step, I'll create a retrieve data class, saved data class. I'll write here public void retrieve data. First, I will call shared preferences class. Shared preferences equals get shared preferences. And I will use the same keyword as above. The keyword is saved data. Also, I will use the same mode, context.mode private. Then after that, what do? I'll call save data back using the same containers. So first, I will call back name. Name equals shared preferences dot get string. So this get string method takes two parameters. First one is keyword. And what was the keyword for this name container? It was key name. Second one is default value. And you can define a default value if the key is not present. I will write null for the default value. Now, if the key is not present or nothing is saved, the default value will be null. So after calling back the name, I will call back the message. So message equals shared preferences dot get string. And keyword is key message. Default value is null. And then third, I will call the count. And no, not from Transylvania. Count equals shared preferences dot get int. Keyword is key count. And default value is 0. Okay, you follow? So the keyword is important, right? If you write the keyword wrong, it will not call back data. Then you got to do some troubleshooting. So let's just write it first in the first place. So the last one is, that's also why I keep things clear as can be. But yeah, so the last one is checked Boolean value. Is checked equals shared preferences dot get Boolean. Keyword is key remember, and default value is false. So now I'll call back data and assign them to the containers. Right, so after that is complete, I need to write this data in place. Okay, so how am I going to do that? So I took data using the get text message from the username component. So this time, I will write on the username and the other components. Just bear with me. I will write here username dot set text name, user message dot set text message, and I will write count value on the button. Name of the button was counter. Counter dot set text quotation marks count. So the quotation marks will convert an integer to string. And the last one is Boolean value. So I called back the Boolean is checked value. If is checked value is true, I will set, remember checkbox, to be checked. If is checked value is false, I will set checkbox to unchecked. So I will write if is checked is true. Remember dot set checked true. Else, remember dot set checked false. Now my data retrieve method is ready. So I will call this method in the onCreate method. You can call this method, of course, wherever you need to, now that it's set. I will write here, retrieve data. So let's run the application again. So the application opens. I'll write a name here. And I'll write something here. I'll click the button several times. And I'm going to click that checkbox. All right, check the checkbox. So now I will close the application. When I close the application, look, there's a toast message. Data is stored. So now I'm going to open up that application again. What do you know? Everything came back. So this time I will uncheck the checkbox. And I will click the button again, close the application. So now when I close the application, it will save the last status of the application. And when I call it back, it will set everything to that last status. Pretty cool, huh? Great. So that's pretty much how you use the shared preferences class. If you want, you can, of course, come up with some multitude of creative ways, I am sure. For example, you can, just to whet your appetite, you can put a save button somewhere in an application, and if the user wants to save any type of data, the user can just click that save button. Alrighty then, so in this video, we learned how to retrieve that saved data using the shared preferences class. I want to see you in the next video because I know you hunger for more. Multiple language support. Hello, everyone. We're going to talk today about how do you support multiple languages in Android applications. So this is going to be a very entertaining video because we both speak thousands of languages, right? Let's just go back to the Android operating system. It runs on millions of devices in many, many, many regions. And in all of these regions, people speak, of course, even many more languages. So if you develop an application in your particular language, what do you think? You can't really publish your application around the world. I mean, even if you do publish, people around the world will not use your application. So because of this, you really should learn how to support multiple languages in your application. Ain't it grand that you happen to tune into this video right now? So, you're asking me again, aren't you? How do you support multiple languages? Just be quiet and let me know. Will you develop another application for every other language? That, could be a workaround. Not a very time-efficient one, is it? So what I'm saying is you will develop one application, and within this application, you will give multiple language support. So the system works like this. The Android operating system considers English a default language, and you will develop your application in the English language. Then after that, you can support other languages, but you really do need to be careful. You know why? It's not an afterthought. You need to consider supporting multiple languages from the very beginning. If the device language of the user is English, Android operating system shows your application in the English language. That makes sense. So if the device of the user is in another language and your application supports this language, Android shows your application in that language. If your application does not support the user's language, Android shows your application in the English language again, which again is really no use at all. So let's say, for example, you develop an application in English and you support the French language. If the device language of the user is French, then your application will be seen in its entirety in flashing French language. But if the device language of the user is German, your application will be seen in English again because your application doesn't support the German language. You follow? So now, after that heartbreaking news, let's go to Android Studio and see how we do this in practice. So, of course, I've already created a new project in Android Studio, and I will add a text view and a button to the project. I'll change the layout width of these components to wrap content. And also, I'm going to change the text size of this text view. I think the bigger size looks better, at least in my eyes. So now I want to change the text of this text view. So before, we could write text in this text area. For example, I can write in here, hello world, but we don't want to do it like that because we want to support what? Multiple languages. So I'm going to delete this and write text view again. So if I click here, you see how a new window opens? So in this window, I'm going to click add new resources and click new string value. So after I click the new string value button, a new window opens again. Now, in this window, I need to define two parameters. The first one is resource name, and I'll just give a name to this string. So when I need this string, I will call it by using this name. Let's call the name, the name can be hello. Second one is resource value. And this is the string that I want to write on the text view. String is hello world. After that, I can click OK. Now you can see that it writes hello world on the text view, but if you look at the text area, it writes in there string / hello. What's up with that? So if I click here again, you can see there is a keyword here. Its name is hello, and the string is hello world. So now I will change the text of the button. I'm going to click here again, click add new resources and new string value. So when I click this button, I want it to show a toast message. So because of this, the resource name can be show toast, but in the resource name, you cannot put a space, right? So I will just write show underline toast. And the resource value will show a toast message. So click OK. Now you can see on the button, it writes show a toast message. But in the text area, it writes string/show underline toast. Right? So you see where we're going with this. So now I can see all of the strings in the string XML file under the values folder. So I'll just open up this XML file and I can see here all of the string resources. Name is hello. String is hello world. Name is show toast. String is show a toast message. Now, when I add new string resources, they are added here too. So if I want, I can, just add one directly right here. Either way, it's the same result. So when I click this button, I want to display a toast message. So I'll check the ID of this button. And then after that, I'll define this button on the Java side. And let me just write here, button show. And in the onCreate method, show equals find view by ID r.id.button. And I'll add a click listener to the button. Show.set on click listener. New view on click listener. And in the onClick method, I'll write toast.makeText. Now, before I continue, I will need to define other string resources. So I'll open up string XML, and I will write in here string name equals toast. And the string is, this is a toast message. So now I can call this string in the toast message. So now I can go back to the Java side. I'll write toast.makeText. And here the toast method, it takes 3 parameters. The first one is get application context. Second one is message. Now, hopefully you can remember, normally I write message between the quotation marks, right? But this time, if you noticed, I'm not going to write inside the quotation marks. So I'll write r.string.toast. The third one is toast.length, long, and .show. So the application is ready for English. Let's run up the application. And the application looks like it's working. So let's see, when I click the button, it displays a toast message. Okay, so now we've set it up so that we can support another language. So there's a world icon here. You see that? I'm just going to click on this icon and select Edit Translations. And it opens in a new window. So in this window, I can see all of the words that I need to translate. And I have 3 string values here. First one is application name, and the others are hello and toast. And the same 3 strings are here too. So I will add another language here. I'll click this world button and select a language. Let's see, how about if I choose, I'm going to select Turkish. Now, also, you can see here how many languages that Android supports. All right, so now I'm going to write here translation of every string. And I will write the application name in the Turkish language. And I will also write translation of hello world and the translation of this is a toast message. So when I add a new language, Android Studio added automatically a new string XML file. And this file has a Turkish flag. So I will open this file. You can see here the same string names equal translated strings in the Turkish language. So when I run my application, it's going to support Turkish. So now I'm going to change the device language and select Turkish. So when I select the Turkish language and open my application again, everything's changed. And unless you can read Turkish, I'll let you know that now my application is working in Turkish. Oh, and also when I click the button, the toast message displays in Turkish as well. That's how it works. So if you want, you can support other languages. You just go through that scroll and hit them up. You know what to do. So we learned how to support multiple languages in this video. And, I don't want to see you back here until you support every single one of them. Just plan. Have a go and see what you come up with. I'm going to see you in the next video. I can feel it. Support different pixel densities. Hello, everyone. We will learn how to support different pixel densities while developing Android applications in this video. So Android devices are amazing. They come in different screen sizes and different pixel sizes. If we look at two different Android devices that have the same screen size, we can see that both of these two devices have different pixel densities. For example, one device has 160 pixels per square inch. Another device has 480 pixels per square inch, but it's in the same screen size. So that means that if you want to use a picture or an icon in your Android application, you're going to need to consider these different screen densities. Otherwise, your picture icon's not going to look, smooth. It certainly won't look the way that you want it to look like in your application, in your stellar award-winning application. So, of course, you should avoid this kind of problem, but how are you going to do that? If you want to develop user-friendly and well-designed applications and win those awards, let's figure it out. So I want to show you in a real-time example. So here there are two devices, and these devices have the same screen size, but these devices have different resolutions. So if you don't consider these differences in the resolution from the very beginning, your pictures may and will look blurry. Now, sure, you can use a low-resolution picture or icon in a high-resolution device, but your picture's going to look all blocky, blurry, and, well, just bad. So if you want to avoid this problem, let's not use pixels in your measurements. What? Mind blown. So Android proposes another measurement unit. We will use DPI as a measurement unit. Now, actually, of course, there are a lot of things, but we can speak about pixels and DPI, but you know what? I don't want to confuse the issue here. It does get a little confusing for everybody, but you just got to know these 5 sizes, okay? It's going to be enough for you for right now. So this is how the system works. When you use a picture or icon in your application, you will use the same picture with 5 different resolutions. These resolutions are MDPI, HDPI, XHDPI, XXHDPI, and XXXHDPI. If you use these 5 different resolutions in your application, the Android operating system will use the picture in whichever resolution that particular device needs. The Android operating system considers MDPI as a base measurement unit. The other dimensions are determined according to this size. So I'm going to show you how to resize your images according to these dimensions. Now, here's a table about these measurements, and you can study the table. For example, let's look at first MDPI. It means resources for medium density screens. 160 DPI is MDPI. Another one is XXH DPI. It means resources for extra high-density screens. 480 is XXH DPI. Now, you don't have to learn everything on this table. Also, you don't need to know which device has which density either. I mean, unless, you really want to. If you put every photo, though, that you're going to use in your application with these 5 different densities, then Android will use a necessary photo in the necessary device. So it takes a lot of the guesswork out. So I'm going to show you how to do this really easily, actually, in Android Studio. So let's go to Android Studio and do some practice. So I created a new project in Android Studio. So in this project, there is a MIP folder. And in this folder, I sound like a magician, right? And in this folder, there is a photo, but with 5 different versions. So the most important thing is all of them have the same name. I repeat, all of them have the same name, okay? 1 photo, 1 name, 5 different versions. All of them are the same photo, but different densities. So I'm just going to right-click on the MIP folder and select Show in the Explorer. Now, if you look here, you can see that there's a folder for every density. And in every folder, there's a photo. So how do we test these photos? I'll show this to you as well. So now you know that we use virtual devices to test our applications. So what will I do? Click Tools, AVD Manager. And in this window, I will click Create Virtual Device. So in here, you can see that every device has a density value. For example, this device has HDPI density, and you can test your HDPI picture right here on this device. Also, you can check it using this table. So on this table, you can see which resolution corresponds to which value. For example, XXH DPI resolution is 480 DPI, And if you see this DPI on the device density, you can understand that this device has XX HDPI resolution. You can find the right device to test your photos, in other words, in this application. Now, I want to make you aware of another situation. So let's say, for example, you have one photo and you want to use this photo in your project. How can you produce 5 different densities of that photo? Well, my friends, that's why we're here in Android Studio. Android Studio does it quite easily. Of course, there are 2 ways. It's up to you. One way is to produce an icon using a photo. An icon is basically a small size photo, right? Another way is to produce a normal photo with different densities. So I'm going to show you both ways. First, I'll show you how to make an icon with 5 different densities from one picture. So I'm just going to right-click on the Res folder and select New Image Asset. And a new window opens. So I can see here 5 different densities: MHDPI, HDPI, XHDPI, XXHDPI, and XXXHDPI. So when I select a picture, it will produce icons that have 5 different resolutions. So I'm going to select a new picture. And I can change the name of this picture. Let's call it Image Example. So now you can see here the same picture with 5 different resolutions. Oh, come on, it can't be that easy. Stick with me, because after that, I'll click Next. And it might take a moment or 2, depending on your computer. So right in here, Android Studio shows me where to put these icons. And then I'll click Finish. So now it's ready. All of the icons are under the Image Example folder. So I'll just open these pictures, and you can see all of them here. I can use these photos in my project now. So I'm just going to close them up. And I will add this icon in the action bar before or right in front of the application name. So also, you will learn how to add an icon into the action bar. So let's do that. I will go to the main activity.java file. I'll just write in here, get support action bar dot set display show home enable. And you can make it true or false. I will write true. Now in the second line, get support action bar dot set logo. And I'll write way of the logo inside the parenthesis, r dot mipmap dot image example. And the last line, get support action bar dot set display use logo enabled. And this will also be true. That's it. So now my icon's ready. Now, I don't know if you noticed, I did not select icon resolution. Why? That's right. The Android operating system will select it automatically. So I have 3 different virtual devices here. Now, every one of them has a different resolution. So these are custom tablet, Google Nexus S, and Samsung Galaxy S6. Their resolutions are XHDPI, HDPI, and XXXHDPI. So I'm going to show you these 3 devices. This is the tablet. This is the Samsung S6. And here's the Nexus S. So now I'm going to run my application on these three devices. So first, I'll run it on the custom tablet. Secondly, I'll run it on the Samsung device. And lastly, I will run it on the Nexus S. So now you can see three different devices. All of them have different resolutions. One icon with different resolution versions. I don't even have to decide which image to use. Android does all the decisions for me. So I just produced images with different resolutions and put every image where it should be. So that was how to produce the icons, right? Now I want to show you how to produce the pictures to use in your project. For example, in the image view. So if you want to use a picture in your project, you should add this picture with different resolutions like we've been talking about. Otherwise, of course, your picture will be blurry or just really crazy looking on different devices. And you can't control what device. Well, I suppose you could, but you don't want to control what device your application is used or played on. So I'll give you an example from experience. Your photo has low resolution and the device has a high resolution. It's just not going to look good, right? Now, before we start, we do need to install a plugin to the Android Studio. So I will select File, Settings, Plugins, and Marketplace. So in here, I'm going to write Android Drawable Importer. Now, I've installed this plugin before. If you did not install it before, you will need to install it now. It's about 37 megabytes, so it should be done by now, just depending upon your internet speed. After you install this plugin, you will need to restart Android Studio. I'll wait for you here. So after Android Studio restarts, you will right-click in the Res folder and select New, Batch Drawable Import. So if you see this, your plugin is installed properly. If you don't see this, you need to go back and install that plugin. Take my word for it, or you didn't, or whatever. Just do it. So when I click on the Batch Drawable Import, it will open a new window. In this window, I will click plus and select a picture. So after that, Android Studio is asking me where to add this picture. Click OK. Source resolution shows me the density of my picture, and my picture looks like it's XHDPI. So my picture has 5,000 by 5,000 pixels. Now you can also see here which pixels correspond to which resolution. And it'll produce for me other resolutions using my picture. So I can check or uncheck some of the options. And I can change the name of the picture in here. I'll just give the name Shutterstock. I can define my location to save the picture from here. I can also, I'll just click OK and then OK again. Now it started to create images with different resolutions. So it's magic. You can see here the same photo with 5 different resolutions. So if you have pictures with different resolutions, you can skip this process and you'll just add the pictures into their perspective folders. But if you just have one picture, or you just think this is pretty cool, you just want to add this picture this way and you're done. So what I'm going to do is right-click on the Shutterstock folder and select Show in Explorer. And what do you see? Every photo has the same name, but under a different folder. So if you were not asleep during this video, we learned how to support different pixel densities. So I just want to make sure that you don't confuse this topic with supporting different screen sizes, because those are 2 different topics. In fact, what do you know? It's kismet. It must be. We're going to learn about that in the next video. So I'm going to see you in that next video, right? Support different screen sizes. Hello, everyone. So now we're going to learn how to support different screen sizes while we are developing Android applications. So Android devices come, of course, with different screen sizes, and if you want to develop a good Android application like we all do, then you do need to create flexible layouts. Otherwise, the Android operating system will take your layout and scratch it to fit the screen. So the more you support different screen sizes and different devices, the more your application will be used by people, the more popular it becomes. And really the most beautiful feature of Android is that you can support different screen sizes and devices using just one APK file. Android operating system uses, I'd say, suitable design in a suitable device. You will develop one application, but you will create flexible designs in order to support different screen sizes within this application. So when you develop an Android application, you need to consider, however, both small and big screen sizes. Android splits devices into 4 different categories according to their screen size. These are a small screen, normal screen, large screen, and extra large screen size. So, of course, what does Android consider a small screen size? Well, it's pretty much between 2 inches and 3.7 inches. Android considers a normal screen size between 3.7 inches and 4.3 inches. Android considers a large screen size between 4 inches and 7.1 inches. And an extra large screen size is between 7 inches and 10 inches. So these categories are basically phone and tablet design. So if you develop an application for smartwatches or Android TVs, you will not be using these screen sizes. So how do you calculate screen sizes? For example, you can see here in the picture, there is a phone and its screen size is 5.5 inches. And that means that from one corner to the other corner is 5.5 inches. And 1 inch equals 160 dp. So please, again, let's confuse dp with dpi. dpi is used for screen density, and dp is used for screen measurement. So I'm going to show you how dp is used in Android Studio. So why don't we go to Android Studio and see it in practice? Now, I created a new project in Android Studio, and I've added some components to this project. Now, I did this because I don't want to take up your time showing you how to do it. I think you can do it. It's easy enough. We saw how to do it before, so you can do it by yourself. I know it. You probably already have. I just used a linear layout and added these components under the linear layout. And gravity of the linear layout is center. So here we are at our design page. I can change the size of this design page, of course. If I click here, I can see other screen sizes. Size of my design page is 5 inches, and its density is 420 dpi. Now I can explain DP to you. So we use DP measurement on the component size. For example, if I write here 200 dp, the width of this button will be 200 dp. If I write here 400 dp, it's going to cover the width of the screen. So the width of the screen is approximately 400 dp. So we will use dp and not pixel. Why is that? Well, we're designing Android applications. But from one corner to another corner, that gives us the screen size. That's the point. So what happens if I change the screen size? I can see how my design is going to look on the other screens. On the 7-inch screen size, my design will look like this. Okay, so let's spend just a moment talking about the virtual device screen sizes. So you know we use these virtual devices to test our applications, and that means that we can see the different screen sizes of the virtual devices as well. So I will click Tools, AVD Managers, and after that I will click Create Virtual Device. So here I can see the screen size of every device. For example, for the Pixel 2, screen size is 5 inches. If I click the tablet section, I can see screen sizes of the tablets. For example, the screen size of the Nexus 9 tablet is 8.86. So you can select one of these devices and see just what it'll look like, your application, on these different devices. So I've got 3 different virtual devices. One of them is Google Nexus 7 tablet. Its screen size is 7 inches. Another one is a Google Nexus 9 tablet, and its screen size is 9 inches. And the last one is Samsung Galaxy S6 phone, and its screen size is 5.1 inches. So these are my devices. This is the Galaxy S6. This is the Nexus 7, and this is Nexus 9. So if I do not create another design for different screen sizes, Android will take this design and it will show it, the same design, on all of the devices. So what I'm going to do is I'm just going to show you by running the application on these 3 devices. First, I'm going to run the application on the Galaxy S6. And what do you see? The design looks normal on this device. So now I'm going to run the application on the Nexus 9 tablet. And sure enough, it's working. So let's have a look at the last one. I'll run it on the Nexus 7. And now you see my point. You can see the same design on 3 different devices. So our design looks small on large screen devices. And if I add small size components in this particular design and run this design on the big screen, well, that's just not going to be useful on the bigger screen devices, right? Okay. Problem solution. So because of this, when you develop an Android application, you should create a special design for the bigger screens. So if I use big screen size components in this design and I run this design on a small screen, well, some of the components are not going to be seen. And because of this, when you develop an Android application, you really should create a special design for the small screens as well. All right, so you get the point. Well, also, I do need to mention one other thing. So now the device is vertical, and this is the mode that we call portrait. If I change the device mode to horizontal, my application also turns, but some of the components don't look good anymore. In fact, you can't even see some. So, of course, this mode is called landscape. So users in general do not use their phone just in portrait mode. They sometimes use landscape mode. So I keep in mind that whenever I design an Android application, I also need to consider this too. So I need to create a particular design for landscape mode. So now I'm going to show you how to create different layouts for different screen sizes. Now, we mentioned earlier that Android splits devices into 4 different categories according to their screen sizes, and that means that you need to create 4 different layout designs. So I'll just right-click on the layout folder and select New Layout Resource File, and this will open a new window. And in this window, there is a size section, and I'll just select the size and click this forward button. So it opened a new category, and in this category, I can select screen sizes. They're small, normal, large, and extra large. So I'm going to select large, and now I need to give a name to the file, and again, let's be careful. The file name must be the same as the main design file. So I'm going to write in here activity_main and click OK. Android Studio created a new layout for a large screen. So my design here will be shown on a large screen device as I design it, as I intend it to be. So I just copy these components from the other layout and pass it to the large screen layout because I don't want to take your time about the, with the design. You can create your own design. I just want you to see what you're going to be facing. So did you notice when I pass over to the large layout, the screen size changed to 7-inch? So I'm going to delete some of these components from the large screen layout because I want to show you the difference between the two layouts. And I'll just run this layout on the 7-inch tablet. Okay, so now I have 2 different layouts, and I'll run this application on the 7-inch tablet. Android Studio will choose one of these designs automatically. And sure enough, Android selected the large screen design for the large screen device. So let's go ahead and create another layout, and I'll right-click on the layout folder and select New Layout Resource File. And I'm going to give the same name to this file. This time I will select the extra large screen size layout. And when I create this layout, Android Studio shows me this layout on the 10-inch screen. So I'm going to copy the design from the other layout and just paste it into the extra large layout. Now, when I use the same components on the bigger screen, they will appear small on the screen. So you should change the size of the components. And you can use the big size components on the big screen devices, obviously. Now, I will delete some of the components here so I can show you the difference between the layouts. Okay, so now I have 3 different design layouts, and 3 of them are the same name. Every one of them has a different design. So now I'm going to run my application on the 10-inch tablet. This time, Android Studio selected the extra large design for the 10-inch tablet. Now, even though I have 3 layouts, Android Studio selected one of them automatically, so I do not need to specify anything. So now I will run my application on the 3 devices again. When I run this application on the S6, the Android, of course, selected this layout. When I run the application on the 7-inch tablet, Android selects this layout. And when I run the application on the 10-inch tablet, Android automatically selects this layout. So you can see 3 different devices and 3 different layout designs. So that means that I will prepare my design for different screen sizes and put all of them in the one APK file. After that, everybody can use this APK file for their Android devices. So I can use bigger size components on the big screen layouts, right? So I want to mention again that these screen sizes are for the phone and tablet applications. If you develop an application for another device, such as a smartwatch or Android TVs, you will need to use other screen sizes. I'm sure you understand that, but I just want to reiterate that. So if I want to create a new project, I need to select project type. And I can select different project types from here. If you want to develop an Android application for smartwatches, you can select different layouts as well. Or if you want to develop an application for Android TVs, you can select this layout. And if you want to develop an application for the automobile systems, you can select one of these layouts. So all of these are indeed for portrait mode, let's remember. But we do need to create designs for landscape mode as well. So let me just show you how to create a design for landscape mode. I'll just right-click, layout folder, select new, layout resource file. Now this time I'm going to select orientation. And after that, I'll select landscape. And I'll, of course, name it the same as this layout file and click OK. Now, if the user changes device mode to landscape mode, this design will appear on the device. So I'm going to design the layout according to how I want it to show up on the device. So I will copy one of my other designs and paste it into landscape mode layout, and I'm going to change the design. Now I will add one horizontal layout and one vertical layout. And I will put 2 vertical layouts under the normal horizontal layout. And I will put some of the components in this vertical layout. And I'm going to change the layout width and height of the vertical linear layout to the wrap content. So now I have a new design for landscape mode. I know it's not a perfect design. I'm hoping that you can do better. But we're just talking about practicalities right now. So I'm going to run this application on the Galaxy S6. And when the device is in portrait mode, This design is what's on screen. Now, if I change the device mode to landscape mode, the landscape design is indeed seen on the device. And if I change the device mode back to portrait mode again, another design is seen once more. So if you want to support all the different screen sizes on their particular devices, you will need to create 4 different designs for portrait mode and 4 different designs for landscape mode, right? So it means that you need to create 8 different designs. But of course, if you don't want to support landscape mode, you just don't have to create designs for landscape mode. It's up to you. So this is the video that we learned how to support different screen sizes, and I will see you in the next one, right? I'm going to see you in the next video. There you are. Project 1, to-do list. Hello, everyone. I want to create a new project in this video. We're going to create it together. So this project we're going to call a to-do list. You can add something that you want to remember on this list, right? One of the most important things in this project, you will learn how to save data into the device memory and how to read this data back. Also, after finishing this project, we will learn how to create an APK file and how to publish this project on Google Play. So our project will basically look like this. Let's go to Android Studio without losing any more time, right? Get to the marketplace. So before we start, I do want to show you how our project will look when it finishes. So here's our application, and if you want to add a new item to the list, you can just write it here and click the Add button. And after you click the button, it will be added to the list. For example, let me write here, go to the office. So I will click the Add button. And so you see the new item is added to the list. Also, after adding the item, edit text is cleared. So the important thing here is when I close this application, the list will not be deleted. So all of the list will be saved to the device memory. So let's try it. I'm going to close the application and open it up again. And let me just mention one more thing. You know, all of the applications that we've created were looking into the device with the Android robot icon. But this time, our application will have a new logo. So when I open the application again, the list is the same and everything came back. Didn't lose any data. Yes, that's the point. Also, there's another feature inside of this application. So when you click on an item in the list, it will ask you to delete this item. So if you click yes, it will delete the item from the list. If you click no, it will not delete the item from the list. So also, let's know this, the application is working pretty slow. Why? Because it's working on the virtual device. If you run this application on a real device, it won't be this slow. So let's start up the project. First, I will create a new project. And this project will be for phones and tablets. So I selected empty activity and I'll click next. I'll give a name to this project. Name, let's call it to-do list project. And Android Studio gave a package name automatically. And I can select where to save this project from here. That's okay. And programming language is Java. Minimum API level is 15. My application will work on all of the devices in the marketplace. You remember that from before. So I'll click Finish. Android Studio will create a new project for me. So now the new project is ready. It's, of course, an empty project. Now there's an icon here. Looks like an eye. You can see how the layout design will look on the device. So I'm going to close my old project, and also I'm going to delete this text view. First, we can start to design our application. So if you look at this application, there is an edit text to edit items, and there's a button next to the text view. And there's also a list view to show the list. And when we click on the Add button, the item is added to the list view. I'm going to delete this constraint layout and write it as a linear layout. Also, I'll define vertical orientation of this linear layout. I will add linear layout in this linear layout, and this time will be horizontal. So I'm going to add one edit text and one button in this horizontal linear layout. I'll change the layout height of this horizontal layout to wrap content. And I'll change the weight of this edit text. So I'll write 4, and weight will be 1 for the button. So that means that I divided this layout into 5 pieces and gave 4 pieces to the edit text, and then that leaves 1 piece for the button. And I'll also add some space to this layout. So I'm going to go to layout margin and write 5 dp. That means that I left 5 dp of a space from 4 sides of the layout. Okay, so that's okay for now. I will add a list view, and list view will be under the vertical layout. So let's check the IDs of these components. ID of edit text is edit text. ID of button is button. ID of list view can be list. Also, I will change the background color of this layout. I will click background, select color, and select a color. Now I selected this color, but you can use any other color. What's your favorite color? We'll all know now. Okay, so the design's ready. So that means we can go over to the code side. And I'll define these 3 components. I will write edit text item, button add, and list view, list view. Now before I continue, I will delete this text of the edit text, and I'll add a hint to this edit text. Hint will be add new item. Also, I will change the text of this button and write add. Okay, now I can continue. So inside the onCreate method, item equals find view by ID, r.id.editText. Add equals find view by ID, var.id.button, and list view equals find view by ID, r.id.list. Now, after that, I need an array list. So this array list will hold my items. Array list string, item list equals new array list. I'll add my items to the list view from this array list. Also, I need an adapter to connect the array list and list view. So I'm going to write array adapter string array adapter. Okay, you with me so far? So good. So now if I add items from array list to list view using the adapter directly, a problem is going to occur. When I close the application, the list will delete. So I need to save this list, and I'm going to save this list to a file. I will save this file in the device memory. So that means that when I need this list again, I'll just read the file from the device's memory, yeah? So I will create a new class to save the file in the device memory. Let me just right-click the main activity.java file and select new Java class. And we can give a name to this class. Let's call it file helper. I will write saving codes in this class. Now, first, I will create a constant for the file name. I will write public static file string file name equals list info point dat. So this is the file name that I want to save onto the device's memory. So I defined it at the beginning of the class because I will use this name in the code more than once, okay, and more than in one place. So if I write this name wrong, that's going to be a problem. Okay, so after that's complete, I will create a method to write the data to this file. And I will write public static void write data. And this method will take two arguments. The first one is array list. Type of array list will be string. Name of argument of this array list can be item. Second one is context. So I will write context. I will write codes to save the list in this method. And I'll use file output stream class. So this class is used to write data into a file. I will create an object from this class. I'll write file output stream, FOS. FOS is the name of the object. It is an abbreviation of the file output stream. So the file output stream, or FOS, equals context.openFileOutput. And then this method will create a file in the device's memory and open it. So this method, of course, takes two parameters. First one is file name. Second one is mode. File name is file name. Mode will be context.modePrivate. Now, if I select mode private, I can reach this file from everywhere else inside of the application, but other applications will not be able to reach this file. Now, if you do save data to the device's memory, you should lock your file. Otherwise, other applications can read your file. Okay, so do you see this? Underlined in red. So, Android Studio underlined in red this code. Why? Because we need this code to be try-catch block. So I will select surround with try catch. So now I can continue. And after that, I need to use another class. So the name of this class is Object Output Stream. All right, Object Output Stream, OAS, equals new Object Output Stream, and inside the parenthesis, FOS. Now these two classes are used together to write data into a file. So now I need to add a catch method for this as well. So after this, I will write OAS.writeObject item. And with this line, the item will be written into the file. Okay, so now that's done. I need to close this file. So I'm going to write OAS.close. Now, this is important as well. Because I created a file in the device's memory, after that, I can open this file and write data to this file. After that, I need to close this file because if it stays open, some problems can occur. Don't even want to go there. So we need to close the file. So now that the data writing method is ready, now I need a method to read this file. So I will write public static ArrayList string. Name of this method can be read data. And this method will take one argument. It is context. So how will this method read data from the file? So first I will create an array list. I will put data in this array list. I will write array list string item list equals null. And this list will be null at the beginning. After that, I will call file input stream class, and I will create an object from this class, and its name will be FIS. So file input stream, FIS equals context dot open file input. And inside the parenthesis, I will write file name. And I need to take this inside the try catch block as well. And then after that, I will call the object input stream class. Object input stream OIS equals new object input stream FIS. I'll need to add a catch block for this as well. Alrighty then, so now I need to write this read data to the array list. So I will write item list equals OIS dot read object. And I will need to add a catch block for this as well. So now this code will add data to the array list. But my type of array list is string. This method will read data as an object, so I need to convert it to string. So if I select this, Android Studio will do the typecasting automatically. So this method should return item list. So now I can read and write items from the file using these methods. Now I can use these methods in the main activity. First, I'll need to specify something. When the application is first opened, I need to check if there's a file previously saved or not, right? So if there's a saved data in this file, I'll need to take this data and then write it to the array list. After that, the list view can take this data from the array list. So I will write item list equals file helper dot read data. This. So this method will read data and then send it to the array list if there is any data. And then after that, I will send this data using the array adapter. Array adapter equals new array adapter. So the array adapter will take 4 parameters. First one is this. Second one is android.r.layout.simple_list_item1. So this is a default layout for the list view Android Studio uses. Third one is android.r.id.text1. This is also a default. You will need to write this exactly the same if you want a basic list view. And the last one is the name of the array list. It is item list. So now I need to assign this adapter to the list view. I will write list view dot set adapter array adapter. Okay, good. So now the list view is ready. And if there is any saved data from before, it will be written into the list view. Also, I want to add data to the list view when I write in the edit text and click the add button. So I need to add a click listener to the add button in order to accomplish this, right? So I will write add.set on click listener, new view on click listener. First, I'll need to take an item from the edit text and assign it to a string container. String item name equals item dot get text dot to string. Now, second, I need to add this item to the array list. Item list dot add item name. And then third, I want to clear text of the edit text. Item dot set text. Quotation marks. And this will clear the edit text. And fourth, I want to write a new item to the file. If the application is closed, data will be safe in the file. File helper.write data, item list, and get application context. Okay, and so lastly, I will need to notify the adapter to get these changes. Array adapter dot notify data set changed. Now the application is almost ready. So why don't we just run the application to see how everything looks and runs so far? So the application doesn't work. Of course, there's a problem. Do you know what it is? Now, before you stop the video and go back and troubleshooting, I'm just going to show you the problem because you need to think this through. In the File Helper class, we need to add something. So inside the File Not Found exception block, I will write item list equals new array list. So this is necessary for the very first opening of the application. Okay, get it? Yeah. So now I can run the application again. All right, so it looks like the application's working. So this is the first time and the list is empty. And I'm going to want to add some items to the list. So when I click the add button, the items are added to the list view. But the most important thing is if the data will be saved or not when I close the application. So I'll close the application and I'll open it again. So when I open the application again, the data came back. So now I just need to complete one more thing. So when I click an item on the list, I want to delete this item, and I will add item, click listener, to the list view. List view dot set on item click listener, new adapter view dot on item click listener. Inside the on item click method, I will create an alert dialog message. And hopefully you remember that, right? We explained the alert dialog in one of the previous videos. So alert dialog dot builder, alert equals new alert dialog dot builder main activity dot this. And after that, let's give a title to this alert dialog, alert dot set title delete. And then next, I will define the question. Alert dot set message. Message will be, do you want to delete this item from list? And then I will write alert.set cancelable false. So that means if the user clicks somewhere on the screen, the alert dialog will not close. And then next, I'll define the negative button and add a click listener to this button. Alert.set negative button, no, new dialog interface dot on click listener. And then that way, if the user clicks no, I will write here what will happen. Dialog dot cancel. If the user clicks no, alert dialog will close. So now after that, I will define the positive button and add a click listener to this button as well. Alert dialog dot set positive button, yes. New dialog interface dot on click listener. If the user clicks yes, I will write here what will happen as well. So if the user clicks yes, first the item that the user clicked on will delete from the array list. Item list dot remove position. And this will take the position user clicked and delete the item from the array list at that position. Second, list view need to renew. We can do this by notifying the adapter. Array adapter dot notify data set changed. Third, I need to write this new array list to the file. Because if the application is closed, we don't want to lose the data. File helper dot write data item list get application context. Lastly, we will need to finish the alert dialog, create code. Alert dialog equals alert dot create. Alert dialog dot show. Yes, now everything is ready and we can run the application. So look at that, the application's working, and when I click on an item in the list, it shows me an alert dialog. Do you want to delete this item from the list? If I click yes, it deletes the item. If I click no, alert dialog closes. So let's check to see if it will save the last version of the list or not. So I'm going to close the application, open it up again, and sure enough, it saved the list and it brought the list back. So it looks like our application's ready. But before we finish this video, I do want to show you how to change the logo of this particular application. So I'll need a picture for this. Now, I prepared a picture from before, so don't laugh. I just didn't want to do it in front of you to waste your time. I know that you've got plenty of things, but all I'm going to do is copy this picture and paste it in the drawable folder. And just like that, the picture's in the project. So after that, I will open the manifest file. And in the manifest file, there's a code line, Android icon. So I'll just delete this and write drawable picture. So now the logo is ready. And I will run the application again. And what do you know? The logo is added. Now, I know you can improve this project. I hope you do, with all sorts of creative, wonderful things. You can add some extra functions to the project as well if you want. You can change the design. You can support multiple languages. You can support multiple screen sizes. All of that is up to you, and it's your responsibility because you know how to do it right. So we finish our first project in this video. Next video, we will learn how to create an APK file from this project and then publish this APK file to Google Play. That's coming up in the next videos. So I will see you in the next one. APK release version. Hello, everyone. So we're going to speak about the APK release version in this video. On the last one, we finished our application. Our application is ready to publish. You know, you probably tinkered around with it. I'm glad you did. But before we publish our application to Google Play, we need to learn something about the application release version. So it is an important part because your application will be published according to this APK release version. So in this part, there are two parameters. The first one is version code, and the second one is version name. Version code is a positive integer value that starts from 1 to this number. And this is, of course, an important value because when you publish your application on Google Play will take this number as a reference code. So when you update your application, Google Play will check this number. Now, it has to be a bigger number from the previous version. So, for example, if you define this value as 1, first time you publish it, you will have to define at least 2 when you update your application. So, every update, you will need to increase this number. So, if you give a smaller value to the update, Google Play will not accept your application as an updated version, right? So, version code is, well, exactly as stated for Google Play. Version name is a string value that we will show to the users. So when you update your application, users will see this value and they will know which version of the application that they will be using. For example, you define this value in the first time you published it, right? Version, let's call it 1.0. And when you update your application, you can define this number, version 2.0. So when the users see the update in their device, they will know that this is version 2.0. And then they can decide to update the application or not. Now, in every update, you can define a new string for this value. This value is not important for Google Play. This is between you and the users. That's the difference, right? So why don't we go ahead to Android Studio and see how to make these changes. So if we have a project in Android Studio, we will see how to define these values for this project. So you see here, there is a Gradle scripts section. Now under this section, there is build Gradle module app file. And I'm going to open this file. And in this file, you can see the previous version code and version name. Version code is an integer value and 1. If we generate APK file using this number 1 and publish it to Google Play will remember this number. So when you update your application, Google Play will check this number, and if it is the same or smaller from the previous number, Google Play will not accept your updated APK file. So this is the version name, and it's a string value. It is written between the quotation marks. So now it's 1.0. So when we publish this application, that's what the users see, this value. And when we update this application, users will see the new value that we've changed it to. Okay, so that's about that. How do we change the values? That's what you want to know. So check it out. If I delete this number and write in a different number, a Sync Now button appears. So when I click this button, Android Studio will change this number. That's pretty cool. So we learned how to change the APK version in this video. See you in the next one. Building APK files. All right, so hello everyone. We will learn how to generate a signed APK file. We need a signed APK file if we want to upload and publish to Google Play, right? So let's go to Android Studio and see how to do it. So, of course, we finished our project in Android Studio, and in that last video, we mentioned the version code. So now we just need to create an APK file so that we can publish it to Google Play. And I'll just go to the Build menu and click Generate Signed APK Bundle. When I click it, a new window opens. So in this window, there are two options. First one is Android App Bundle, and the second one is APK file. So the Android App Bundle is a new version of Android APK. If you use Bundle, your APK file size can be smaller, but it only works on Google Play. So it's a new feature. If you want to use it, of course you can use it. If you want to learn more about it, you can just search for it on the internet. The procedure is the same. So, all right, I'll show you the bundle first. I will select Bundle and click Next. And in the next section, first you just need to select the key store path. And this is a password file. First, you will create this file and save it on your computer. And then when you create an APK file, you will select it from your computer. And I'll show you how to create this file in the next video. So I'll click, choose existing, and select this file from my computer because I've created this file before, as I just said. And then after that, I just write the password of the file, define the password when I created this file, hang in there. So this is the first section. When we create an APK file, there are two password sections. The first one is for all of the applications. It's a password file that I will show you how to create in the next video. But the second one is special for every application's APK file. For this application, I will create a new one. And I will just click here and select Create a New Key. And I need to give it a name, right? Give a name to this password key. So I'll name well, it'll just be to-do list project. Now, after that, I will need to define a password for this key. Now, this is very important. If you forget this password, you will not update your application in Google Play again. Because when you upload an updated APK, Google Play will check its password. If it's not the same, Google Play will not accept your APK file. So I advise you to write this password somewhere. Keep it safe. And just in case you're wondering, this password is valid for 25 years. Just so you know. So now I need to write some information here. At least I need to fill in one space and click OK. So now I have a to-do list project key and its password. Now you can check, remember password. If you check this checkbox, it will remember your password for creating an APK file. Again, this password is very important. I have a password file with its password and a password key with its password. Okay, so now click Next. And now there are two options, debug and release. So debug, of course, is for testing your APK. Not going to use it right now, so I'm going to select release. Now in here, we can choose where to save the generated APK file. And I'm going to choose a file, and we have a folder named To-Do List Project. So in this folder, there's an app folder, and in the app folder, there is a build folder. And I will create a new folder in the build folder. Its name will be Release. Android Studio will save this APK file in this release folder. So if I click Finish, Android Studio will create this APK file. But before clicking Finish, I want to go back to the top. So if I select APK section and not the bundle, what will happen? If you create an APK file, you can publish it in other platforms as well. For example, the Amazon Marketplace, or there are some APK sites. People download from these sites all the time, and they download APK files. Android devices can take AP files from the outside as well, not just from Google Play. So I will select APK and click Next. And this part is the same, so I'll click Next. And this part is also the same, so I will click and select Release. So the difference here is in these checkboxes. So I will check two of them and click Finish. So now Android Studio is producing an APK file. Android Studio will write all of the features in this APK file. So this can take some time according to your computer speed and the size of the file. But for now, mine is finished. Android Studio generated an APK file. So let's look at this file in the folder. It's under the C, Users, Android Studio Projects, To-Do List Project, App, and Release folder. And this is the APK file. So now I can publish this APK file on Google Play. So what do you think? We learned how to create the APK file in this video. But stay tuned. We've got some more info in the next video. Signing the APK file. Hello, everyone. We will learn how to sign your APK file with an encrypted file and how to create this encrypted file in this particular video. So let's go to Android Studio and see it in practice. Of course, we learned how to create an APK file. So I will click Build, generate sign APK. Then I will select APK or app bundle and click next. Okay, so here we will create a new password file. Now in the previous video, I used the password file that I created before. So this time I do want to create a new one. And I will click Create New. So first we need to define where we will save this file. So this is an encrypted file, and you will need to save this on your computer. I mean, it's not just a keyword and a password, right? So this is a JKS extension file. So where you save this file is so very important, because if you delete this file, or it's deleted by accident or some other happenstance, you will not be able to update your application again. Even if you create a new file, it will not be useful. You will create this file just one time, and you can use this file for all of your applications. So I will advise you, you should be able to save this file in the cloud, at least in 3 places. Because if your computer has a problem, it will not update your application again, right? So keep it safe. So here I will select a folder and I will give it a name. Let's call this, the name can be password example. So you can, give it whatever name you want. So then I'm going to create a password. Now this, of course, is important as well, because if you forget the password, there is no reset password option. So this alias section is the second part, and you will create this password key and the password for this APK file. So when you create another APK file, you will create this second part again, because the second part, the password key and the password, are different for every application. So I will write to-do list for the key, and I will write a password for this key. And this password is valid for 25 years. And also, I'm going to fill in at least one space and click OK. Now, the password.jsk file is ready. Now, I've also defined a password for this file. Key alias is to-do list. And there's another password for this alias part. And the second part is different for every application. So after that, when I click Next, it will continue. Okay, so now we have come to another yet very so important part. You'll create this file just one time, and you can use this file for every application. So this is an encrypted file. Now, I want to show this file to you. I will open the Save folder, and here's the file. Now, you can take this file from here and save it to another folder, or you can send this file to your drive, but keep it safe. And remember. So we have learned how to sign your APK file in this video. I want to see you in the next video. Google Play Developer Account. Hello, everyone. We will learn how to open a Google Play Developer account if you don't have one already. You will use this account to publish your application on Google Play. You will need to open an account in this platform. So after that, you can publish your application APK file on Google Play. So first, we will open Google Chrome. Second, you will need a Gmail account. If you don't have a Gmail account, where have you been? You will need to create one. Then you just sign in with your Gmail account. The Gmail account, of course, is vital these days because you will use this Gmail account everywhere. If you publish a paid application, for instance, you will receive your money from Google Play using this Gmail account. Or if you add Google Ads into your applications, you will get your advertising revenue with this Gmail account. So you will use this Gmail account everywhere. All right, so I signed in with a Gmail account, and then I'll write Google Developer Account on Google. And then I'll click on this link. So this link will open the Google Developer Account page. And I'll click on the Sign In button. So after that, this page opens, and there are 4 steps. And now we will accept the developer agreement. You should read the agreement and check the Accept checkbox. So after that, you can click Continue Payment button. Now, the developer fee is €25, and you will pay this fee just one time. It's not an annual or a monthly fee, and you can publish as much as you want and as many applications as you need to, as you want to, using this particular account. So when you click on Continue to Payment button, this credit card page will open, and you can write your credit card details in here. I'm not going to continue on from here because I already have an account. I've already paid my fee, so I will use that account after this, but I did want to show it to you for that reason. So after you have created your account, you can sign in with your account and get to this page and go from here. So that's how to open a Google Developer account. And we will publish our application in the next video. So I hope to see you there. Release your application. Hello, everyone. We will learn right now how to publish your application on Google Play in this video. So as a result of some pretty great efforts, right? I mean, you really need to pat yourself on the back. You've made it this far. You've got a great application. You can publish your application on Google Play. You can be a registered developer for Android. So we opened the Google Developer account in the previous video. So now I will go to the Google Play Developer page. So this is the Google Play Developer account. Your account page will look like this, except you will not see this application information because you've not published anything yet. So I published 7 applications, and this is information about my applications. So after you created your developer account, you will see this Google Play console page. And there are some menu options here, such as all applications, game service, download report, and so on. And I'll click on Create Application button, and it will open this page. Default language, English. Now you can also support other languages on this page as well. So then you need to give a title to your application here. And what will I do? I'll write to-do list and click on the Create button. And then this page will open. So first you will need to write a brief explanation of your application in this section. When users will be searching for applications on Google Play, they will see your application title as well as this explanation. And I'll write some explanation here. You can write whatever you like. You can even have written it beforehand and just copy and paste it here. So after that, you're going to write a full description of your application. So that means that when the users want to learn more information before they download your application, they will read this explanation. You know how it works. You've been there. So now you need to add an icon of your application. So this icon size has to be 512 by 512 pixels. And this is the icon that the users will see, title and brief explanation on Google Play the first time with your application. Now, I've already prepared an icon before, so I will add this icon and continue. After you load your icon, you can see what it will look like on Google Play. All right, so in this section, you will need to add screenshots of your application. Now, you have to add at least 2 screenshot photos. If you have tablet screenshots, you can add them as well. If you develop for other devices, you can use those screenshots too. Now, I've prepared 2 screenshots for this. I will select these 2 photos and add them here. And then after that, you need to bring a big size photo of your application here. So this is also a necessary field. This photo size has to be 1024 by 500 pixels. And I've already prepared this photo, so I'm going to add this photo. Now, I'm using the same photo every time. You don't have to use the same photo. Also, I changed the size of the photo every time, and it, of course, doesn't look that good in the photo, but you really should use some really good images, of course, and the exact sizes for your applications, because this part is also about marketing your application. I'm just showing you how to do it, not an example of aesthetics. All right, so I added this photo too. Now, if you want, you can add an introduction video, some gameplay or something, whatever. Of course, this to-do list is not a game, but you know what I mean. First, you will upload your video on YouTube, and then you can just write in its link or copy and paste it here. So that way people can watch this video right here on this page. Okay, so after this is complete, you will need to select the type of your application. And of course, there are 2 options, games and applications. You can choose one of them according to the type of your application. Of course, I will select the applications option. So now you need to select a category. So you can select one of them, and I will select lifestyle, I guess. Now, if you have a website for your particular application, you can write its address here. And you will need to write a mail address here. It's also a necessary part so that the users will see this email address and can send you email about your application using this address. You can use a particular or special email address in this part. It's up to you. And you can write a phone number in this field. This one is not necessary, but this part is important. So you need to prepare a privacy policy and publish it on the web. After that, you need to write its address in this field, and you can do that using Google Drive. So the privacy policy can change according to your application. You can prepare this with a lawyer, but also you can read the user data policy section and prepare it yourself. So for now, I will check not submitting a privacy policy URL at the current time section. Okay, so now this part is ready, so I'll click on Save Draft. So this is the first part. The store listing is checked. we need to finish these 3 parts to publish our application. So to continue, we will need to upload an APK file. And I will click APK Release section. And of course, it gives us some options here. You can release an alpha or beta version of your application. And then after you publish these versions, you can publish the production APK file. We will publish production APK directly. We will click on the Manage button. Then I will click on the Release button. And then I will click on the Continue button. And now I can upload the APK file into this section. And I'll just click Browse File and find APK. And now it's uploading. Now, it did not upload the file. Why? Because Google Play does not accept com.example package name. So we need to change the package name. So I did this because I want to show you how to change the package name and why it's important. So now you know why it's important. So let's go to Android Studio. And you can see here the package name. So I'm going to change it. And I will click Android section and select Project Source File. And you can see the package name under the source folder. So I'm going to change example folder name, and I will right click on the example folder and select Refactor, Rename. Then I will click on Rename Package button and change package name. I'll write company as a package name. You can write whatever you want. And I'll click on the Refactor button. Okay, then I'll click on the Refactor button again. And now the package name is changed. And then I will change its name from the Gradle file and click the Sync Now button. I can rebuild the project again. Now, if you do this part, you won't have a problem in the next part. After that, I need to create a signed APK file again. And of course, you know the process. So I don't have to explain this part right now, right? And everything is the same. And then after Android Studio finishes the build, I will go back to Google Play Console again. And I'll click on Upload Another APK File button. And then I will click on the Browse File button, select New APK File. And now you can see that it is uploading the APK file. Excellent. So the APK file has uploaded successfully. Now, if you notice here, it gave the 1.0 code automatically. So if you want, you can change this code. You can write something about new features of your application. I'm not going to write anything here. And then I will click on the Save button, and then I'll click on the Review button. And you can see here, Start Rollout, the production button is not clickable because we have to finish these sections. So I'll click on Content Rating. And you have to write an email address here. And you do have to confirm it. Not just anybody can get through these steps, right? So after that, you need to select your app category. I will select the entertainment category. And you need to read these explanations and select your application category according to these explanations. So after that, you need to explain and answer some of these questions about your application. You'll need to answer honestly these questions because it will rate your application, and then people will be able to download your application according to this rating. So if you answer these questions without being honest, you will be punished. Won't get into that now, but just know there are consequences. So you can read these questions carefully and answer as honestly as you can. And then you can click on Save Questionnaire, and it will save your answers. Now, click on the Calculate Rating button. And my application rating is Peggy 3. I will click on Apply Rating, and now the content rating is checked. So after that, I will go to the app content section. And to continue on to this section, I will need to finish the pricing and distribution section. I'll first go to the pricing section. And first I have to select the application type. Is my application free or is it paid? This is important because if you select the free option, you will never be able to change it. I'm going to select free. And then you will choose in which countries you want your application to be published. And I'm just going to select all of the countries because I want to publish my application to the entire planet. And then I will select whether the application contains ads or not. And I'm going to select no. Now, if you want to add ads, you can change this option later. So after this, it's optional. And you can read and select some options. And now I'm going to click on the Save Draft button. Now, there are some missing points, and I will check them and then click the Save Draft button again. All right, so now pricing and distribution gone through. They're all checked. After that, I'm going to go to the app content section, and I will select target age group in this section. And if you select the under 13 age group, you have to add a privacy policy. So I'll check above the age of 18 and then click on the next button. After that, you'll need to decide whether your application will be shown to children or not. So you need to read this part very carefully and click according to your particular answer. Right now, I'm just going to click no and then click on the next button. And now you can review your answers and click the submit. So now the app content section is ready. And I can go to the app release section. And I will click on Edit Release. Then I'll click on the Review button. Now it's time to celebrate. So after you click this button, your application will be published to Google Play and people around the world will be able to download it. So that's how you publish applications on Google Play. I've got some great stuff coming up in the next video, so I want to see you there. All right, so first of all, we're going to learn Git. So what is Git? Why do we need it? So Git is a distributed version control system. So basically, it's a system that's going to record changes to our files over time. And we can recall any specific version of those files at any given time, and that in itself is going to save a lot of time. It also allows many people to easily collaborate on a project, and that way they can all have their own version of that project on their computer to work in on their own time. Now, let me just explain why we're using it. And I'll give you a short example. So just imagine that you have started doing a website for a client. And one of your clients sent you a website design, and they wanted you to code it. Then you created a project on your computer, built the web app, and send in the website link to the client, right? And the client gets a link, looks at that, and then at some point in time, he sends you back an email and says, you know what, I don't like that the sidebar is pink. Maybe we could change the sidebar theme to red, let's say. And then you say, okay. And then you did all the changes, and you reloaded all the files, and you changed everything that they wanted to, and you send it back with a link. And then at some point in time, let's say they don't like the header or some other part of the project. And then they say, well, you know what? We need to take this over here, move that over there, and change the header, and so on and so forth. So you'll do those changes, you'll reload them, send those changes back, and then a few days later, they'll get back to you, and back and forth, back and forth, back and forth. And they would say, we're really sorry, but we think that the original design is what we want. I don't know if that ever happens to you, but it happens all the time. So as a professional, you will remove all the changes that you did, revert back to the original design, and then reload the project, and then send the link back. Now, at some point in time, this process would get a little bit frustrating and sometimes even boring, and you're going to lose that sort of will and foresight to make all the changes in your project folder. So at that point in time, version control, or maintaining a version control system, makes this process very easy to manage. So it's thanks to a version control system that we can make different versions of folders if we like. So we will create the initial website, and the client always comes back and says, yeah, I want to change this and that, so what are we going to do? Then you duplicate that folder into one that's called version 2. And then just make the changes in there and then upload that. Then if you want to do another change, create version 3, version 4, etc. So then in that way, if they ever say, oh, you know what, sorry, let's go back to version 2 or version 1, you don't have to recode anything at all. All you have to do is reload the version that they want now. So that's only one of the advantages of Git. Okay, so some of the other advantages of version control systems are you don't have to store all the versions of a project on your local computer. Yeah, that could be messy. It's going to eat up a lot of space on your hard drive, so wouldn't it be better just using Git? Git allows you to store all versions of projects in just one directory. So you're going to have the version history, and then you could always use any version that you want to, whichever one suits the project at the time. So, of course, that's really awesome. Now, sure, it's going to save you a lot of time. It will also allow you to work on new features without messing up that main version by the help of something that we call branch, which we'll touch on and learn about a little deeper later on. But another one of the most important benefits of Git is it will easily allow you to collaborate with other developers if you're working in a team. So we can collaborate with other developers and work as a team just to sync up the code to GitHub. Now, another topic that we're going to learn is GitHub. So GitHub is indeed an online service that hosts our projects so that we can more easily share code with other developers on our team or others who want to be on our team. Now, those developers can download the projects, work on them on their different machines, and we can all reload our edits, and then merge them into the main code base. All right, so now Git and GitHub are great tools used by many developers. But now you don't really need to know anything before you start this course. That's just a short introduction to Git and GitHub. So in the next tutorial, we are going to set it up on our computer. All right, so we'll take a short break here and we'll come back in the next lesson. Hello, my friends. So in this video, we are going to learn how to install Git on our computer. Okay, but before we start using Git on our computer, we have first got to install it. Now, that's really easy to do, and I'm going to show you just how easy it is. So the first way is to go to the Git website. So just follow this link in here, and then down below, click on one of these links here, depending on your operating system. And then you can just follow the installation process. So I'm just going to click Mac OS because I am on Mac OS. Okay, so in here it says we can install Git with Homebrew. So first of all, if Homebrew is not installed on your computer for whatever reason, why don't you just install it just by clicking on this link? And after you have it on your computer, you run this brew install git command in your terminal. All right, so that's going to download it to your computer. So then once you have downloaded Git and you open up your command line tool, just check to see that you've got Git installed. Now, all you need to do is say Git, then --version, then press enter. Now, if you're seeing a number like this, it means that you have successfully installed Git. So the next thing that I want to show you is set up a couple of options for Git here, and that is username, user email. Now, I want to do this because when we start making changes in Git, Git is going to want to know who is making these changes. And that's one of the ways that we keep track of changes. So let's add in our username. Now, first of all, I'm going to say git config and --global. Because we're setting this in a global, and then I'm going to say user.name. So I'm going to be calling myself Alex, just like this. And then I also want to use the email, so we'll say git config --global. And this time it's going to be user.email, and I'm going to say alex@tech.co. Like so. All right, so now we've set up our username and email, and if at any point in time you wanted to see just what you registered as, you can always say git config, then user.name. And then you're going to see username. And for the email, we're going to say git config and then user.email. Just like so. All right, so the next thing that I want to show you is just a few basic command line commands, because we're going to be using some of those commands throughout this course. So if you've ever used it before, just feel free to watch along with this part. If you are familiar with these commands, you can always skip this part as well. Just go on to the next lesson. But, you never know what you might know or not know. So you might learn something. All right, so first of all, I'll just show you how to change directories. Okay, so we can say cd, then .. to go up one directory. And by the way, don't forget to put a space between C, D, and .. So this is going to take you up one directory. So we can see that we've gone from being in Git and GitHub to desktop. So if I want to go back to the Git and GitHub directory again, I'll just say cd, That stands for change directory, by the way. And then just say git and GitHub, which is the directory that I want to go to. So I'll go to CD again, and this time I am going to go to Docs. All right, so now we are here in the Docs folder. And if we want to list the contents of the Docs folder, we can say ls. That's going to list everything inside it. Or if you're using Windows, dir, and that does a similar thing. All right, so you're looking at everything that's inside this directory. So if you want to do cd into another directory, I could do that because I'm just looking at this list of different directories. Okay, so if we want to make a new directory, we can do that by saying mk to make a dir for directory. And I'm going to do, I'm going to call this test. So this is going to make a directory called test within my current directory. So I'm going to use ls to list out the directories again. And now I can see that test is right here. Okay, so let's go into that directory, cd test. Then in here, we can make a new file. Now, if you're using a Mac, you can say touch. If you're using Windows, you can't do this. On Windows, you can use the echo command. But because now I'm on Mac OS, I'm going to say touch, and then we name the file. So I'm going to call this index.html. And it's going to create an index.html file inside the directory called test. Now, if I'm going to say ls, we can see the index.html in here. Okay, so to delete a file, I can say rm, and that basically means remove. It stands for remove. And I'm going to remove index.html like so. Now, if I type ls, we won't be seeing that file anymore because it's been deleted. Terrific. Okay, so now I'm going to go up a directory, and this time I want to delete the test directory. So I can do rmdir. So I'll remove the directory, and that's going to remove test. So let's type ls to list our documents. Test is gone. All right, so that's just a basic overview of some of the different commands that we will be using in this series. Again, they're basic commands in the command line, and once you got them, they're very easy to remember. All right, so we've got Git installed, and in the next lesson, we're going to go ahead and start using it. So we'll pause here if you need to, and we'll come back in the next lesson. All right, my friends, so in this video, we're going to discuss how Git works. So before we start using Git, I want to explain the very basics of how Git works. All right, so the main thing we need to know about Git is repositories, okay? And you call it repo in short, or repos. So repos are containers for projects that you want to track with Git. For example, you could have a repo which is an iOS project, and it's going to track that mobile app project for you, okay? So a repository can be local, which is stored on your computer, or remote, which is stored on some kind of online service, like GitHub. So we're going to cover remotes a bit later on, but for now we're going to focus on local repositories. So we can have as many repos on our computers as we want to for as many different projects as we want to be involved in. But see, one of the cool things is all of these different repos and projects are going to be tracked independently by Git. So basically, Git repo is a project folder in which Git is going to track the contents for us. For example, let's say we might have a folder on a computer called My Project, or whatever your project's called, and this project is going to be a repository folder, and this repository is being tracked by this .git file. This .git file says that this is a repository right here, right? Because this is at the root level of this project, it means that Git is going to track the changes to any file in this folder, even files and subfolders. So if this .git file was not in the root, but instead in this image folder, let's say, it would only track the changes of this image folder. So it wouldn't be a repository. So now this project file is at the root and the whole thing is a repository. And it's going to track changes to every single file. So if we change this index.js file or image.png file, Git will recognize that and track all those changes. All right. Okay, so let me show you another thing that we'll need to know about Git, and that is called commits. So commits are a bit like save points, right? When you're playing a game, you can create some save points for your projects, save your files at those points, and at some point in time, if you need to, you can always go back to that point and see the saved version of those files at that save point. Now you can create as many different save files and then return to different save files that you want to at any given point. Commits are a little bit like that in, well, just simplistically in the most basic form. For instance, let's say we have 3 commits right here. So for example, we're starting a project and we're going to build HTML for our project. So at one point we finish a header. Okay, and we say, all right, this is the logical point to create a commit or save point. So we're going to commit our code and files at that particular time to the commit history. So you can think of commit, which we implemented the header of the page right here. You can think of this as some kind of save point. So then right after that, we might start on a cider of the page and finish that. And right after that, we'll say, yeah, this is another logical save point. And that way we can track the project progress. So here's another commit. We'll make it after finishing the cider of the project. And, you know, it just goes on, so on and so forth. So you just have to remember that. So these are all different commits in the commit history within our repository. So we have 4 commits in here right now. So the best thing is if we want to go back to the 3rd commit or the 2nd commit, we can go back to one of these save points and see what the code is like here. And guess what? You can do all that just by using Git. We can roll back the code to any different commit in it, right here in this commit history. So it's tracking our different revisions of the code as we go along and as we remember to commit. So by working with Git, it's kind of hard for us to lose our progress and our work because we can always go back and see where we've come from, all the project's progress bit by bit. All right, now, before creating a repo, I want to talk about these 3 different stages here. Okay, so we've got our project folder right here, and we want to make some changes. So let's say we have changed the index.js file. Right, then so those changes are going to go into the modified stage right here. Now they're modified, but they're not ready for committing yet. So we don't know whether we want to commit these files and create these save points or not. If we decide to commit, what we can do is we can add this file into the staging area. So that means we are saying to Git that we want to commit the changes in index.js file, and we want those to be included in the commit. So for instance, we're in the modified stage, and we want to change both of these files, and we want to stage these. We want to add them to the staging area. Then both of those files are in the staging area. So when we create a commit, those files, those changes are going to be committed, and then a snapshot of those files going to be added into the commit history. All right, so that's pretty much how Git works in repositories. So that means that these stick right here, okay? That the commits are, well, all the commits that are on this right here, that's why we call it a branch. So when we begin a repository in the most basic form, we have one branch, which is the master branch. So then in the next lessons, we're going to talk about creating additional branches and why that's important. We're going to create different branches from the master and then merge back later on. Okay, you'll see why that's important. So that means we can work on our new features without altering the master branch code. So yeah, we're going to cover all of that a little bit later, but that's pretty much the basics of how Git works. And we will pause right here and we'll come back in the next lesson. Hello, friends. So in this video, we're going to create our first repository. So now we have installed Git on our computer. And that means we'll need to open command line interface. I'm just using terminal for macOS. So, well, this is iTerm actually. You can use a different terminal replacement like iTerm or terminal that's already there by default. You can use Git Bash for Windows, whatever you want. But basically it needs to be a CLI. Okay, so we do need to open a text editor though. So I'm just going to use VS Code for my text editor. Of course, you can use whatever text editor you want, like Sublime, Atom, whatever you're comfortable with. We're not going to use any particular feature of any particular text editor, so that's why it's just up to you. But here you can see I've created two directories, one called Project 1 and one called Project 2, okay? So now I'm going to create a repository in each one of these directories. So first of all, I'm going to create a repo for Project 1. Now, the first thing that we'll need to do is navigate into the Project 1 directory where we want to create a repository in our command line. So I'm going to say cd desktop, switch on desktop directory, and then cd git and GitHub. Then inside the Git and GitHub folder, I'm going to open Project 1. And because I've created Project 1 under the Git and GitHub folder on my desktop, this is where I want to create this repository. So how do we go about doing that? Okay, to create a repo, all we need to do is say git init, which of course stands for initialize, hit enter. And that's going to initialize an empty Git repository inside this project. Okay, so now we can see this .git folder. We can expand it, and you'll see all of these different things inside here now. I'm not going to go into detail about what all these files are because you don't really need to know what all these files are inside the Git folder yet. But yeah, we'll do some advanced stuff in another tutorial. But for now, all you need to know is that it's here. This Git folder has all kinds of great stuff in it. All right, so this is our Git repository with this .git folder. So it's going to be tracking any kind of changes that we make inside this project folder. This .git folder is generally hidden unless you change your default settings. So to see hidden files and folders, in case now you're wondering, just open your project directory and follow these keys, Command-Shift and dot. Okay, so press these at the same time and it will show you the hidden files on macOS. On the other hand, you can see hidden files and folders just by typing ls-al, and this will show you all the files and folders. Okay, then inside this directory, let's create index.html. So I'm going to say touch index.html. And by the way, this touch command, it's only working if you're on a Mac or Linux. It's not going to work in Windows. You will have to create that manually if you're running Windows command line interfaces. Okay, so as we see all these index files are green. So normally when we're not in a repo, this is just going to be gray. But we are in a Git repository. VS Code recognizes this index file is a new file that wasn't there before. So it changes file to green, and that's just to let us know that some new kind of change has been made. So I'm just going to create HTML file for now and save it. Okay, so you can create all your files inside your project directory and Git will recognize it and keep track of it. Of course, you may create a Git repo from scratch, or your project folder doesn't have to be empty for you to create a repository. We could create a repository in a folder which just contains subfolders and documents. Like this one. Inside project 2, we have 2 documents. So this already has an index file and a styes.css file. So if we wanted to create a repository in here, we just do the same thing. So I'm going to say cd ... to go up one directory, and this time I'm going to say cd project 2. So now we're in project 2. So inside here we can say the same thing, git init, to initialize a repository. All right, so now this is a Git repository. So now we can see these documents are being tracked as well. So we have now created a repository from scratch and a repository in an existing project directory, which already has a few files. So in the next tutorial, we're going to start editing files and then adding them to a staging area, which you may remember my mentioning in the last tutorial. So we're going to take a break here, come back in the next one, and carry on. Hello, friends. So in this video, we're going to talk about staging files. All right. So in the last tutorial, we created our first repo. Inside that repo, we created a new file, index.html file, if you remember. And then we added some HTML template to it. Okay, so one of the best things about this VS Code text editor that I'm using is that it highlights that index file in green to say that we've changed this file, and it's telling me that Git is aware of that. But that doesn't mean that we've committed it yet. So if we see any green files in our project tree on here, well, it means that we have changed them or modified them, but they have not yet been committed. All right, so it looks like that we've changed the index HTML file, but have not committed it. So it's now right here in this modified zone. All right, so if we create a commit right now, it would not commit anything. Why? Well, because when we commit something, Git takes everything from the staging area and creates a commit from that. But see, all we've done here is modify a file, and we've not added it to the staging area yet. Okay, we don't have anything that's actually ready for a commit. So why don't we get into it, see how to do it. So on my terminal, I am in this Project One directory right here. And I'm also in the Project One directory in my code editor over here. And I've got the index.html file that was added in the last tutorial. As you can see, it's green right now, which means that Git is indeed aware that we've changed this file, but it's just not been committed yet. So if we want to make a commit now, it's not going to commit because we haven't added it to the staging area. So let's do it. So now I'm going to show you command here, which is going to show you which files are currently in the staging area and waiting to be committed. The command is git status. So if we type that, it's going to show us which files we have changed and which files are in the staging area. Okay, so now it says the untracked files in here, this index.html file is untracked file, and it's red, which means we've changed it, but it's not been staged yet. Okay, so you see that difference. Cool. So if we want to stage this file to make it ready for committing, all we need to do is say git and then add, then the name of the file, which is index.html, and then see how that's going to add this file to the staging area. So now if I say git status, we're going to see this file again, but this time it's in green and it says new file index.html. And in here it says these are the changes to be committed. So now if we say git commit, then it would commit the files here for now, this one particular file. Cool. So sometimes we add files to the staging area which we don't necessarily want to, and we want to remove those files from the staging area. And it says right here that we can use git rm --cache, then the file name to unstage the file. So if we want to remove the index.html file from the staging area, I can say git rm --cached, and then index.html. Now, if I say git status again, we can now see that the index file has been removed from the staging area. All right, so now we need to know how to add files to the staging area, but just imagine that we've got a really big project and we changed maybe 20 or 30 different files. And how do we add all those files to the staging area? All right, well, we could say git add and then type every single file separately. But seriously, who wants to do that? I certainly don't want to do that. And let's say you do, it's going to take a long time. So what's the shortcut? There's got to be a shortcut. If we change so many files and we want to add them all to the staging area, so I'll show you. To add all of them, we can just say git add, then dot. And that's going to add everything to the staging area. That's pretty cool. So let me just demonstrate. I'm going to create a new file over here. I'm going to right-click here and call this file styles.css. All right, so we've created this file, and let's add some styles in here. So I'm going to say body. Inside the body, I'm going to say font size 14 pixels. Okay, so if I save this, and we've got two files in here, and they're both green, which means that we've saved those changes to those files, but they're just not committed yet, right? Changed, not committed. So let's say git status. And we can see that both of these files have changes in them, but they are not added to the staging area. Now we can add both of them to the staging area at the same time just by saying git add dot. So we're saying dot to add every single modified file to the staging area. So then if we say git status, and we can see, see, these two are now added to the staging area. Here they are, both waiting in the staging area. Okay, so they're both ready to be committed right now. So now if we do a commit, it's going to take both of these files and add them to the new commit history, okay? All right, so you might be thinking now, all right, so what's the point of having a git staging area? I mean, why don't you just commit? You know, it seems like it's just adding one too many steps. You know, you could just commit right away when you make your change. Well, why do we have a staging area? Why don't we make commits without even having to add things to a staging area? Well, one of the reasons is by adding all of our changes to a staging area, it allows us to review our changes before we make that commit. You know what the word commit means, basically. But another reason is that we can split our work into 2 separate commits, or 3, or 6, or 12, or whatever. So in other words, imagine that we're managing the application, and there are 2 main issues in it. So let's say I want to fix bugs, and at the same time, I have to change 2 files for each bug. So I might not want to bundle them together in the same commit. So what I could do is stage one of the files and then commit that, and then stage one of the other files and then commit that. You follow? So it'll allow us to split our work into a couple of different commits for different stages. Then in the future, if, let's say I want to change one of the fixes, we may only have to change one commit. All right? So that's pretty much the shape of the staging area. In the next lesson, we're going to learn how to commit these changes in the staging area. All right, my friends. So in the previous lesson, we have learned how to add change files into the staging area. I say learn a little bit more about why that staging area exists. So in this lesson, we're going to start making our commits. All right, so far we have modified index HTML file and style CSS file, and then we staged both of those files. So now it looks like they're ready to be committed. So we are at the stage where we want to take those files, we want to commit them, and add that commit to the commit history down here. So remember, a commit is basically like a save point, and it's a snapshot in time of your code at that particular point in time. So in this tutorial, I'm just going to show you how to make commits. So here we are. I'm still in the same directory, project 1. Okay, so in the previous lesson, what we did was create these 2 files. We added them to the staging area, so they are ready to be committed. And we see that by saying git status. Now for me, they are appearing in green, which means they're ready to be committed. They're ready for their commitment. Okay, so how do we commit these files in? So to commit the stage files, I'm just going to say git commit. Then we say the -m flag. That means that we want to pass in a message, and this message is in double quotes, and this needs to be a descriptive message. So for example, if, let's say you're fixing a bug, you can type something like fix bug in sidebar. All right, is that cool? Follow? So basically you should write something that's descriptive for the commit message, not something, esoteric. You're just going to use them for future reference, all right, to trigger a memory or, one of your collaborators so that they know what exactly it is. So in our case, all we've done is added index HTML and the style.css file. So I'm just going to say add index and styles files as my commit message. And then, as we can see right here, it says that we've made a commit with a message, and this number right here is the ID of that commit. And we've made that commit on the master branch. Yeah, we're going to get into branches a bit later on, but just remember that, like I said, the default branch is the master branch when we create a repository. And this just means that we have made that commit to the master branch. Okay, so we've made this commit, and it's now been added to the commit history. So what I want to do now is just make another couple of commits, and that way we can review the commit history. Well, that way there will be a commit history, all right? So I'm going to add div tag in here. And then inside this tag, I'm going to say hello world. I'll save that now, and it's going to be orange on the left here, which means we've changed it. So sometimes it's shown green in here, and sometimes it's orange. Green means there's a new file, and orange means that you've changed an existing file. But either way, they've been modified, and we'll need to add those to the staging area. Oh, and by the way, you wouldn't make a commit something as small as this, right? I'm just demonstrating how to make several commits. So we'll add this to the staging area, and I'm just going to say git add and then dot. So this dot will add all the files and folders to the staging area. Even though it's just one file, it's just quicker that way. So let's check what's in the staging area by saying git status. Make sure it's green. Okay, so now see the index file is waiting to be committed. So we can now say git commit and then a message. And I will say add text to the index. Cool. So now we've added another commit with this ID on the master branch. And there's been one file change and one insertion and one deletion. We didn't delete anything, but this is just the way that Git works. It's good to communicate that way. So if we change one of the lines right here, we change this one, what Git does is it actually says that we've deleted the line and we added it. So it doesn't see it as a change. So we've deleted a line and we've inserted one. So it's the same thing as being a one-line change. So we have two commits, and I want to do one more. I'm just going to come to the styles.css file, and I will add in a background color right here. I'm going to say background color blue, and I'll save that. Okay, so now I will say git add then dot. So I'm using dot instead of the file name just because it's quicker. So let's say git status again to check, see if it's in the staging area. Okie dokie. Now we can commit. So I'm going to say git commit. And the message is going to be add background color to body. All right, so now we've done these three different commits, and it is committed to the master branch. Now we've got a separate unique ID for each commit. So we've got three commits. We've got three different save points on our master branch in our commit history. So what do we want to do if we want to review this commit history? Well, all you need to do is say git log, and this is going to show us a log of all the different commits that we've made. So each of these yellow lines right here represents a different commit that we made. So it's a very long, unique string of letters and numbers, and they are all different. So this little I right here, these are the first few letters of one of these IDs. So it's kind of like the short version of these IDs, and this is a full version of these IDs. And underneath of that, it says who's made the commit. And I'm sure that's me. And my username, and also my email, the date that it was committed, and the message of the commit. It says exactly what has happened. So when it is committed, it is committed. Now, you're not necessarily going to want to see all of this info all the time. You might just want to see like a short version of it. So if you want to just see the short version of it, you can say git log, then --1 line. And this is going to show you all the different commits in your commit history, and it gets squashed into one line. So we've got the short ID here, and we've got the message. All right. So that is your commit history. We'll take a short break in here, and we'll come back in the next lesson. Hello, friends. So in this video, I want to show you how to undo a commit if you made a mistake. Now, in the previous lesson, we made some commits to our master branch, and we assumed that those commits represent these commits on the screen, right? So we did 3 commits in the previous lesson, and I've added 2 more commits for this lesson to show you how to rewind things or undo things if you make mistakes. So for example, you're right here in the code, you've made these commits, and your boss comes to you and says, can we rewind this? And well, right into about here. It shouldn't be a problem, so I'm just going to show you how to do things like that, and we're going to do these things using 3 different methods. So you can show your boss, hey, yeah, I could do it 3 different ways. So these are the commands here. So check out commit, revert commit, and reset commit. Now the reason I color them like this is because they're kind of in order of danger, all right? So the green one is, well, it's not completely dangerous, and it's usually very safe. It's not going to ruin your commit history. This one, revert commit, it's still considered safe, but not quite as safe as checkout, but it's still very safe. So this one, reset, I would consider that unsafe. And you kind of want to be sure that what you're doing is you really want to basically erase your history before using the reset commit, because it will ruin your it could ruin your repository. How's that? Okay, so let's have a look at the 3 different methods. First of all, checkout commit. So you're at this commit at the code, and your boss says, can we just go back in time? I just want to see what the code was like, for example, at this commit. I don't know who the boss is, but And then you can say, yeah, I can do that. In fact, I can do it 3 different ways. Right now, I just want to do checkout commit so that we can check out this commit. And that's exactly what it is. It's not like you're checking out at the grocery store. So it's going to show you in your text editor the code at this point in time when you made this commit. All right. Now, they're not going to be saved. This is read-only, so I'm not going to be able to destroy the commit history or alter it in any shape or form. So that's why I'm saying that it's really safe. All right. So the second is revert, and it lets us undo a particular commit, right? So we were just checking it earlier. This one is revert. For example, you're here and your boss says, I don't really like this cider. Can you revert that commit? And you say, yeah, I can do that. So revert commit is going to basically put a big X through this commit as though it never happened. It's going to revert the change of this, almost kind of like a delete, but it doesn't really delete. The effects are the same. It's like it never existed, but anyway, we can see how it works later on. But the last one is reset commit. And this is the dangerous one because it's going to permanently take you back in time. I mean, well, not you, but your code, your project, whatever, to a particular commit. So for instance, if you're here and your boss comes in and says, we don't need any of these last 3 commits, can you go back here, and we're never going to use these last 3 commits. We're not going to use them ever again. Well, that means that you can say, sure, and you can use a reset commit to do that. Just as long as you get it in writing that your boss will never use them again. Just kidding, but you know what I mean. So you can reset to this commit, and it's going to be permanently deleted. See, all of these commits and your code is going to go back to how it was at this point in time. All right. So I'm going to show you examples of all 3 different commands here. All right. So I'm still in the project 1 repository. So I'll do a git log to show you those. I'll say git log -- one line. All right. So you can see these 5 commits in total. So one of our new commits is this. I have added a new JavaScript file. The other one is, which I added a heading to the index file right there. All right, so I made those 2 commits. Okay, so now what we're going to do is start rewinding time. So for example, in this commit right here, where we added text to the index file, so we can use the checkout to do that. Sure, boss, I can do that. And the way that we do that is by saying git and then checkout. And then you need to tell git which commit you want to check out. So the way that we do that is by referencing this thing right here, this unique ID. So I'm going to copy that, and I'm just going to paste it down here and hit enter. And it's going to change it and delete up until here, or back until here, I guess. All right, so we've deleted this JavaScript file and heading as well. So we're basically seeing the code like it was in this commit right here, where we just added text to the index file. So any changes that we do here are read-only and not going to alter the commits. So that's why it's good for going back in and seeing the code at any one particular commit. Okay, so once we finish examining the code, we can just go back by saying git checkout master. Master is the branch, and we're going to see branches later on. I told y'all. Now, like we just said, we want to check out the master branch again, because what we did was, we went to the particular commit from the master branch. Now we're reattached to the master branch. That's why I want to talk about all that later. Cool. So we can now see the old code and the JavaScript file right on here. All right, so that's how we go back in time using git checkout. And so the second thing I want to show you is git revert, but I don't want this lesson to be too long, so why don't we take a short break right here, and we'll come back in the next lesson. Hello, friends. So in this video, I want to show you about undoing commit with git revert. It's a great command. Git revert basically undoes one particular commit. So let's do git logs -- one line. See what we got. Okay, so we've got these different commits right now. And let's assume that, again, your boss comes in and says to you, I don't want this JavaScript file and everything inside it right here. I want to undo. No, I don't want that feature here anymore. And you say to him, okay, so, dude, I'm just going to use a git revert to undo them. Okay, so anyway, the way that we do this git revert is just like this. So I'm going to say git revert, and again, we need to say which commit we want to revert, and it's this thing right here. So let's copy and paste it and press enter. All right, so now you get this screen right here, just like a text editor, and it's asking you to give this commit a title because it's making a new commit for us. And I'll show you that in a second. So you can see the changes here to be committed. We're going to delete that index.js file because that was the commit that we want to undo. So what I'm going to do to get out of this screen is press the escape button and semicolon. And we get this little sign here at the bottom. Then press WQ. Poof, it goes out. So as you can see, we've removed that index.js file. Now, if I do a git log and then --1 line, we're going to see that we've not removed that commit. We just added a new commit called revert add new JS file. Yeah? So what this commit has actually done is basically undoing anything that we did in this thing right here. For example, we added the JavaScript file in here. We say we want to revert this commit. Then what it does is it makes a new commit, which reverses it or undoes anything that was made in here. All right, so we still have access to this commit in the history, and it's just reverting it at the top. So that's pretty cool, huh? So that's why it takes us through to the text editor, because it's asking us if we want to add a new message for that particular commit. All right, so that's how we undo one particular commit using git revert. All right, so now, the last thing that I didn't really want to show you, but I do have to show you, is the git reset. So git reset. This is the thing that could potentially, anyway, destroy the contents of your repository. So you need to really approach this like you're approaching a bonfire, or at least put your gloves on or something. So you got to be real careful, in other words, when you want to undo things with git reset. So again, for instance, your boss comes in and says, hey, these last 4 commits right here, we don't need them anymore. You sure? You say. He says, yeah, I'm sure. What I want you to do is go back in time, take the code to this point, and just work from here. All right, well, so you say the way that we do this is say git reset, then which commit we want to reset to. And that is this thing right here. So I'm just going to copy this ID and paste it in here. So if we hit enter, it would take us in here and it would give us a message saying that we've got some unstaged changes in here. So basically we've gone back inside of this commit, but it's not changed our working directory. Everything we did after this is still in here, right? But they're just not committed. So if I do a git log --1 line, then we're not going to see those other commits. You follow? We've only got these 2 commits, but the changes that we made in these commits, they're still in our code editor. Because in case if we change our mind, we could re-add individual files or all of the files and then commit them again. So yeah, I suppose it could be good if you want to kind of take all those commits and put them into one. You can add them all in one commit and just make another commit. But if you want to rewind in time and you don't want to preserve these changes because your boss says, we're never going to use them again. Okay, well, then fine. What you do is press the up button because we can get that command again. So we can cycle through all the commands that we have typed just by pressing the up and down keys. So once we've specified which commit that we want to go to, right after that, we're passing the --hard flag. And what this is going to do is take us back to that particular commit, but this time it's not going to retain any of the changes from the commits in the text editor. All right? So if I click enter, now you're going to see them disappear. Now, we no longer have those things in here. All right, I'm just trying to give you an idea how it goes. So let's reset one more commit. So I'm going to say git log -- one line. I'm going to copy this ID. Just going to remove text that I added to the index file. And if I say git reset, and then the particular commit that I want to go to, and then say -- hard, it's going to take away this hello text in the index file. And I'm going to press enter. And we no longer see the text. Now, if we do a git log -- one line again, we only see that one commit. And then there's no way to get back those commits. They are permanently deleted. That's why I said, just be very careful if you're ever going to use the git reset. Boss, I don't mean to question you, but are you sure we're not going to need these ever again? Never again. Just get rid of them. Okay. Anyway, it could ruin all your files. Delete them all. You might lose hours, days, weeks, months of work, whatever. No big deal. So that's how we undo or get back things and then go back to all of the revisions of code. All right? So now that you've learned how to do that, well, the whole world's your oyster. Not quite yet. In the next lesson, we're going to learn the concept of branches. And that is going to be able to let us work on some new features in our projects without editing the kind of core code base on the master branch. Yeah, that sounds exciting. So we'll take a short break in here, and we'll come back in the next lesson. Hello, friends. So in this video, we're going to learn how to create branches. All right? So branches are one of the greatest features of Git. Love branches. Going to save your life one day. So far, we've only been working on the one branch, and that is, of course, the master branch. So remember, when we create a new repository, what we're doing here is we're creating this master branch as well. When we've been making commits, we've been committing only to this master branch. Now, generally, master branches, it's going to represent the stable version of our code, and normally it's going to be the code which is released or published. So for that reason, we don't try out new features or new code on the master branch just in case it messes the code up, right? So generally, if we want to add a new feature to our application, we're going to create some kind of isolated environment to try out a new feature. And then if we like it, if it's error-free, we can then merge the new feature into the master branch. So that's why it's divided into branches. That's the branch in short, all right? So for instance, if we have some kind of new feature that we want to test out, instead of adding more commits onto this master branch, what we do is we make a new branch, which is already an isolated environment, all ready to test a new feature. So when we make this branch, we're kind of copying the state of the code in here. So we're copying this stable version onto this branch. Then we can work in this branch, make commits, test things out. Then if we're really, really happy with this new feature, then we can merge it back into the master branch. We're going to learn how to merge one branch into another one later on. But for now, when we merge this new branch, let's say, into the master branch, this master branch is updated with a new feature, right? That's how that works. But while we're testing this new branch, if everything goes wrong, for example, we've tested things out and it messes the code up or it doesn't work or something happens, what we can do is we're not going to merge this branch into the master, just delete that branch, and then it's not going to affect the master branch. So this is still going to be stable. It's not touched at all. That's why we use branches. Oh, and another cool thing about branches is if we have two developers working on the same project at the same time, doing two different new features, what we could do is one of us makes a branch to work on one feature, and one of us makes a branch to work on the other feature, then we can both work on the same projects at the same time without affecting each other. Then, let's say after we finish all the features that we're working on, if we're really happy with those new features, then we can merge them onto the master branch. So again, branches allow us to work on different features at the same time with different people. Very cool. So let's go back to the project 1 again. So here we've just got the one commit right now, and I see that if I type git log --1 line, we can see this is just one commit, which is the added index file. So we've added the index file to the master branch, and we're on the master branch right now. So in here, there's a command tool that says which branch we're on. Okay. So let's make some changes on the master branch and commit. So I'm going to create a h1 tag, and inside of it, I'm going to say git and GitHub. Let's save it, commit it. So I'm going to say git add dot. So it's added to the staged area. Then git commit -m, and I'm going to say add title to the index file. Okay, so now we've got 2 commits. So now let's say git log --1 line. Okay, see, we have 2 commits. Okay, so now I want to work on some kind of new feature, but I'm not going to start working on that new feature on the master branch, just in case it messes up the code somehow. So instead, I'm going to create a new branch, and then I'll be able to keep it isolated. Okay, so to create a branch, all we need to do is, I'm going to say git branch, then the name of the branch. So let's just say for now, I'm going to call this branch test. So now we've created this new branch, and if we want to see this branch, I can just say git branch, and then -a. That's going to show all the branches. Okay, so now we can see this test branch and master branch. And as we can see, the master branch is green, and see this asterisk next to it? That means that I'm on this branch. Now, if I want to be on the test branch because I want to work on a new feature on that branch, so I need to check out that branch. Just like we checked out the commit, we can check out a branch to be on that branch. And the way that we do that is by saying git checkout, then the branch name, which is test, like so. Now we've switched to test branch. So if I do a git branch -a, then we're going to see that, okay, see, we're now on the test branch. Okay, so now I can start working on the new feature on the test branch. So I just want to add in a JavaScript file, which I'll call test.js. And I'm going to do a console log, and let's say hello world. So it really doesn't matter. I mean, you can say anything, really. So then if I say git status, we're going to see that we've changed this file. So let's commit this file. And I want to commit this file to the branch. So to do so, let's add first, add it to the staging area. So I'm going to say git add, and then that's going to add it. And we can see that by saying git status. So now it's green, and we can commit it. So let's say git commit -m, and as a message, let's say add test file. Okay, so what we're doing here is we're working on this new branch, and we're creating this new feature on this test branch. It's isolated, it's away from the master branch, and we've not changed the master at all. So how can I demonstrate that to you? Well, I can check out the master branch again. So switch back to it, and to do that, we'll just say git checkout master. So I switch back to the master branch, and you'll notice that JavaScript file is gone because we didn't edit the master branch, and it remains stable. Cool. So let's go back to test the branch again, the test branch. So I'm going to say git checkout test, and there it is, reappeared on the left again. And we can now see that test.js file. So that means we have created a branch and we started working on it. Awesome. So what if things go wrong and we just want to delete that whole branch and hopefully nobody ever sees that? All right, how do you do it? So to do that, I am going to go back to the master branch, and I'm going to say git checkout master. All right, so we're no longer on the test branch. Then we can delete the test branch. The way that we do that is by saying git and then branch dash capital D, then the branch name, which is test. All right, so now it's deleted the test branch. So to prove my point, let's look at the branches again. Git branch A, and it's only going to show the master because we have successfully deleted the test branch. All right, so we created a branch, we deleted a branch. Now I want to show you about working on two branches at the same time. Whoa. So remember, to create a branch, you can just say git branch and then the branch name. Then right after that, we have to check out the branch to switch on that branch. So I want to show you a quicker way to do that. So instead, what you can do is create a new branch. You can just say git checkout, then dash B and the branch name. So I'm going to call this test 1, like so. All right, so now we've created a new branch and we have to check it out as well. So we don't have to perform those two steps separately. See that? Okay, so on this branch, I'm going to create a new file. I will right-click and create a file named test1.js. So let's say console log test1. I'll save it. Now let's add and commit this. So I'm going to say git add, then git commit, and I'll say add test1 file. Now, did you see that? I'm always using the imperative mood in the subject line while writing the commit message. So in here, I've typed add test1 file. Instead of this, you may say added test1 file as a commit message, but using the imperative mood in the subject line is it's a kind of community convention. You know, using it is entirely up to you if you want to be ostracized. No, it's just the way things are done. And of course, you may add your commit message in the most descriptive way that you know how. Or you can choose the imperative mood. All right, so right now we're working on this branch, test1, and let's imagine that another person is working on another feature on, let's call it a test2 branch. Okay, so we'll create that branch. So I'm going to say git checkout master. And we don't see the test1 file anymore, right? Because that feature is in the test1 branch. And person 2 may not even want to see that feature, let alone have to see that feature. We don't ever want to even maybe know that feature exists. You know what? Focus on your own feature. So let's create a new branch for person 2. So I'll say git checkout dash B, then the branch name test2. And let's create a file over here. All right, so now I'm going to create test2.js. So that's my file, just like so. So inside this file, I'm going to say console.log, and it's going to be test2. So now let's save and commit this feature as well. So I'm going to say git add, then git commit, and I'm going to say add test2 file as my commit message. All right, so now you've seen me. We've added these two branches, two people working on one project, same time. Person one is working on some sort of something on test one branch. Person two is working on, well, some sort of something on the test two branch. Neither one of them is going to affect the master branch. And we can see that by saying git checkout master. All right. So now we don't have those test files over here because we didn't touch the master. So we've got two separate branches that are as far away from the master as can be. Two different developers working on their own features, and only when they're happy with what what they've accomplished on their branches, can they then merge their branches onto the master. Okay, so if we'd say git branch -a, then we're going to see all these different branches. So we're currently on the master branch. We've got these two branches, test one and test two. And of course, when they're finished and tested, we can merge all of them onto the master branch. And that's what we're going to learn how to do in the next tutorial. So we'll pause it right here, and we'll come back in the next lesson. Hello, friends. So in this lesson, we're going to learn merging branches and dealing with conflicts as well. Thought I'd throw that in there too. So in the previous lesson, right, we have created a couple of new branches to work on some new features. And that's generally what we do if we are working on new features, because we don't want to really mess up the master branch, which is, well, going to actually be our production code. Okay, so we've made these new branches, and we'll assume that we liked all the new features that we worked on in the new branches, and we want to publish these new features, right? So now we need a way to take that code and merge it back into the master branch. See, so that's the thing that we're going to learn in this tutorial, merging test branches and code that we create into the master branch. All right, so you can tell that I'm still in project one, and that's my repo. So I'm going to say git branch -a to see all my branches. Okay, so we've got three branches, master, test one, and test two, and we're currently on the master branch. So let's check out test one and test two to see what we have in those branches. All right, so I'm going to say git checkout and then test one. And we've got this test1.js file in here. And that's the first branch. And so for the other branch, git checkout test2. And in here, we have this test2 JavaScript file. Cool. So let's assume that we have finished these two features and we're happy with each one. So now I want you to imagine that each feature is being worked on by a different person at the same time, and we're both happy with those features, okay? So that means that they want to merge it back into the master branch so that they can publish their branches and you can publish yours. So to do that, first of all, we've got to be on the branch that we want to merge into. So we want to be on the master branch because that's where we want to merge our test branches into. So I'm going to say git checkout master. Now I'm on the master branch and I want to merge that test one branch into this one. So to do that, I'm going to say git merge. And then the name of the branch that we want to merge, and that is test one. All right, so now we see this message here. Fast forward, one file changed, one insertion. So we've inserted test one, which is the file that's full of the features that we tested in the test one branch. We have merged it into the master branch. And we've taken that test one from the test one branch and we've merged it into this master branch. Now we can see that feature and script right here. Okay, so we've merged that now, and this fast forward basically means that all we're doing is kind of fast forwarding the code and the changes that we've made in the test one branch. Okay, so let's merge the other one. Now we're going to do the same thing. So I'm going to say git merge, and then we want to merge test 2. All right, so this time we have merged test 2 into the master right here. So now the master's up to date with both of these 2 new features, and it doesn't matter that we've worked on them at the same time in different places. You get it. But sometimes you are going to come across something that's known as a conflict when you are merging branches. I'll give you an example of that, you know what, in the next tutorial. So we'll take a break here and we'll come back soon. See you then. Hello, my friends. So in the previous lesson, we updated the master branch with test 1 and test 2. So the master is up to date with both of these 2 features. Boy, people are going to love them. But sometimes you are going to come across something that's known as conflict when you're merging branches. So in this lesson, I want to give you an example of that and what to do. So for instance, let's say that this is the master branch, everything is okay, and the code is working perfectly, and we want to add in a new feature, a new CSS feature, let's say. So let's create a new branch to do that, and I'm going to say git check -b, and I'm going to call this branch test 3. All right, so now we're on this test 3 branch. But before I start work on this, I just want to go back to the master. So to do that, I'm going to say git checkout master. Okay, so let's assume that you're working for a company and your company has decided to make some edits on the master branch. So for example, one of your colleagues has some changes in, because he's changed some CSS in a CSS file, okay? So let's say that he added a margin of 20px in here. So I'm going to save and commit it to the master. So I'm going to say git add and add those to the staging area. Then we'll say git commit. And the message is add margin to the body selector. Okay, so we've made that commit now. And let's say in the meantime, I'm working on test 3 branch. So I'm going to say git checkout test 3. Now here I am working on this branch and I don't know about that CSS. So I don't know about the CSS changes that somebody else has added to the master branch. I'm working in CSS file. I'm working, and I'll add in a padding property to the body selector, which is going to be 30 pixels. All right, cool. So I like this new CSS feature, and I want to merge this into the master. Okay, so you see where we're going with this. So just to carry on with the example, I want to show you that I will need to make a commit to this branch. So I'm going to say git add to add these changes to the staging area, and then I'm going to say git commit -m, and as a commit message, add padding to the body selector. All right, so now I want to merge to the master. So I'm going to check out the master first of all because, well, that's the branch that I want to merge test 3 branch onto. So let's just say git checkout master. And I want to merge the test 3 branch into the master. So I'm going to say git merge and then the name of the branch, which is test 3. So what have we here? We have a conflict. And that's because the other developer working on our project has been editing the body selector in the master branch while I've been working on the test 3 branch and editing the same selector, right? The body selector. So then we get these things over here. And we also get an error message in here. And the error message says there's a conflict in the styles.css file. Okay, so that tells you which file has an automatic merge fail, and it also tells us to fix the conflict. So it's asking us for help because, well, it doesn't really know what to do right now, because it knows that somebody's changed this body select on the master branch and someone's changed it on the test3 branch. And then we're trying to merge the two together, and Git doesn't really know which version is right or wrong or which version that we want. You know, you get it. So we've got to help it resolve the conflict. I'm just glad that it is aware of a conflict. Okay, so all we really want to do is ask the other developer, hey, do you want to add this margin to the selector? And let's say they say, yeah, we do need that margin in there. So I'll keep the margin in, and I'm going to delete this little comment right here and this thing right here. Okay, so we'll delete that, but we'll leave everything else just like so. And now if I save this and add this file to the staging area, I'm going to say git add to the staging area. And then I'll just do a git commit like so, and now, this time, I don't need to write a message because we're just doing a merge commit. I'm going to say git commit, and then you'll get this screen. So I don't need to do anything in here, but just press escape and semicolon. And you'll see the semicolon down here, then press W and Q together and hit enter. All right, so that's going to exit, and it's going to do that merge for us. Okay, so we can see that just by saying git log -one line. And we can see right here that we've got that merge. All right, now you may come across different conflicts and probably way more complex than what I just showed you, but really the basic bucket of bolts is it's just a case of communicating with who's ever made the other changes and then deciding between what the file should look like where the conflict has occurred. All right, so communication. Then, of course, you can edit it manually and then add them to the staging area, make that commit. So in a nutshell, that's how we merge branches and then deal with conflicts that may arise. All right, so we'll take a break right here and we'll come back in the next lesson. Hello, my friend. So in this part of the tutorial, I'm going to introduce you to GitHub. All right, so what is GitHub? Well, basically, it's a service that's going to let us set up hosted repositories, or as they're known, remote repositories. So it means that our repositories are stored online by GitHub. So anybody with a computer and internet access can go and see the repository online, and they'll have access to the code in it. Now, this helps to work effectively in teams on a project, as well as many other uses you may or may not be familiar with. So for our purposes, let's just imagine that there are 6 developers. We've each got our own computer, and we all want to work on a project together. So we've decided to set up a repository for this project online in GitHub. And we have this kind of central repository which can, well, hold, and then we can all access from our own computers. Let's say we're all on laptops, right? We're not on a network. And then we can clone this repository onto our own computers. That way we'll have a local version of this repository. Then we can all work on whatever code at the same time. So then imagine that one of our developers starts to develop a new feature. So they develop it locally on their computer in a local version, their own local version, right, of their repository. Then when they've finished that feature, they can push that new feature into the hosted repository to update the code right there, just like that. Merge it to the master branch in this repository. So then right after that, these two people, well, they can take a look at this code and say, hey, okay, I'm going to pull that code from the hosted repository to update my local version. So then in this way, they all have the new feature on their local computer and will all stay in sync with the main code base. It's pretty cool, huh? So we can all collaborate on the project in this very same way. So that way we can all work on different features on our own computer and then push up that code, and then the other developers can just pull down the code, and then that's how we can work together as a team most effectively. So that means for you and for me, if we want to start using GitHub, then we do need a GitHub account. So that means you've got to go to github.com and create an account if you don't have one already. And you need to choose a username and type your email and password and click the button. Now, I'm not going to sign up because I already have an account. But after you sign up, you will see a page like this. Okay, so in here, what we want to do is make a new remote repository right in here on GitHub. So I'm going to show you two different ways of creating a repo on GitHub. First way is, let's assume that we already have a local repository or project set up on our local computer, and we made some progress on the project, and then we decide that we want to collaborate with the other developers. So in this case, we want to upload all of that code to GitHub to a remote repository so that other developers, basically around the world, I really do need to emphasize that, can view that code, download it onto their computers, and work on it. Right? So it's not just about having a closed-off select team. So in this first scenario, assuming that we've already started a project and have a local repo, that's what you do. So what about this second case? We'll assume that we don't have a local repo. We've not started a project yet. So what we do is we can create the repo on GitHub and clone it to our local computer. So first, we'll create a repo on GitHub as a remote and then clone that to our computer. Now, typically, I think that it's the best option to create a repo on GitHub first, especially if you haven't started a project yet. Just start there. But I'll show you how both methods actually work in the next lesson. So we'll take a short break here and we'll come on back next time. All right, so in the previous lesson, we talked about a couple of different ways of creating repos on GitHub. So in this lesson, we're going to just create two of them, okay? Both ways, actually. So first of all, let's say that we already have some kind of project and repo that is on our local machine, which we've been working on. Okay, in previous tutorials, you might recognize this. So we've got a project 1, and this is the repo right here, and this is what we want to push up to a new remote repository on GitHub. So just open up your GitHub account and make sure you are on the repositories tab. Now to upload it, I'm going to just click on this new button, but if you just signed up, you might not see this new button. You might see a welcome screen with a bigger button that says create your first repository, and you can go ahead and click on it. Okay, so now we need to give this repo a name, and I'm going to call it Project 1, just so that it matches up with what our local Project 1 is called. Now we can give this repo a description. I'm not going to write I'm not going to write anything in here. But this is important. So the repo can be either public or private. You may select one of these options. Public means, of course, that anyone could see this repository. And we also have this private option. But for now, we're just going to keep it public. Okay, so we can initialize this repo with a README file if we want to. We can add some information about the repository in the README file. For example, you may add some information about the library in your project, how to use it, or something like that. Don't need that for now. So we can also add a git ignore file. It comes with all these different options for an ignore file. For instance, if we have a node project, then we can use the node git ignore file. So we can also add a license if we want to. I'm not going to add it for now. I am going to create this repository just like so. All right, so this is going to set up that remote repository for us right here on GitHub. And it's going to direct you to this page and give you some setup instructions. And you can follow those instructions to set up your repo. So this is the URL of your online Git repository. So I'm going to copy that because I'm going to need that in a second. So you can copy it too just by clicking on this board. So now what we want to do is go to our local repository and push all of the code to our remote repository. Okay. So first of all, I'm going to make sure that I've not changed anything. That, in other words, there's nothing left to commit. And to do that, I'm just going to say git status, and yeah, everything's clean. So now we're good to go. We're good to push this code to the remote repo. So what we need to do is, let's just say git and then push. So that's the keyword for pushing code up. And we say where we want to push it to. So I'm going to paste in this URL because that's the repo that we're pushing to. Go back and get it if you forgot to copy it. Okay, so then we want to say which branch we want to push up. So we're going to push up the master branch. Of course, you can push up other branches as well, but for now we're just going to push it to the master. And then if you click enter, it might take a few seconds or something like that to gather all the code and then push it right up to GitHub. Okay, so then we get a feedback message in here, which is basically saying that, yay, everything's done successfully. So now we've got this new master branch on a remote repository. Good job. So that's it. That's how we create a GitHub repository with an existing project. So let's take a look at the remote repository. If we click on the repository name right here, and yeah, we should see all the code. Pretty awesome. All right, so that's it. Okay, so now let's say another developer could come along to this URL right here and see this repository, and they could see this code. And if you wanted to see, for example, the index CSS file, you could just click on it. And yeah, you can see that CSS. Now, if you wanted to clone this repo to your computer, you can just click this clone or download button and clone it. And I'm going to show you how we can do that. But first, I want to show you the commit history. So when we push to GitHub, that is the commit history of repo. So we can see everything that we've done in the past, and we can then click on each one of these commits to see more information about it. We can also see the branches. If we click on them here, we can see that we have a master branch. And okay, so we have pushed all of our existing code from the remote repo. So now I want to show you something else. For example, let's say that we want to make some changes and then push those changes to this repo. So to do that, I'm going to add just a p tag and say hello world in here, okay? And now let's add this to the staged area. So I'm going to say git add and then dot to add everything. And we're still committing exactly the same way to our local repository, first of all. So we'll commit this with a message, and let's say git commit -m and add p tag. And now we should push this again. So let's say git push and then the repo name. And now we could copy and paste that in again. And then we want to push this to the master. So you might say that every time that we make a push, typing this thing right here could be a little bit painful, yeah? So instead, what we can do is set up an alias in this repository to say what this URL is going to be. So that means we only have to type out one little word instead of this entire URL. So let's see it. Okay, so the way that we do that is by saying git remote. This stands for remote repositories. Then say add, because we want to add a remote repository. Then what we're going to do is give this remote repository an alias. Now the default one in GitHub is origin, and many people use this. So I'm going to use it as well. You should know it. So this is going to be an alias of this repository. So then all we need to do is type in the repository name. So I'll just paste that in, click enter. All right, so that's going to add this alias to the local repo. So now instead of typing git push and then the whole URL, or go back and remember to copy and paste and all that, I can just say git push origin, which is now associated with this URL because this is the alias for it, and then the branch, of course, the master branch. So now it's going to do exactly the same thing, but it's a whole lot easier to push this thing up. All right, so now we've pushed it up, and if we check this out in GitHub, refresh the page, we should see that, yeah, whole commits are in here. So let's click on commits, and there is add p tag right in here. Okay, so we've pushed it up to this remote repository. We've updated it. Now other developers can see all those updated files, just like they ought to be able to do. Perfectamundo. Okay, so we've said that we're going to learn two different ways of creating a repo. So the second method, let's assume that we don't already have a local repository. So let's now create a new repository. So first of all, I'm just going to go to my profile, and then I'll go to repositories, create a new one. So we're going to do the same thing again. I'm just going to give this repository a name. So I'll call this project 3. And again, I'm not going to add to this description. It's just going to be public this time as well. I'll add a README file. So I'm going to click the create button, and it's going to do exactly the same thing. All right, so we have this README file and just one commit, the initial commit to add this README file. All right, great. So now we only have one branch. That's the master branch. I'm just keeping it simple for now. All right, so what we want to do is this. We want to clone this repository to our local computer. So to do that, click this button right here. And again, this is the URL right here to this remote repository. So you can click this button to copy it to your clipboard. All right. So now I'm going to close these files. And now I'll go back inside the terminal. I want to go up a directory because we're creating a new repository, right? So let's say cd for change directory ... to go up a level, and then I want to clone my repository. All right, so to clone the repo, we'll say git clone, and then paste in the URL that we copied from the hub, and this is my remote repo that you saw me and hopefully you made as well. Cool. So now we've got project 3. We can navigate into that by saying cd project 3, and now we're inside this repository locally. All right. So we've cloned it to our computer, and we can see this repo right here. Okay, great. So let's make some commits to this and upload it onto GitHub. So I'm going to right click over here and add a new file, index.html. Let's add an HTML template and add a title. And I'll just save that. And then down here, what we want to do is add this. And we'll add and commit this locally first. So I'm going to say git add to add it to the staging area. Then git commit with a message. And the message is going to be add index file. All right, so now we need to push this up to the remote repo. Now, remember last time we had to specify an alias for the remote repository. So we had to say git add remote, then origin, and then the link to the repository. Now we don't have to do that, though, this time, because we've cloned it from GitHub, and this repo already has set up the origin alias for us. So that happens when we clone it. Now what we can do is push up to the origin because it's already stored here. So that means I'll say git push origin. And we want to push it to the master branch. And then this is going to take this master branch and push it up to the remote repository. All right, perfect. So let's check out the repo over here. And if we refresh, now we can see that updated commit. All right, so that's how you set up remote repositories on GitHub. We'll take a short break right here, and we'll come back in the next lesson. Hello, my friends. So in this video, I want to show you how we can collaborate on GitHub. So in the last tutorial, we learned how to set up a remote repository. And we also cloned that repository onto our local computer in two different ways. So we had one computer, one local version of our repository, and we also had a remote version of that repository. And then we could push our changes from the local version to the remote repository. All right, so that's really good, but I didn't show you how we'd work in a team on GitHub yet. So now let's say there's only me right now, so I can't show you exactly how all of us would work as a team. But what I am going to do is show you how to, I'm going to show you a typical workflow that I'll do in the office if I was working on GitHub on a project with about so many other people. All right, so the last tutorial, we made this repo on GitHub, and we cloned this repository to our local computer. So now I want to, so let's say that this is a project that I'm working on in an office with 3 other developers, and we're all using this remote repository. So I've got this repository cloned on my desktop. And let's also assume that I come into the office and I've got some new work to do on this project. So the first thing I'm going to do is I'm going to make a pull to keep my files locally up to date with the remote repository, just in case any of the other developers have made any changes. So to do that, what I'll do is first make sure that I'm on the master branch, because that's where I want to merge to. So to pull the master, what I'm going to do is I'm going to say git pull, and then I'll say the origin, because that's the alias, right, that we're pulling from the remote repository. And then we're going to pull the master branch. So what git pull does is it fetches all of the code from the remote, and then it merges it into our local master branch, right? Because we've said master right here. All right, so we are on the master branch, and it's going to pull the master branch from the remote, and it merges it into our local branches, and it updates all the files. So in this case, no one has made any changes, and everything's already up to date. So then that means the next thing that I want to do is, if I was working on a new feature, I should just check out a new branch, because I want to preserve the master branch, right? I don't want to edit it and then mess it up for everybody else or myself. So to do that, I'm just going to say git checkout-b for a new branch, and I'm going to create a branch called test.html. And then what I'm going to do is just add a little bit of HTML. So I'm going to create an HTML template. And inside of here, I am going to add an h1 tag. And inside it, let's just say that this is a test file. All right, so now I'm going to save it. And I'll add it to the staging area. So git add, and then I'll say git commits, because we are going to commit this branch. So the message is going to be add test HTML file. Cool. So we've made that commit, and now what we want to do is take this code and we want to push it to the remote repository. Now what we don't want to do is merge this into the master branch locally and then push up the master branch, right? Because if we do that, it's going to override the master branch on the remote repository, and the rest of my developers might, they might not like that too much, we'll say. Because they, might not actually agree with the code that I've done, or, there's all kinds of reasons, but you understand the point. Ideally, what we want to do is push this branch up to the remote so that my other colleagues can review that code, and then they can all decide if we want to merge that into the master branch on the remote repository so that everyone can download and pull from the master branch on their remote repositories to update their own local files. So that means what we're going to do is push up this branch. So to do that, I'm going to say git push, and then I'm going to say origin, and then the branch name that I want to push up, and that is test.html. Cool, so that is going to push up this branch, and we should get feedback in a second. Okay, so all that's done. Now we can check out the GitHub repository. All right, so we can see right here, it has been auto-updated. Now what I'm going to do is just click this button and compare and pull request. And that just means that we're going to compare the differences between these changes and the current state of the master branch. Then we can make a pull request, which means we want to merge it into the master branch on this repository. All right, so let's do that. On the next page, this is the message that we added to the commit. And we can also leave a comment if you want to explain exactly what you've done so that the other developers can read that and be pleased. Then we can create these pull requests. So I'm going to create this pull request, and that means that I'm putting in a request that I want to merge this branch into the master branch on this repository. So when I do this, all the developers are going to get a notification, and they're going to come and see this, and then they can review it. So we can assign reviewers right here. Currently, I'm working on my own. But if you were working in a team, other people would show up here, and you could assign one of those to review your code, or all of them, whatever. They could come down here and they could read this, and it says this branch has no conflicts with the base branch. It's a good sign. So there's going to be no conflicts if we merge this into the master branch. And if they wanted to write a comment about this code, yeah, they could do that right here. And I'll just put excellent. And then the comment shows up here. Now you could go down here, you could see the commits that I've made and the files that I've changed in here. So you can come in here, and all this green stuff is what I've added, and the red stuff is what I've deleted. And they can see all the changes in the code. Now, if you wanted to, you could add in a comment here, line by line. If there's something that you don't agree with, or that your team doesn't agree with, they can just add that in a comment in here. Okay, so then if we're all happy with this pull request, let's say that we are, we can go back and merge this pull request to master. So now if we merge it and confirm the merge, that's going to take this branch and merge it into the master branch, right? So if we wanted to, we can delete the branch as well because it's already been merged, right? Okay, so if we now go to project 3 to see the code, we're going to see this test here. So now we've updated the master branch. What do you think of that? I think it's pretty cool. Okay, so imagine that a few hours later, someone's been on to the code and they've seen that you've, I don't know, missed out adding a paragraph, let's say. And they say, hey, you need to add some text in. Can you do that? And I'll say, okay, then what I'm going to do is start a new branch. But remember, before I start in a new feature, I always need to pull down the master branch just in case anyone's made any changes. So that means what I'm going to do is go to my master by saying git checkout master, and then I'm going to say git pull origin master. So this time it's going to pull something down, and we can see that, yeah, we've got some changes. So you can see it's updated the test page, and the change that I made in the last section where I uploaded that branch, that has come down to me. So we've updated that, and it's always good practice to update the master branch first of all before creating any new feature. Let that sink in. So to add that paragraph to the test page, I'm going to create a new branch. I'm going to say git checkout -b, and I'll call this branch add text. Now we need to check out the add text branch. So I'm going to add some text to this page. So I'm going to create a p tag and paste some lorem ipsum text in here. So let's save all this and add this to the staging area just by saying git add. Then commit this, git commit -m. As a message, we'll say add some text to test file. Now we can push this to the master. So I'm going to say git push origin add text because we are on the add text branch. You follow? Okay. So now we can go and see it on the remote repository. So let's refresh the page. Okay, so it's in here. Now we can create a pull request for the other developers to review our code. So let's click this link to create a pull request. And we've got a title here, and we'll add a comment in here. I'm going to say, hey, I've added some text to this test page in this pull request. So we can save it, and we can now create pull requests. Okay, so now let's say that we're completely happy with this change. We can merge this back into the master branch. So that means I'm going to merge this pull request, which is going to take that text and add that to the master branch like so. And then we can also delete the branch, and you can keep it so you can refer to it in the future, but I'm just going to delete it here for now. So if we go to the code now, you can see that right there on the master branch. All right, so that's typically how we do things on GitHub, right? So now you've got a whole bunch of new methods. That's cool. But to sum it all up, I am pushing up my branches, and then if we are happy with that and all those changes on my remote branch, we merge them to the master. Then my other colleagues, they can pull down the master branch to get any updates that I've merged into the master. And they'll be getting those updates in their local repository. And then they can be working on it, or maybe adding other features on it, or pushing it to GitHub on a different branch, whatever. But in this way, we are doing different updates, and we can all work on things at the same time very, very easily. All right, my friends, that's how we collaborate as a team, in a team, for a team. It's how we push and we pull code from GitHub, and it's the way that we work in branches. All right, so there's a lot here. I hope this course helps you a lot, and that's all for now. I hope to see you in another tutorial, and keep developing.